All right, good morning, everyone. It is Sunday, October 11th, 2020. We are back again here at VCF East virtual show. Yesterday
Yesterday
was a
was a great day. We had a lot of great speakers, presenters, classes. We had all these people on Discord. It was really exciting, really fantastic. So, again, we're here at the Computer Deconstruction Lab. Uh, that's a group that they have a nice setup here that they let us use.
Have
And
a nice
we
setup
also
where,
do our
Jeff?
repair workshops in this area. They do Facebook Live every Monday at 7 o'clock. It's part of this whole campus is InfoAge Science and History Museum, so you guys should come visit it. This is where we have our Vintage Computer Federation Museum. Lots of history. Yesterday uh, we had someone talk about the history of Camp Evans, which was the original name for this location, as a rich history with Marconi, Cold War research. So it's a great place to visit. All right, so our first up
Oh, real quick.
is
Let's talk about shirts. Before
So-
we get into speakers,
before we get into speakers, a quick look at their T-shirt here.
this is
Chris
something I got
Falla.
from Radio Shack when recently, which is the only good thing they're still selling. And then this one, woo! Talk about this one, Jeff.
All right, so this one is from VCF East 11. I believe that was. What's on the back of it? All right, so that's just an advertiser. So let's look at it on the front. So this is VCF East 11. I think that's maybe 4 years ago. So it has the Computer Chronicles desk.
Stuart Chaffee.
Stuart Chaffee. Yeah, I was going to try to remember his name. He was a famous guy who did the different computer shows in the 80s. And I remember that. Was that Ted Nelson?
I think that was Ted Nelson.
That's Ted Nelson. And then the other guy, I don't remember.
Who designed this shirt? Was this a Dan shirt?
So yeah, Dan Riganti was our designer of our T-shirts. We had shown one of them yesterday, and that's one of his designs. It shows Camp Evans in the background there, and the satellite dish, Diana satellite dish, computer lib, because that was Ted Nelson, and a little fun stuff with a little walking floppy disk and looks like little miniature computer guys there. So anyway, we wanted to show off.
Load Runner people.
All right, that's Load Runner. All right, so we just want to show that T-shirt. Our first video is Serial Terminals, New and Old, by Eric Siegel and David Hunter. And Andy's going to start playing it. All right, ready, Andy?
Yep.
All right, let's go.
Hello, I'm Eric, and this is Dave, and we're going to be showing off a whole bunch of serial terminals and serial tricks you can do, and talking to different machines. And, sometimes your machine or your mainframe is nowhere near you, and the only way to talk to it is with a terminal, over far away. Maybe back in the day it would be miles or something away. Now it's, 5 feet away on the other side of the room, but still kind of the same thing. So, okay, so speaking of old serial terminals, this thing here is an IBM 3151. This isn't that old. This is from like the 90s or something. It's not like an 80s or 70s terminal. This is from like 91 or something, but still significantly older than the machine that it's talking to. Machine on the other end here is just a fairly modern Linux server, like a Synopteron, maybe like 2013 or something. So way newer, but hey, things still have serial ports. Things can still talk over serial, so I can still log into this thing over serial. Oh, that's not my password. That's my password. And this IBM is actually running in WISE mode, so I need to set it to WISE, which should be my new terminal type. Yep, WISE60 in crazy 25 by 132 mode. People have been hunting for like 80 column mode. This is 132 column mode, even better than 80 column mode. And so, whatever you want to do over here, I can run Vim over this thing, which before I set this up, it was running in the wrong terminal mode, and Vim just wasn't working at all. This would just be all garbled. But with the correct terminal, sends the correct control characters, or at least tries to send the correct control characters, and I can run things from here. Having a serial terminal on my server is actually pretty helpful, because you ever lock yourself out of a SSH or something, or skew something up, and this is sometimes faster than having to get a keyboard and a monitor connected to the actual server. I connect it over a single cable, to this machine, and I can do whatever I want with this. Oh, well, right. I need to not save that. In case anyone's wondering, the other end is a Opteron. It's not telling me because LSCPU is glitching out, but whatever. It's a fairly modern system, but anything with a serial port can still talk to anything over serial, regardless of age. I apologize if this footage is really shaky. I'm now holding the camera, but over here is a AT&T Unix PC, which was made in 1985, purchased by the Rochester Institute of Technology in 1987, and then sold to a prospective student who never actually used it because I bought this thing a few years ago, still in its box, and never used, from his wife after he had passed, and the wife was just selling a bunch of old computer stuff. Why this is here is because this is actually running as a serial host as well, to sort of show off how anything running over serial can just talk to anything else running over serial. So let's say you wanted to do Unix work, instead of being at the actual machine, this can be hidden somewhere in your server room, mainframe room, or just in another room in the office, and you can talk to it from anywhere else.
Okay, so for a more modern take on terminals, what I've done is, this is a board I designed. It's based on a design by Jeff Graham in Australia, and I designed it for two different modes. This is this typical mode where it's a PS2 keyboard, VGA output, and then I have another mode which can use an Adafruit LCD SPI adapter, and I use some mini DIN connectors that I had sitting around for outputs. So what we have here is serial out going through a string of adapters, a null modem, and a tester over to the Unix PC that Eric just talked about earlier.
Yep. And the Unix PC also only has a 25-pin serial port, so it's got to go through a number of 25-pin and 9-pin adapters to get back to a 9-pin serial.
So we have a serial port adapter, and now we're using a modern take on a VT100 terminal with an old vintage computer.
Yeah, since serial can run over pretty much anything. Unfortunately, the AT&T machine only runs at 9600 baud. It runs slower than that, but I can't run it any faster than that. But I mean, for most things, text-based anything, 9600 baud is probably fast enough. I mean, when you need to send data over a serial line that fast, that's a bit ridiculous, isn't it? Not just for fun, I could build terminals together because why not? So if I type something on here, it appears on the other one. So why would you do this? This is a good way to mess with your friends, you know? You just do something like, you know, suddenly it's typing out of nowhere and you can't see where it's typing from. You know, I mean, probably would never actually do anything like this in the real world. I can't see why you just connect two terminals together because they're both dumb terminals. They have no storage. Is there any reason you would actually do this other than because it's fun? Maybe to control something? Like you could probably do like I don't know, send commands to another terminal and have it do something on the other end if you had something connected to it. I don't know why you'd do this, but you can because it's fun. Anyway, I guess that's about it. Just showing off two different serial terminals, modern one and old one that can talk to each other just fine.
Back everyone. That was Eric Siegel and David Hunter. Am I pronouncing that right, Eric?
Yep.
All right, great. So that was serial terminals, new and old. It was kind of interesting. can you guys tell me a little bit about how you got the idea for this project and how you created it, put it together? Eric, do you want to go first?
Yeah, I mean, I don't know. I just like messing around with like serial things. Like I have a media server set up in my basement, and it was just like sometimes it's easier to connect to it via like a terminal versus trying to like find a keyboard and a mouse and a screen and all that stuff and connect it to the system. And then it was sort of like, I don't know, what else can I connect it to? It was mostly also to show off the AT&T machine. I actually was using that as a terminal for the longest time until I got a proper like actual terminal that isn't a computer, like a proper dumb terminal. And then David was like, oh, I made like a little terminal board, and I'm like, that's neat. Can I talk to it? Let's see if it works if I can talk to it.
Yeah, that's pretty cool. David, you have anything else you want to add, like how you got involved with this?
Yeah, I like playing around with little computers, and I've made some retro computers and other things. And I thought it was kind of silly to have my big fancy PC running a serial terminal to a small, 8085 computer. So I thought, well, looked around for terminals, and I found the one from Jeff Graham, and it uses a PIC32, and then I just modified it to kind of my own needs. Took out the USB port, added in a TTL based port and other things, had a board made. So that was kind of the idea there.
So did you guys have other ideas about like how you could extend this demo, this project, and add other things, add other machines or terminals? You have ideas about something you might do in the future?
I had a whole list of like different ideas I wanted to do. I just think I ran out of time thinking of ways to set things up or didn't have the right like equipment or stuff. I don't know. Yeah, there was a bunch of stuff I wanted to do, but I just never got around to it.
Tell me, well, then why don't you just elaborate and tell me what you plan on doing when you do have time? What kind of things did you want to do?
One of the things I wanted to do was somehow try to make some sort of like game or some sort of way to like connect different terminals together in some sort of like meaningful way. Like I know you can copy like obviously files and even data over like serial or maybe even just characters, but I wanted to do something like where you'd have like a separate controller running like some sort of game talking to each of the two different terminals of like player 1 and player 2. I don't know. I want to do something like that. I just never get around to like making it or designing it, but that was an idea I had. I'm sure you can do something like that. Some sort of central system communicating with each terminal as like player 1, player 2, and have some sort of game between them.
All right. It looks like Chris has a question from the Discord. What do we got, Chris?
Stephen Edwards asks, what microcontroller or whatever is at the core of your modern terminal?
It's a PIC32.
Thank you.
Thank you. Thank you for the answer. Are we out of questions or?
I'm sure.
All right. So let's wait 1 second. So after these guys, all right. So that's all the questions we have right now. Eric and David, I really appreciate you doing the exhibit. That was very fun. Sometimes when you're the first guy on the list, people are still waking up. So just monitor that Discord channel, because I'm sure people are going to have to ask you questions about it now and later. That sort of happens. So like sort of throughout the day, hours later, people are still chatting in there, and it's really great. I'm glad that we have that facility for them to communicate and continue the conversations. So thanks again for doing that exhibit. It was wonderful, and hope to see you again live, hopefully in April when we have our hopefully in-person show.
Yep, thanks. It's been great.
All right. Have a good day, you guys.
Thanks.
See ya.
So next up is Tanner Collins, and he's going to show off his flight simulator, and it has some vintage computers connected to it. And are you ready to go, Andy? Mm-hmm. All right, let's go. Make it so.
Hello, my name is Tanner Collins. I'm a flight simulator technician here at Flyrite, and this is our Dash 8 full flight simulator. So this simulator was built in the late 80s and early 90s, and began training probably in 91 or so. And as a result, it ran off the best computers that they could get at the time. And so here we have, this is our host computer. It's a IBM Power Server 530, and it runs most of everything in the simulator. All the instruments, flight controls, motion, everything. And these two are Silicone Graphics Personal Iris 4D25s, both of them. And they run the instructor's operating station that the instructor would use to reposition the airplane and put in malfunctions and all sorts of stuff like that. So here we got our host terminal here. It's where I would start the simulator program. I'll show you an example of that. Let's see. So it's run through this, and all the software on this thing is proprietary. It's all, this simulator was made by CAE. I think it stands for Canadian Aviation Electronics, something like that. But all their software is proprietary. All their electronic boards are proprietary. I'm about to show you that in a second. But, so basically, to load it, just type in 300. Because this simulator is built as a Dash 8 100 and a Dash 8 300. We always train it in the 300. That's what all our clients ask for. So it's just running, doing the load up sequence. And this is a spare iris I've been working on. This is my Raspberry Pi that I made, and he does a lot of things. Initially, I wanted to replace these old terminals because they are expensive, and I'm trying to get a replacement or something. So I wanted to find a cost-effective, modern solution, and I did. Basically, uses a MAX 3232 chip, and to convert the serial to the level that the Raspberry Pi uses. It's got everything oriented on this hat here, so I can solder it all together. Those two switches you see actually swap transmit and receive. They're meant to be moved together. I just didn't have the right switches at the time. And the two transistors actually they actuate the loopback handshaking. So in the software that I made for the thing, well, not software, the script that I made for the thing, when it kills screen, which is the application it uses to talk to it through serial, it will break the loopback handshaking connection to make the host computer think that you've turned the terminal off, so that when you kill it, it will come right back to the login screen. I wanted it to emulate everything that these terminals did. Sometimes we gotta turn them off and turn them back on. We always start up on the login screen, so I wanted to do that. Raspberry Pi talking to a very, very old computer. And it works. It seems that this host computer really likes VT220s, so thankfully Screen will emulate that and find, select, previous and next page. They all work. I'm not 100% sure about them PF buttons. I haven't really used them too much. You mainly use those in the editing software. But let's see here. We got two hard drives running the host computer here. Let's see. And then our 2 irises here. Like I said, they run the instructor's operating station, which I'll show you here in a second. They take their 3 B&Cs from the back. We can see there, red, green, and blue. And they run them about 75 to 100 feet up to the simulator in there. There's our 16-port splitter for the host computer, and the isolation boxes. There they are. There's one of them. The newest computers that you will find on this thing are right here. This is the visual system here. It used to have a lot older computers on it, and it ran proprietary boards for pixel processing, texture processing, stuff like that. Ran off really, really big projectors, had multiple lamps each. Now it just runs off of this here. There are 6 projectors you can see up there. Those, I think you can only see 2 right now, but there's 6 mirror arrays in there, and they make up the image that you see out in front of the cockpit. So, but yeah, these were this was done in 2012, and they run off GTX 580s. The host computer, it doesn't run all the instruments and stuff directly. It actually runs all these blue cabinets here, and I'll show you. So you've got 4 Ethernet transceivers here, and that corresponds to each one of these buckets. Now behind these covers here, big racks of cards. One card controls the communication with the host computer, and all the other ones do various things wherever it needs to do. It seems to me, you can't quite see, it's kind of dark. This, all these, every single one of these is a digital out board. Takes a 28-volt signal and runs it through all these little relays, mercury read relays. And these are those proprietary boards I was talking about, all made by CAE. They still use them to this day. Here's our DM1 cabinet. It controls the motion and the controls as well. Runs an EL screen, probably made by Finlux or Planar or something like that. We got our hydraulic pump room, a big metal room over there. You get to it from beyond those stairs there, just right across right toward the wall. And yeah, motors on here. Simulator runs off of the oil is not warm, therefore throws a failure, and that's something that'll happen until the oil warms up. So I'll get you a shot of the back here. That's where all the cards plug into. This is the back of one of those buses. You can see there's a lot of wire wrap there. The common ground and 5-volt lines there, as well as 28-volt. There's another one. Power supply in there. A little dark. Lambda power supplies, a ton of them. You can see there's a replacement for one right there. anytime something crazy happens with this sim and it's not working right, more than likely a power supply has gone bad somewhere. We gotta figure out which one it was. And that can take quite a while. But as long as you keep these things on, they're fine. You turn them off, that's when things start going bad. Looks like a duck, quacks like a duck, you know, flies like a duck, everything. That's what they went by to make it one-to-one with to make it as close to one-to-one as possible to the real thing. And so this is a level C simulator here. According to the FAA, that means it's approved for certain types of training. So here we are inside the cabin here. Cockpit's dark, visuals aren't up. And we have loaded the simulator, but we haven't run it yet. So I type in SimX, which stands for Simulator Executable. All right, run. There it is. You can see everything light up here quite a few times until it starts. We know it starts because flight free is right there. Well, first off, it loses its box, and then it will regain its box, and it will be colored in completely orange. So that's how we know it's done. Very dark. Can't see nothing there. Let's see here. One thing I didn't check downstairs was whether the visuals were loaded or not. That's done on the visual server computer. So while that's going on, these right here are the instructor's operating station I was talking about. You can see you can change all sorts of stuff, lighting, time of day, weather, which is really fun, your airport. You can reposition the airplane to on the runway, at the gate, whatever you need. The ATIS. We also run our tests here. I call them QTGs, Qualification Test Guide, I believe is what it is. And run it through here. And as I said, these are run, these iOS stations are running on the SGI personal irises. So they're a little old, runs on 3.3.1, I believe, version of IRIX. The visuals are up, coming up one at a time here. And I'll blink a little bit. One of the issues we have with the particular projectors that we use is the projector optical block likes to yellow. And that's very apparent right in this one. This is our worst one here, and we got to send them off to get repaired, to get them replaced. So some are better than others. You can see the colors off on just about all of them. All these, the whole iOS application was made on a proprietary program that they got called GE. That stands for, get this, graphics editor. Yeah. So all the functions, like when you press a button, it'll go to a new page. All that stuff set up through there. And I actually ended up making this startup screen here for us. We'd been wanting to do it for quite a while. I used to say US Air, which is who we bought it from. We bought the simulator from. Due to this thing being so old and our limited documentation we got, and software, we don't have all the software for these things that we need, just enough to run it. You just touch it, and there it comes. Comes up with the map. We're at KCLT. Yeah. And the thing runs pretty good. A lot of questions I get, why don't you update to modern computers. Well, if we did that, for one, it would cost a lot of money, and there would have to be some sort of ability that we would gain to make money if we invested in that. So it runs pretty fine right now. Let me turn the cockpit on here. These parts are old, and not a lot of people have them anymore. If we lose an instrument, we pretty much got to go on eBay, because one thing about the aviation industry is parts are very expensive because they have to be certified for airworthiness, and that comes with a cost. So we don't have to worry about that, being a simulator shop. So we can open these things up and work on them and do what we need to do. These aviation electronics can get pretty complex sometimes, but we do all right. We do all right. They're built very well too, so they don't go bad often. The main things we change are light bulbs. You can see up there. This thing's close to 30 years old at this point, so there's some discoloration going on. Things are burnt out. Well, the lights aren't burnt out, and you can see permanent heat discoloration there. Yeah. Paint's chipped. Things are worn, like that park and brake handle there. Very worn. It's got character. That's what they would say. Okay, so here's part 3 of my little tour here. We're going into a turn, about to come in for a landing. So one of the biggest parts of my job as a simulator technician is to, before any training happens, I have to come in here and I have to pre-fly the sim. And what that entails is making sure that everything is working as intended, nothing's wrong, no light bulbs are burnt out, and also wiping down the sim. I got my Clorox wipe here, and it's always been a big part, but especially nowadays with COVID and everything, I gotta really make sure that I wipe down every surface. So a big question that I get asked about working this job, well, as a byproduct of this job, I learned how to quote-unquote fly a quote-unquote plane. I've never flown a real plane. I've only ridden in a real plane just a few times. And let's see, we're a little high here. Let me write this down here. Bring the speed down. Vertical speed down. And catch the glide slope there. Really bring my engines back, because I'm going just a bit fast. Actually, no, I'm not anymore. Alright, now this is what you would call a very steep approach. In fact, most pilots would not attempt to land this. Due to time, though, I probably will. Now, need to do a few things. I don't know, it's getting a little hairy here. Let's see. I can probably do it. Might have to make a spin here. It's hard to do it with one hand, though, is the only thing. So let's see. Let me take a turn. Make sure that I don't go under speed and fall out of the sky. Keep the yoke up with my knees so I can push the engines up a little bit. And I'm still losing a bit of altitude, or a little bit of airspeed. I'm sorry. I want to lose altitude. The airspeed I want to keep. This is pretty good airspeed right here. As long as I don't dip too far under this, end up stalling out, crashing. But yeah, so people ask me all the time if I could land a real plane, and to be honest, I probably could. Through the 2 years I've been working here, I started when I was 23, I'm 25 now. 2 years I've been working here, I have, as a byproduct of me doing these pre-flights, I've accrued hundreds of hours across the 5 sims that we have, and I've completed hundreds of landings successfully.
Minimums.
I've
Too low. Flat.
I haven't really
Too low.
crashed them too many times, believe it or
Too
not.
low. Flaps.
But the hardest part about flying is not the maneuvering of the plane, I don't think.
20.
There we go.
10.
Yeah, there we go. It's not the maneuvering of the plane, it's really the what to do in emergency situations, like if you got an engine out. Flying when you can't see out the window. Just flying by your instruments, navigating that way. That's the real hard stuff. Knowing all the different speeds that you should that you will stall out in, because it's not just going too slow. You can stall out a specific wing or a specific control surface, and you stall out a wing, you'll spectacularly spin to the ground. So that's the scary stuff, and that's stuff I don't know. But as long as you keep it going pretty fast, you're all right. But anyways, so yeah, I could probably land a plane if I had to. I hope I'm never in that situation. But if I had to, I'd definitely try. But anyways, so one of the biggest things about simulators is what's genuine and what is simulated, right? So in terms of avionics, we have genuine avionics in here. Most of the main ones, like this ADI and this HSI, I might have got those backwards, but vertical speed indicator right here, the altimeter, airspeed over there. Those are probably all real, genuine instruments driven by real, genuine flight computers that are fed simulated data. So I know this panel here is real. This one here is not. Oh, this one here is not. Any pneumatically driven instruments, as well as this one here, this is a simulated instrument. So is this. The wet compass here has got to be simulated, because I'm not actually moving around, you know. I'm not actually facing north, faces the same direction. That guy there, that slip ball in there, that's usually just a ball and some fluid, but our sims have motion, but so you can feel the g-force when you take off, a simulated g-force, probably not one-to-one, but anyways, yeah. Some instruments are stimulated and some are simulated, so there's that distinction there. All these engine gauges here are genuine. These computers here, or well, the FMS here and the weather radar, those are genuine. Yeah. So the control panel there, the autopilot control panel, is a genuine instrument. Most of our comms down here, all genuine. And that's our vintage flight simulator here at Flyrite in Concord, North Carolina. Thank you.
Right, welcome back, everyone. That was really fascinating. Not exactly about vintage computers, but it's still in the same realm, and I think a lot of people really enjoyed seeing that, because it does have vintage computers running that flight simulator. So that was Tanner Collins. And so Tanner, how did you meet up with Andy? How did he find out about you and your flight simulator?
Well, I ended up posting on. I sought out the Silicone Graphics user group because I had some questions about our personal irises, and also had some old proprietary confidential documentation about our particular ones. And I scanned those in and uploaded them. But anyways, yeah. So I started talking to people on there about it, and then he asked me to share.
Oh, yeah, great. That's fantastic. And it's just funny how we can make different connections in different areas and into different things that will be interesting to our show. All right, so Chris has a question for you. Chris, what is the first question we have?
So the question is, am I not on mute? Am I on? Okay,
I can hear you.
good. What plane is the interior simulating?
It is a de Havilland Dash 8, and it can be a Dash 8 100 as well as a Dash 8 300. Dash 8 100 is a little smaller than the 300. And they fly different, but in terms of the cockpit, they're similar enough that we can swap out a few things and provide our clients Dash 8 100 training as well as Dash 8 300 training. But as a whole, generally we keep it in 300. We rarely have Dash 8 100 clients anymore. So, yeah. I'm sorry, Jeff. I can't hear you.
Oh, all right. Sorry that I mute myself when Chris is talking. So that seemed to be like a very professional simulation machine. How does that compare to some of the? I mean, I'm not sure if you're familiar with it. Some of the vintage computer flight simulators, because they had the flight simulator game. I guess you could call it a game for the personal computers. And how does it compare to some of the older ones and maybe some of the more recent ones that are on desktop or vintage computers? How does it compare to those?
Well, in terms of the flight simulator games from back in the day, it and the new ones as well. It in some respects it blows them right out of the water, and in other respects, for instance, the most recent Microsoft Flight Sim 2020, the graphics that you see out the cockpit in Flight Sim 2020, they're way better. But in everything else, even with the most elaborate home cockpit, generally it's going to be, because the sim is designed to be as close to one-to-one as the real thing. So it's got to really feel the way that it flies when you put your hands on the yoke and everything. One thing that I find when I'm playing Flight Sim 2020 is that the force feedback on the controls is not there. So you can really push on the yoke really hard, and it will. You can nose down, and in reality, that's going to take 20, 30 pounds of force depending on how you got it trimmed. So and feeling the wind underneath your wings, and that affecting the weight you got to put into moving the yoke and the rudders and all that. The motion is probably the biggest thing, because it's amazing how when you're in there, how your eyes can deceive you and your brain can deceive you into thinking that you're actually flying. Because when you see the sim tilt up like this, you're accelerating, and that's emulating the G-force that you would feel. And then, but when you're in there, you would have no idea that you're like this. I mean, you would know you're like that, but your eyes would trick you into thinking that you're laying flat, but you're going fast. So it's just amazing, and there's everything from taking the landing gear up and feeling the buffet of when you're when it comes into the plane and retracts and closes the doors. You feel that. Flying through thunderstorms, that's fun. Goodness gracious. I tell you what.
Yeah, that must be
Sometimes.
scary. Yeah.
Yeah, it's I would be terrified if it was real life, but man, I sometimes I would if someone asked, I would say I was testing the weather radar, but what I was actually doing is putting in a giant storm and then just going right through it and feeling, man, it just pushes you all around. I mean, you're going all over the place. It's wild and it's fun.
All right. Thank you. That was a good answer. I like that. So Chris had some comments. We don't have questions, but he wanted to say a few comments that we had found in the Discord.
So
Here we go. Nice things to say. Brilliant demo. Thanks a lot for the presentation. Fascinating stuff. Thanks. This is a fantastic demo. And then we have things like, oh, actually, this is a real question. Can you land a real plane?
Probably. I probably could. I hope I don't have to. If I was in the cockpit of so we have a Caravan C208. We have a couple Beechcraft 300 and 200s. So if I was in one of those, most definitely. I've got hundreds of hours in them. From the 2 years that I've been working here.
In the sim or in real planes?
In the sim. Now, when it comes to our sims, we have a couple that are level D, and according to the FAA, a level D simulator is as close to the real thing as you can be, and it counts as flight time for pilots, so they can put that on their flight logs and count that as real time. And that's most of our sims are level D. We got 5, and 2 out of 3 of them are. So,
Cool.
yeah.
So we have some warnings here. Please be careful opening the overhead compartments as the contents may have shifted during flight. And
Yeah.
then somebody said, is he going to crash the plane on landing? Nope. And just watch out for those buildings in Melbourne.
I don't get that one.
I don't either, but yeah, among others, it's just some guys really enjoyed it. Lots of chatter in the chat about the demonstration. It looks like it was very well received. So thank you.
Yeah. Oh, good. I'm glad.
All right. Well, looks like we're out of questions and comments. I thank you, Tanner. Do you have anything else you want to add to what you what the system may have there, or?
Yeah. Some interesting news about our host computer here. I'm not sure when the last time somebody installed some software on it, but I recently installed some new software on it on IBM AIX 3.3 something. I installed rsync on it, so it's got rsync now, getting up with the times, and I installed RSH into the Raspberry Pi, and I was able to remote shell in, and I don't know whether it's a product of the R shell on the Raspberry or something that is not set on the host for when it comes to how it behaves with the serial terminals. But I'm able to use like tab autocompletes and a lot of the modern amenities that you'll find with Linux prompts today. So regardless, that makes me happy. Yeah.
All right. We do have another question that
Oh,
popped
good.
up. So Chris will ask you another question.
Okay. Lost it. Where'd it go? The boards with relays, are those all digital controlled outputs going to the equipment?
Yes. So each bucket has a microcontroller card that connects to the Ethernet transceiver, which in turn connects to our host computer. Ethernet, it's the old 10 megahertz, I think, or 10 bits, megabits. That's it. Connected in the BNC loop, and so the microcontroller card talks to all the rest of the cards in the chassis. It's a lot like VME bus, actually. If any of you guys are familiar with that, it's a lot like VME bus. So, yeah, and there's all sorts of those cards in there. They do all sorts of things. when it comes to fixing these things and these cards, since they're proprietary, if one of them goes wrong and we don't have a spare, we just got to figure it out. And I can't tell you how many times I have successfully troubleshot these things by removing socketed chips. That seems to be that's huge. It's huge. That's that. In fact, that's one of my. It's low on the troubleshoot list on the steps going through. So yeah, and these and another thing is if one of these power supplies dies, these Lambda power supplies are about 20, 25 years old, some of them, and if you turn them on, there's a there's a good chance that eventually they're not going to turn back on again. But as long as you keep them on, they're great. So.
So yeah, that's something that's true with a lot of these older machines. Like we have a UNIVAC 1219B, and you turn it on, and then it's like different error messages. Why is it not working? So then after a few hours, all the errors go away. So it's like, why is that? Oh, because you have to leave it turned on. You're supposed to. It's designed to be on all the time, and we don't want to waste electricity. Not that it uses a heck of a lot, but you still want to save it because we're using this place. So that's the problem. Is that yeah, some of these older systems they're designed to be left on all the time.
Right. Yeah.
Believe it or not, it actually works better. There's various reasons for that because it has to warm up, and certain components have certain properties to them, and it's better for them to be on than to be warmed up.
Yep. A little clarification, the Melbourne joke. Flight Simulator 2020 used public and government data to make the towns, cities, landscape, buildings, and over time, people are finding glitches where buildings are entered wrong, like indicating something like 200 stories instead of 20 or 2. As a result, massive buildings will show up in the sim. So that's interesting. That's why I guess you look out for those 200-story buildings. A real question, what kind of upgrades do you have in mind?
Anything that would increase the sustainability of the system. Like for instance, the Raspberry Pi I made with the because we got a few IBM terminals and we got a VT220, but eventually they're going to die, and hopefully that's not it's not too soon. But we've had a few of the CRT CRTs go bad, so.
Yeah, contact us. We have a lot of people in our group, and we have our repair workshops. Bring down your CRTs to the repair workshop. We have someone who's an expert.
Okay, that's great.
He's going to have his thing later on at 2:00. So watch that one.
I'll have to because we've actually got some in another one of our simulators. It runs off of its main flight displays are mini CRT. It's probably about that big. Mini CRT screens that run. It's a proprietary combination of raster and vector, made by Rockwell Collins. EFIS 84 is what it's called. And man, we've got one that the CRT's gone bad on it, and it'd be great to learn how to fix those things. I've been looking into how to potentially swap an LCD in there, and my research hasn't gone well with that.
So come at 2:00. Ian Primus is going to show off his CRT repair. I nickname him MacGyver because he can fix so many different things in so many different ways, and he's really an expert at CRT and terminal repair. So watch that, and you
I
can
didn't
get.
know his name wasn't MacGyver. Just kidding.
Because literally, we had a monitor and a cracked board in it, and he's like, "Anybody have a paper clip?" And he's like, always like MacGyver's like, and he soldered the paper clip to the board, and then it worked fine. It was like, it was just an amazing thing. So he always finds out ways to repair things. So watch that video later on. It's really helpful, and you can always get in touch with him. So that's all the questions we have now, Tanner. I really appreciate this. Everyone's really loves this. It's very interesting. video, and thank you for taking the time to answer questions. And everybody in the Discord, I believe it's on the screen there that shows how to get into the Discord. And we, afterwards, Tanner, as long as he can answer them, and maybe later on, because he's sort of working now, answer some of the questions. And Chris is showing off the T-shirt from last year. Well, thank you, Tanner. Thank you.
Hey, if I could say one thing real quick.
Sure, go ahead.
All right, so if any of you guys or girls have family members or yourself that is good at has interest in computers and electronic repair, hydraulics, stuff like that, they don't know what they want to do, and they want an interesting career, inform them about the flight simulator technician possibility, because I had no idea this was even a job. And I'm glad.
Where would they go to find out information about that, or were there jobs available, or how they would get training or school for that?
When it comes to school, there's not a flight sim. Well, there is a sim tech school. I'm not sure where it is. It's out in the Midwest somewhere. But in general, just electronics classes, soldering, and computer programming, computer science, stuff like that. Yeah.
So is there a shortage of those people to repair those? Is that what you're sort of inferring?
I think so. I think there is. Now we're kind of a unique case because we're an independent flight sim school, but usually an airline will have its own simulators and its own training. So you can work for an airline, and those are usually union jobs. And there's
so you're smaller independent private companies, so maybe you don't have as many resources as the huge companies.
That's definitely the case.
Okay.
But yeah, but just in general, tell your family and friends about the flight simulation careers. Just get the word out.
Thank you.
All right, thank you.
All right. Well, thank you very much, Tanner. And Chris is going to show off the T-shirt from last year. That's the back of it. Let's show the front. So this T-shirt was for last year. And why did I have a teletype in there? And it says login, VCF, password, and Unix. Hello world, let's see. Because we had Ken Thompson last year. It was amazing. He helped to create Unix. And we're glad to have him there. So this is our T-shirt from last year. This was not done by Dan Ragonti because he had passed away. And we had someone else designed a T-shirt. So I gave him here's a terminal. I wanted to have the theme Unix, and we had Unix Town. We had a whole bunch of different computers there hooked up to Unix, and it was amazing. It was great. All right, so there was Tanner Collins, and he was showing off his flight simulator. Next up is Kaz, and he's going to show off his IRIX 2020. We're going to do a live broadcast. He's over in our classroom 2 rooms over, and Corey Cohen's going to be cameraman and interviewing him. All right, so we're going to switch over to Corey, and he's going to interview Kaz.
Live. All right, good morning and welcome to the IRIX 2020 talk at VCF East 2020. Thank you for joining us today. So today I'm going to be talking about Silicon Graphics IRIX along with my colleague here, Anthony Bolin. He's going to wave into the camera.
Hello.
There. And so let me just go ahead and go over a brief primer about what Silicon Graphics and IRIX were really about. IRIX is a derivative of Unix System 5. Which was developed between the late 80s and about 2006. And it ran on these Silicon Graphics hardware. You'll see right here I have an SGI Octane 2 and another one from the back. And this is just to show off the modularity of the systems here. You can see the motherboard at the left here. And at the right here you'll see the graphics module and the power module at the bottom. These were designed so that they could be easily upgraded and used over a long period of time. And indeed, Pixar, in fact, used these machines for a very long period of time in the animation departments of the 3D graphics and such. The Octane 2 in particular is kind of one of the most popular machines that's kind of still relatively well used in niche applications and such. Over here, you'll see the monitor. The monitor. Sorry, we're having. All right, so over here at the monitor, you'll see that this has an About the System page right here. It has the graphics controls over here in the system console, which displays warnings and such. This is just to demonstrate how the system is set up. This system is running dual MIPS of our 14,000 processors at 600 megahertz with 4 gigs of RAM and a V12 graphics card. Yes, they were named after the types of car engines you had. Yeah, this was about as capable as most SGIs came at the top end of it, and well, the V12 in particular kind of is very similar to a GeForce 2 MX, so something similar to like the original Xbox or like an early 2000s PC with really high-end CPU and such. Of course, most machines at that time did not have 4 gigs of RAM, so that's something to take into consideration. These were high-end graphics and rendering systems. They were not, your gaming systems. So the answer is, can it run Crysis? Technically, it probably could, but Crysis never really ran on these systems. And yes, you'll see by my shirt here that I have a Nintendo 64 shirt on. The Nintendo 64 is probably the most famous and widespread piece of SGI hardware out there because they had a huge hand in designing not only the hardware of the machine, but the software as well, as pretty much everything that the early titles used was based on, Super Mario 64 and like that. It's all incredibly heavily tied to SGI developed libraries and microcode and other things. Anyways, that kind of gives you a primer about what we're about. I'm going to turn this now over to Anthony here, who's going to show off an impressive array of systems that we have prepared for you today.
Indeed. So you guys can probably only see, oh no, hey, I am in frame. Perfect. Hello everyone. Again, my name is Anthony Bolin, also known as Kaigen Online on the IRIX network, which is a forum that Kaz and I are administrators of. So the first system we're going to be discussing here today, which actually is now showing a very pretty screensaver, is the SGI-02. And so it's this little box here, this kind of greenish blue machine here, was released in 1996. And this one is running this is a MIPS R10000 300 megahertz processor. It has a full gigabyte of RAM in it. And it uses what's known as the CRM graphics. It's integrated into the system itself, and it's actually the only SGI system to have that integrated graphics and to not be able to come without another graphics option or to have that upgraded in some way. It also uses what's called the unified memory architecture. So basically every component on these systems can directly talk to one another. They can go point to point. The memory is all unified between the CPU, the graphics, all those components. And so there's a number of cool things that you can do with this. The O2s were originally designed with a very heavy focus on multimedia, including audio and video. And so if we come over here, we have a couple of things that we can show you. For example, we have a couple of demos running over here. This is showing off some of the texture capabilities of the system. Texturing this cube with full transparency, showing it spinning. This is the Ideas in Motion demo, very famous SGI demo from some of the earlier days. Just have that there, just because it's a nice, cool little effect. And then we have this little camera sitting up here on the top. That's the rather famous O2 cam. Yep. Also known as the Moose Cam, as Cass pointed out. Thank you. And so it actually has a pretty good resolution there. We're looking at around 800 by 600. It's stretched from that slightly. You can see our wonderful, helpful cameraman here. And so it can do texturing with any of those graphics in there in real time as well. And we've got this video feed coming in, and also over here from that Nintendo 64 on the other table, we have just some of the gameplay of the opening of The Legend of Zelda: Ocarina of Time, showing off that the system is capable of doing multiple video feeds, simultaneously sending them out to different devices for different purposes. It can also make changes to these video feeds in real time, such as doing additive effects, such as, like, say, a blur or a sharpen, other similar things like that as well. And then also, to show off some of the additional capabilities of the machine, I'm actually going to shut this stuff down real quick, and we're going to load up one of the games that actually has been ported over to IRIX and was, a rather famous company known as id Software, which you may have heard of in the past. This, if it'll load for me, is Quake. The demo gods are giving me a slight problem here, so give me one moment, and maybe while we're waiting on that, you can show off more of that shiny, shiny Zelda. This should only take a moment. We'll get those guys started up too to show off our second system. My apologies on this, but we have the wonderful IRIX login screen here, although without the visual effects, just username and password here. We'll get this going real quick. Sorry about that, guys. It's not playing nicely for me, so I will show it off on our other system instead, actually, along with yet another game. So we'll power that off, wait for this guy to start up here. I don't know if there's anything you'd want to add for a moment here, Kaz, while I'm finishing this up.
Certainly. So I will talk a little bit about this system in particular here. This is the Silicon Graphics Onyx 4. This is kind of the penultimate system that SGI released that was powered by MIPS processors, so to speak. This was released in parallel with the Tesro, the late era fuels, and a bunch of other things as well. But this in particular is a prototype system here at the top that's hooked into it. So the graphic system for this doesn't actually use SGI branded graphics. Instead, you're using the Ultimate Vision system, which is basically a very modified form of the ATI FireGL series, from what I understand. This is not my personal system, so I don't have a whole lot of screen time with it. But yeah, this system is pretty impressive because it uses a Cray-derived Numalink processor system that allows for a single system image to be shared across both of the bricks, as they call them in SGI parlance. So at the top right here you have the compute brick, and at the bottom is the video brick.
Yep, and so, and sorry, I'm still working on booting this up. Again, my apologies for the technical issues, but yep, we're getting it up and running right now. So this particular system has, in this top brick here, this compute brick, which again is a prototype model. Managed to find a seller out in California who had this prototype chassis. I rebuilt it, and now it runs very well. So it's running 4 R16000 MIPS processors at 1 gigahertz each. The bottom brick is also a 4 processor system. And so it has 4 of those same R16000 processors running at 800 megahertz. And they're all tied together. The system is capable of sending out tasks to any component of memory, any of these CPUs, at any time. Sorry, just working on getting this booted up.
It's a pretty low latency system.
It is. The bandwidth on the Numalink connection on this, which is known as Numalink 3, is somewhere around the order of 2.1 gigabytes per second.
Yep.
Capable, it does that as a pair of unidirectional links that go back and forth. In this case, there's a single cable that connects the systems. Later ones, such as the Itanium-based Ultix series, use a number of these cables together in a Numalink 4 architecture to double that bandwidth and provide for very fast data transfer for things like, say, molecular computations for designing new pharmaceuticals, things of that nature. Or they were also used very heavily by, say, the petroleum industry for doing designs for everything from oil wells themselves to plotting out large data sets.
Certainly.
Looks like we're almost ready. Again, my apologies on that.
The monitor's not on.
Yeah, it's still booting.
Okay, just wanted to let you know.
Gotcha.
So as far as SGI goes, it has a long history of being involved in HPC, scientific, military, pretty much all of those sorts of things. And that's why we at IRIX Network try to keep this alive as much as possible. And that's also why we are actually working, and you'll probably see if we still have time at the end of it, you'll see our, we have a forum that has a classic mode for it that allows for the older browsers that these systems can run to access and read posts, create posts, read PMs, reply to PMs, that sort of thing. That's basically kind of the point with forums.irixnet.org. We're trying to make it very cohesive so that people can participate in any capacity that they wish. And hopefully that practicality, because the application that we use to make this happen is open source, and I have open sourced all the code to it, so anybody can take that and spin up their own forum, for a classic Windows or classic Mac, and be able to do that. So that's kind of one of the little innovations that I am very excited about. And Anthony has been a huge help, as has the rest of our staff there, including a famous YouTuber called Dodoid, who unfortunately could not be here today because he lives in Canada. And with everything going on, yeah, the borders are not very kind, unfortunately.
Yep, we are almost there again. My apologies for technical difficulties, folks, but system is, as it says here, the system is coming up.
Unfortunately, it's not possible for us to run all of them at the same time due to circuit breaker and power draw.
Yeah,
we actually tripped a breaker right before this.
Yeah, being that these are in fact server class systems, they are designed normally to be in a rack, although this basic configuration, which was actually known as the power configuration, was set up to be able to handle, and we actually should be able, if I power this on, to get a strain.
Let's see.
Hey,
ta-da! Welcome to Artemis. There we are.
Fantastic. So,
hooray!
Yep, so this is the Onyx 4. This is our login screen in glorious 1080p here, 1920 by 1080. And actually, a lot of the systems, even going back into the late 80s, were capable of handling some very high resolutions, including
4K.
Yep, including 4K, including being able to manage multiple, multiple 2K video streams and multiple editing with software such as Discrete's Flame. So, let me log in here real quick. If I can type my password on camera. Turns out I can. Hooray! All right. So, now we will get to that wonderful piece of id software. Go to our desktop here, start a Unix shell. We will load up NecoWare, which is a wonderful old collection of software that had been ported to IRIX. There we go. And so we'll just show a real quick demo here. So this is Quake running at 1920 by 1080 on a machine from 2003 at variable FPS, but getting as high as 90. So, it does pretty well. I was hoping to show it off on the O2 here as well, which can handle it very well at about 1024 by 768 at around 75 hertz at a similar frame rate. And again, that's from a system that came out right around the same time that Quake did, when most people would have been playing this at a resolution of somewhere like, say, 320 by 240, maybe 640 by 480. And so it was only quite some time after that these systems were available and capable, on the PC side to do this. The original processor that came with the O2, which was an R5000, 180 megahertz, was said to be about 10 times as powerful or fast for integer operations as the Pentium Pro at the time. So very expensive though too. That base configuration that was that fast would have cost you $7,500 in 1995. This Onyx 4 configuration, the base version of it started at $45,000 on release. As I have it spec'd here, it would have been well over twice that.
This Octane over here would have cost about 90 grand at its top end, actually, because it has the top level processors and such. This one over here would have been more of a moderately priced configuration because it doesn't have a V Pro, it has a SI graphics system on it. Probably closer to something like 30 to 25,000 if you're lucky, depending upon what you would what type of discounts you would get from your distributor and such. It's unfortunate that we don't have those types of relationships anymore, with our businesses and such.
All right, we'll go ahead and pull out of Quake here and show you a rather fun little piece of software that was recently ported, actually by one of the members of our forums. Assuming again that I can type directories today. There we go. This is GemRB, which is an open source engine, and yeah, we'll have to zoom in on this because unfortunately the game only does display at 640 by 480. I'll try to center it here and show off a little bit of the background piece here. So GemRB is an open source engine designed to run the old Infinity Engine games that were made by Black Isle and BioWare, such as Baldur's Gate, Icewind Dale, Planescape Torment, and games of that nature. So this is my own personal copy of the discs that I ripped over to this thing. And yes, I do still have all 6 of them. So we'll load the save here real quick from the expansion, because it's a nice way just to kind of get into the game and show things off a little bit. It gives us a little bit of introductory text, which goes very slowly, so we won't worry about that here. But there's our group of adventurers. And as you can see here, we're running, it shows at about 25, 26 frames per second, which for Baldur's Gate is entirely normal. That's what it should be running at. And so we're just going to run up here real quick.
And Baldur's Gate was not the most well optimized game, unfortunately.
No. So then we've got this old mage here who's talking to us. He doesn't like us very much, and so he's going to go send us on a quest to somewhere very cold to go fight some things because he wants us to get a cloak for him. So our group of adventurers here will run in, start fighting this nasty wolf. Let's get something a little shiny on the screen, show off some magic. Here we go. Boom. And with that, the wonderful Jaheira has eliminated the wolf. And so, our adventurers can continue their way throughout the dungeon, roam around, find yet more wolves to fight, and so on and so forth. But it runs very well, and it actually runs quite well on the O2 as well. Being that the O2 came out 2 years before Baldur's Gate, there is a little bit of a performance dip, although with the higher end processors it can do pretty well. But
this is far from the final form of games like GMRB. With further optimization and better libraries and such that we continue to port to IRIX, it can only get better from here.
Absolutely. And so, since we have just a couple minutes here, I think, before we want to get into Q&A, let's go ahead and load up a web browser here, and we will show you that wonderful classic view that we have on our forums.
Yeah, this will be perfect.
Nice big screen.
Yeah.
Just, whoops.
Oh, untrusted certificate errors.
Yeah, it's trying to connect to the Firefox page, and this is a very old browser. Again, IRIX was discontinued in 2006, so this doesn't have modern SSL capabilities built into it.
We are working on eventually mitigating some of that, but it takes a long time, unfortunately.
There we go. So here is the classic site, and if I click forums, we're good?
You're going to click into forums, and you're going to have to but it's going to change to the modern
right. And so it's going to give us some issues there. So I put /classic on the end again?
Yeah, put /classic on the end again and log in.
Perfect. And again, my apologies for the certificate errors. It's just one of the realities of the modern internet on an old machine that doesn't have that support. So here we go.
And ta-da.
Ta-da! Oh, and it actually has to be logged in, which is fine.
Yeah, it carries your login cookies over from the default sessions, which, that's just a consequence of how it operates.
So if we go in here real quick, we can see, and yeah, it might be a little harder to see with the color. Just
color contrast, and unfortunately, that's we're limited by CSS technology and such with what we can actually do. That doesn't break that. I'm still working on refining it further, but as you can see,
the actual pages look quite nice once we get into the post. And so this is a question just about what text editors are good, or an IDE for IRIX. And so you can go through here, you can read this quite well.
You can also reply to a post.
Yep.
At the bottom.
I won't put anything in now, of course, but hello. We can put that in there. And so we can post, and it works really well, even on these old machines. It's a great interface. It works quite well.
And we're continuing to improve it constantly, and anybody who uses the MyBB forum could actually technically make this and go spin it up. So anyways, I think that's about all we had to share today. So I guess it's time for any questions and answers you might have.
Indeed. And we can always show off a couple other things that people like if there's time, but we'll go from there.
Yeah, if there's requests, we're happy to see what we can do to fulfill those.
Right now we're asking over to the booth to see if there are any questions for you guys.
All right.
So maybe ask us to just give them a moment, please. So I actually have a question.
Sure.
So I guess these guys here, so these would probably be in a rack of like 64 or 128 of them?
They can be. Like I said, the minimal configuration was just these two pieces here, which was known as the power config. However, with that NumaLink protocol, you can take, using what are known as NumaLink routers, up to 8 of these, tie them together, and then from there, tie those routers to other routers, and build these out to systems that have a maximum of 124 processors, terabytes of RAM. Again, terabytes of RAM in 2003.
Yeah.
And just these massive clusters so that you could take incredible data sets. Again, for things like molecular modeling, design of new pharmaceuticals.
High performance computing, just general university, folding at home, all the SETI, all those things.
Yep, and they were used, they were used by NASA, they were used by numerous government agencies. Same with the later Itanium-based systems with custom software to do whatever sort of modeling could be wanted. And I think we have lost our video on that side. Hopefully everybody can still see us.
I don't think we actually lost the video. I think
Okay.
No, we just lost our feedback.
We lost your preview.
Fantastic.
Your
Okay,
preview.
wonderful,
Your
wonderful.
preview. You lost
Okay,
your
so
preview,
we're
but it's
fine.
back. So I get there are 2 questions up right so far. We've got, is there much software development for the IRIX these days?
Yes, there is. Yes, there is. So on IRIX.net, we kind of have a couple of projects going, including NecoWare 2. That one's currently kind of, we're still working on it. Our main developer is a very talented gentleman named Axatax, and he has been fantastic with it. I'm helping him out too with packaging, documentation, and other things. It's just, we're trying to piece things back together from NecoWare and freeware and other things, and it just takes a heck of a long time. There are competing projects. There is RPM for IRIX if you want to go more of a Linuxy route and such. Some of our users are a little bit apprehensive to that. I mean, I worked as an RTL admin for years, so I'm not as into that personally, but some of our other users find it to be very convenient. There's nothing wrong with multiple different approaches to it.
Yep, absolutely.
And IRIX is very flexible. It's a very flexible operating system. You could probably, port APT to it or anything else you really wanted with enough grit and time and patience.
So we do have another question about something. What is your favorite single SGI machine? One for each of you. But before we get to that, I have just a question that came out of that.
Sure.
Do you find any frustration that probably most of the stuff you're looking for is classified and not open and not available?
A lot of patches I've had to kind of source from users who had old support contracts and who had copies of them locally. There was a lot of software that is licensed like to dongles with systems and such, and because of DMCA and such, it's really difficult for us to talk about that publicly and such.
Okay.
But, it's just, we're trying the best we can to build out the most complete documentation, the most complete collection of software that we can. I do host some non-free software that's abandonware mostly and such like that. We just do the best we can with what we have. And that's all we can really ask for.
Right.
So once again, I'm going to ask the question that came through here, which is to each of you. Which is your single favorite SGI machine and why?
Go ahead, Anthony.
Okay, it's a hard question. In terms of daily use, and as much as I do still have any daily driving of these things, I've come to really love the Onyx 4 for its sheer power. The only problem with it is that it does use, as we mentioned, ATI graphics, which were codenamed Voyager. And the issue there is that you lose a lot of backwards compatibility. And so my second choice is the Octane or Octane 2. I have one that I've built out to a pretty solid specification. It's extremely modular. And there's a lot you can do with it, a lot of upgrades. For the prices you can find them for these days, they're a great value. Although I actually also brought the O2 because I feel like it's a great starter machine too. You can get a lot of power out of it. It's not quite as performative as something like an Octane, but it also weighs less than half. It takes up less desk space. If you want something good to start with, that's going to give you some performance, might be a little faster than an older machine, it's a great choice.
We should probably mention plastics and those things are brittle and balsa wood.
That is one other thing to be aware of just on these machines, and I can't really show off the back of it right now because it's all plugged in, but there is a little bit of damage there. I've super glued a few things.
Yeah.
These things break in shipping, so if you can find one locally, go for that. Otherwise,
Make sure you seatbelt it into your car.
Yes, and that is in fact what I did.
It's just like a baby. It's just like a baby. You have to treat it like a baby.
Little bouncing baby O2. But in that same sort of vein, just make sure you work with anyone you'd be buying one from who may be across the country. Make sure that they pack it well. There are sellers out there that may have some of these systems out there, both recyclers who receive these over time, as well as individuals such as Ian Mapleson out of the UK, Harry Goldschull, and Doug Nashik here in the US, that still sell parts for the few people that still use these systems in production, and also sell to hobbyists. They're great people to buy from.
And they usually are very negotiable on price.
Absolutely.
And with that, I'll just segue into mine. My favorite's probably the SGI Onyx 2, which I don't have here with me because it's about 250 pounds and it's the size of a freaking cube. So it's not the best machine to be able to show off here because it requires a ton of power.
Yes.
It's pretty loud. I use that a lot. It's one of my dailies. But for practicality's sake, I have to concur with Anthony here. The Octane, best system for a hobbyist to start out with, in my opinion. You have excellent upgradability and flexibility with it, and they're not too heavy, they're not too bad.
So the next question is kind of interesting because I guess it's subjective.
I
I'm
like
a car
subjective.
guy, and this is always causes these kind of fights when someone does a "what is the best" online. But we've got about what is the best? Why is the Crimson the best SGI ever created? They used it in Jurassic Park to create some dinosaurs.
Okay, the Crimson is...
Hold on, one disclaimer. They used it to create CGI dinosaurs.
Okay, so...
If they could create real dinosaurs, I'm running away.
Okay.
Building a better dinosaur. I'm trying to get the light off of it. SGI trading card from '93 after the Crimson and the use in Jurassic Park.
Okay, so yeah, the Crimson is not the best SGI. I've actually never seen one with my own eyes, to be honest. They are that rare. They're very tall. They're very heavy. They also only have one R4000 processor in them. They're not a multi-processing machine, and the only real killer app for them is the Reality Engine boards, and those things are not only rare but heavy, loud, and unreliable.
Although
we have one gentleman on our forum who's been searching for a replacement Reality Engine board for 8 years. 8 freaking years. That's a long time.
I will add, though, that I have seen one in person. There was a recycler in Rhode Island I helped do some appraisals for. They had one that was actually part of a U.S. Merchant Marine and Coast Guard naval simulation. It actually was one of the original machines. When I powered it on, booted up, straight into IRIX, worked great. So it was surprisingly reliable. But what's best about the Crimson is that every time you're near it, you just want to start singing the Jurassic Park theme. That's what's great about the Crimson.
Well, if you want to see one, they actually have one in the museum out near Pittsburgh. In the large, I guess it's a large-scale museum. It's
Wonderful.
David Wires Museum.
Cool.
Yeah, we'll have to take a look
They
at
have one
that.
you can see there. It's very cool. It looks like it's all made out of dinosaur bone. So, anyway, I think that's it.
Okay.
We are good.
Well, I'll hang around the Discord. If anybody has any questions, they can just ping k.karoy. I'm in that. That's the username I'm using in there. So
I want to thank you guys. It's been really informative. I didn't know very much about SGI, but I've learned a lot, and
it's a pleasure. Yes.
I didn't realize there was such a community for these machines because they were so expensive when they were new. And I honestly thought by this point, people, when they got rid of them, they just recycled them because they weren't kind of vintage.
Unfortunately, I'm trying to rescue them as much as possible, but recyclers are a little cagey sometimes. It's really difficult to deal with them at times. They're really boneheaded a little bit, but that's not to say that I don't like recyclers. They're difficult to deal with.
Yeah.
They have a bottom line. They need to make money. They get paid by the pound for the metal and scrap. So you oftentimes have to pay a lot of money to get a machine out of their hands.
Especially Crimson.
Yeah, especially Crimson. Thank you guys.
You're very welcome. Thank you so much for having us.
Thank you, everybody. Bye.
Right. Welcome back, everybody. Thank you, Kaz, for that great demo on the IRIX 2020. That was very interesting. A lot of people are interested in that. And, as Ethan just said to me, that, it was there was a big group and it died out, and now it's being researched and people are interested in it. So Ethan O'Toole his next video is the Yamaha C1 and his saga about finding information about how to repair this broken 286 music computer. Ready.
Ethan here with my 2020 Vintage Computer Festival virtual exhibit. This year for the virtual exhibit, I decided to do the Yamaha C1 portable music computer. It's a DOS PC luggable 286 computer that is meant towards MIDI and music composition. A bit of backstory: when I was younger in Virginia Beach, I think I either saw a brochure or one of these machines at a local music store. And it kind of stuck in my mind. It didn't really stand out too much other than it kind of looked cool. And it was interesting that it had all these MIDI ports, which at the time MIDI expansions for PCs were kind of rare. Many years later, I decided to try to hunt one of these things down, posted all over the forums and the mailing list. Just a little, hey, I'm looking for one of these. Never got anything back, but I did have an eBay search set up for many years. So I think after maybe 4 years, finally there was a hit on one of these machines. Before that, there was someone that would list the brochure over and over and over, so they kind of highlighted the fact that it was out there, and there was a little bit of information here and there on the internet, but really nobody had one or anything else. It's kind of a thing of lore. So yeah, after 4 years, one of these things pops up. It was non-functioning, which I eventually learned that all of them are non-functioning. And it actually had a good amount of documentation and stuff with it. So bid on it, was actually successful, and I think there was actually a little bit of competition, which surprised me because I thought it was kind of the only one in the market looking for one of these. When the auction finally receive it, and it actually came with more just the actual computer itself, as well as a good amount of documentation, which included some rare documentation that kind of goes into not a full service manual, but kind of programming and other documents that were actually also included on a floppy disk with the system. So the minute I got it, I put all that information out in public so that others would have it, and wrote some blog posts about it. And there was actually someone else that had some blog, a post about his, and I think his is also dead. So posted kind of, hey, does anyone know what the issues are? Nothing came up, so I decided to dig into it. It took about 3 years to actually troubleshoot and fix the stupid thing. I was kind of at the very end of my wits at a do or die. This thing's either going to get fixed or got to go because I was tired of seeing it. But yeah, so the difficulty with it is there's really no information. I contacted Yamaha, and their service people didn't have any service manuals or anything else. They actually didn't really have much of a record of it existing at that point in time. Like they were kind of confused as to what I was talking about. My eBay search later actually hit, and sure enough, service manuals started popping up. So someone had a bunch of service manuals they were selling off. So service manuals became available, and I think I was the first one to grab one, but others grabbed the follow-up service manuals, and now I've scanned them and other people put them out online, which is pretty good. So the service manual didn't really shed too much light, but it was definitely a big help. The symptoms were originally that there's actually an external display feature for the CGA graphics, and there's a port on the back where you can hook in a monitor. Well, it would always come up saying that it's set up for the external monitor, and there's a dip switch in the back to turn it off and on, but it just never responded. Not having any reference to one of these machines, I had nothing to compare it to. So started tearing into it, did a lot of kind of reversing the circuit board to figure out all the dip switches and logic that actually controlled the screen. Tried to hook it to an external monitor, actually kind of tried to hotwire it to an Amiga monitor, but that didn't work. There were capacitors that had leaked on the motherboard, but nothing too bad. And I wrung out all the traces with a multimeter, and they seemed to be good, even the ones that looked questionable, which is only like 2 of them that really looked marginal. So yeah, it was a tough one, but eventually I figured out that there's actually more traces damaged by the capacitor leakage. The vias going through the board, not so much the trace itself. And yeah, the day it came to light was pretty good. But prior to that, I had hotwired it to get the LCD to fire up. There's no output, everything. So this one is partially working. The actual machine itself is a 286, I believe 12 megahertz. This one is equipped with the hard drive, which is not of any normal standard, which was kind of common for all the laptops and portables of the day. It's got a custom hard drive that uses a much thinner ribbon cable with no power. This is actually the hard drive controller out of it. So the hard drive does not work, and the parallel port as well, I found out after trying to run a iOmega zip drive for storage. No go. So there's traces that are damaged underneath the surface mount chip. I could probably replace it, I just haven't had the motivation yet. But some other neat things about it was the machine features 2 sliders, which are actually show up as MIDI. Hopefully I won't damage the hard drive. It is a heavy beast, but there is indeed 8 MIDI outputs. There are 2 MIDI inputs and a MIDI through. There's a SMPTE timecode in and out, which I'm not sure if that can be written straight to tape for time striping tape to synchronize with the MIDI sequencer, or if it has to, or if it's just between devices that speak that. I'm not really familiar with that. And your standard PC ports. There's also an expansion slot here, and according to the documentation which came with it, which once again is pretty rare, but I put it out there, it looks like it might just be an ISA expansion. The only expansion card that was ever mentioned that was released is a RAM expansion that adds another, I think, 1.5 megabytes of RAM to the internal 1.5 or so that it has. Hopefully I might get around to maybe trying to cat out a board for this to convert it to ISA for trying to run an XT IDE. On the vein of hard drives, and moving to a modern hard drive solution, hard drive, There is was it low tech. So low tech person from there contacted me and actually gave a whole bunch of information as far as the dimensions of the physical hard drive controller, the original, and he produced a IDE interface that will allow you to hook a more modern hard drive or SD card, compact flash, any kind of the upgrade solutions into it. However, there is no BIOS here, and someone else from the VCF Fed forum had actually downloaded the BIOS dumps that I posted online and merged into it the XT IDE BIOS to try to make this thing work. However, upon trying to use that merged BIOS, the person who created it doesn't have one of these machines to test with. It doesn't work. It basically beeps a few times and it never posts. So with that, this doesn't work. So I think if you were to actually attach that ROM through the 16-bit ISA slot through that interface there, it'd be possible to get that working. I'm not quite sure why this wasn't designed just to plug into that connector, because that's externally accessible, so it's possible to add that card in without tearing the machine apart. And it's quite a bit of a lot of screws and stuff to get down into where the hard drive controller sits right here. As far as software, there's actually quite a bit of software that would run on this and support the MIDI interfaces. The big one is Voyager Sequencer, which I have a demo copy that someone has out there that has the driver, but that only works with Voyager Sequencer 1, 2, and 3, and 3 supports having all the MIDI ports. However, the versions that are out there online are copy protected, the disk images. Voyager released Sequencer Gold free to the world as the DOS version way back when. However, the driver, I believe, that is used to drive the MIDI ports, DOS TSR, does not work with Gold. There's someone in Iceland with one of these, I believe, that says that he has that long-lost driver that would actually make that work. I found out that Cakewalk will work and drive all the ports. So that's kind of what I've toyed with, because they released the DOS version of that to the wild a while ago. Famous users, there's some spiel out there that Kraftwerk had used one of these to sequence the robots that were on stage during their concert. There's a little bit about Jan Hammer and the Miami Vice team, but I don't think it was actually written on this. It was just used a MIDI sequencer that was kind of popular with this called Textures. But past that, I haven't really found anything about like legacy famous songs made with one or anything like that normally gets attached to a lot of synthesizers. But yeah, overall, it's kind of a neat machine. The screen is a EL backlit. It's kind of hard to see. It has a socket for a coprocessor, which isn't there. I think in its day when it came out, it was very expensive, and I think it was kind of maybe behind the other computers of its era. So I think it kind of came out when the 386s were hitting the market. So obviously, they don't seem to have been too popular because they're very hard to come by. I think since 4 years, I think maybe 3 more have gone through eBay, and someone has 2 of them that both need repair. But yeah, overall, it's a neat machine, and I guess for the next part, I will demonstrate the MIDI stuff a little bit. Okay, for a quick demo on the Yamaha Music Computer C1 doing MIDI. Once again, this is the back of the unit here. So we have 5 connections going out to devices. Each MIDI port can technically handle 16 devices, so yeah, it's true that you could run everything on one. In theory, this can drive 128 devices due to the 8 ports times 16 channels. This is actually coming inbound from a keyboard that I used to pound in my beautiful composition. And this is Cakewalk 4.0 for DOS. So you can see here the kind of different devices here, MT32, Oberheim, Wavestation, etc. And over here is the channels that it's assigned to for the output. Oh, sorry, the ports are right there, followed by the MIDI channels. I'm just driving a number of synthesizers that I've repaired over the years. So Thanks for watching, and I guess I'll see everybody at VCF 2021 and hopefully in New Jersey.
All right, welcome back, everyone. That was Ethan O'Toole and his Yamaha C1 286 music computer. It was very interesting. And we have Ethan here. Ethan, how are you today?
Not too bad. How are you doing?
I'm doing pretty good. It's a great show so far. And do we have any questions?
First question today is, was the Atari Stacy a competitor to this Yamaha?
All right, so I'm not sure on the timing of when they both came to market. To me, it seems like the Yamaha might have been more of a business computer since it was IBM compatible. The Atari Stacy it's a notebook or laptop version of the Atari ST. The Atari ST, those computers shipped with MIDI ports standard. They're like the only home computer that came with those interfaces on every machine sold. So they gained a really pretty large following along musicians, a lot of the electronic music artists. A lot of them in the UK, I think, use them. So there's two applications over there, Cubase and Notator, that are pretty popular. They definitely got a much larger. I would say they won if they were, because even though they're rare, the Atari ST portables and computers are used in a lot more productions.
So, Ethan, do you want to elaborate on So you had to cut some things from your video. Did you want to add anything that you didn't have on your video that you might want to share with us now?
Oh yeah, so I didn't actually put in there the final issues were that I think there was 3 to 4 of the either data or address lines that came off the CPU where the V is cut through to the other side of the board, or where the actual failures were on that machine. And I think that every one of those computers that's in existence are going to be hitting those same issues, because the capacitors leak. They don't leak too much, but that stuff, it kills the traces pretty badly. Trying to think, troubleshooting. It was a long road to recovery on that thing, because even probing it with those scopes on the lines, the data lines and address lines, it looked like there was activity. The BIOS kind of looked corrupted when I examined it, but it wasn't. So.
Did you have any career in music or special interest in music, and how does it integrated that your vintage computers and music together?
So I guess I've always been a music fan, and in the early days I was a Sierra kid and everything else. So just like a lot of others, came up on the Sound Blaster cards on the DOS PCs after the Atari 8-bit world. And I don't know, I just kind of always was kind of fascinated by the MIDI stuff. I thought it was neat, but when I was younger, it wasn't as prominent or reachable. And no, I'm just a hobbyist, a kind of ADD. So I touch all kinds of vintage computers. The music side's just one, and I also mess with a lot of laser show stuff that's also on the vintage computers. But yeah, there's nothing specific. Actually, to be honest, a lot of it was just Space Quest 3 and the Secret of Monkey Island music was kind of what caught me in the early days of computer music. And then I played with all the trackers and stuff on the DOS PCs, which is the mod files and Scream Tracker stuff, just as a hobby.
Nice.
I got a question. What's your favorite instrument?
Ooh, probably the synthesizer. Although I'm not against. I don't know. I guess I like a lot of them. Low brass, saxophone stuff, keyboards, piano. Tend to levitate more than that. I don't really like bagpipes. Well, sorry to any bagpipe fans, but no.
I don't think you have to apologize for that one. Oh, no, I didn't say that. Okay. Yamaha later had the CX5M for music, but were there other computers of that time with built-in MIDI ports, this ST or others? Question.
So the Atari ST series had it. They're referring to this Yamaha C5M, I think, and I think there might be 11 version or something those are both MSX compatible computers. I think they had MIDI ports. I know they shipped with a keyboard and stuff, and they have like a shortened version of the Yamaha DX7 synthesizer built in. I don't own one, but a couple friends have them. Past that, I can't think of them. Of course, MIDI interfaces existed on everything from Commodore 64 to Amiga to DOS PCs. And the Yamaha C1 is not MPU 401 compatible, as far as I know. So there's no way to. It should not work out of the box with any of the games or anything. Not that you'd really want to run the games on it because of this display. But yeah, I think that was probably it for MIDI.
How did this relate to the Yamaha MSX computers?
Totally separate. There seems to be a bit more knowledge or awareness of the existence of those C5Ms and those, but yeah, this is straight up a DOS PC. I think so far maybe I found 9 of them between watching eBay and people on the VC Fed forums and stuff that have the DOS version, the 286. When it comes to the MSXs, I think they're a little bit more available. I think they're a much lower price point when they were sold, so more of them are in existence. Plus, the MSX is really popular overseas. I think the Yamaha C5M might be one of the few MSX computers that really showed up in the US market.
What's the best music composition software for vintage systems? I know a lot of people use vintage systems for chip tunes, etc.
From what I've seen, your 2 big contenders are probably going to be Cakewalk. Sorry, not Cakewalk. Cakewalk and Voyager Sequencer. I found that Voyager Sequencer Gold, I kind of like a little bit better. With this particular computer, it's hard to get the Gold version running without that driver that's only this guy, I think, in Iceland seems to have. Cakewalk is definitely more accessible as far as getting it to run on that machine due to support. Past that, the other sequencers of that era that I've peeked at didn't really look too great. I've tried using Cubase and whatnot on the Atari ST, haven't dove into that enough yet, as well as Master Tracks on the classic Mac, like the Mac SE. Both of those seem pretty capable and cool as well. And there are a lot of videos of people making compositions even today that sound modern using vintage systems. And to some degree, it's kind of interesting that the workflow seems faster if you're good with the keyboard, because I think the mouse slows people down. So some of these, for the copy paste music, you can see there's a guy named MIDI Song, I think, on YouTube who's posting these videos where it's all created in under 10 minutes and it's just copy paste fast, and he's really, really fast with the keyboard. So it's kind of interesting that he can pound out these musical scores so quickly using vintage software, but he is driving modern synthesizers with the vintage software. So he's just mostly using the software as the sequencer to potentially like fast computers running virtual instruments.
So I have a question, and how does what's the difference between MIDI and like synthesized music? What is like the
So the MIDI protocol, which might be one of the longest running computer buses in history, because 80s and it's still common today. It's literally just say like when you hit a key on a keyboard, it's going to send 3 bytes, and those bytes are what note it is, how loud it is, what channel it is, and what octave. So it's literally just instructions to hit the note. So it's all up to the other equipment to produce that sound, and that's kind of why general MIDI isn't very good, because if you're using just a general MIDI instrument sets, you're not hearing it as the artist may have wanted you to hear it or how they heard it when they wrote it. Whereas when you store it digitally, be it a mod file where the instruments are stored with the note data, the exact sound that the artist heard when he created is transferred to you. With MIDI, it's literally just the notes and the volumes, and as well as a little bit of other data for effects that's stored in that file. So it's literally think of a spreadsheet. It's like a spreadsheet of notes, and it just drives the synthesizer or the whatever the music instruments are that receive those MIDI commands and triggers them on that instrument. So unless you have the same exact MIDI device that the artist made their composition with, you may not hear it the same as they did, unless you have, I guess you can emulate it. But that's why the Roland MT32 kind of took off in the game world. But if you didn't have the MT32, the sounds are kind of possibly off or didn't sound good.
Andy asks, will this control your laser light device?
You could pass the MIDI data out of it into the MIDI data. The laser device can be, I guess, triggered by MIDI, or you could actually use the SMPTE time code, I think, to clock a show and chase that, because the SMPTE is used to time align your MIDI data, your MIDI notes with an external thing. So it's used a lot of times in, I guess, movies. So if you created a movie, you would have a time code along with it. then you set the computer up to follow that time code. So if you're composing notes, it clocks right along. So yeah, the laser software can do that.
So it sounds like MIDI is just like a very generic sound instruction, and whereas the other ways of doing it are more specific, like you said.
Correct. Yeah. So the problem is once again the instruments. If you're not using the exact same instruments or the same patches on the synthesizers that sound exactly how the artist wanted you to hear it, it may not be this. It may not sound good or as good as the artist created it.
So do you know why MIDI was created? Was that just to make it easier to transfer from one device to the other? Is there some benefit as to why it was created?
There was some earlier predecessors. So there's like some other synchronization and timing stuff that Roland and the other companies had that were specific to their brands. And I don't know a ton about them because a lot of that equipment is now very, very expensive. It's highly sought after. So the MIDI is just it was a spec that was cross-platform. I don't know if they knew that it was going to last as long. It runs at like 31.5 kilobits per second. It's a current loop. There's 16 logical channels on it, but the early devices may not understand those channels because I guess when you get to the very beginning of it, some of the devices didn't implement that spec very well. And to be honest, I have like a device now that's brand new and it can't talk to the C1 because its actual implementation of MIDI is kind of off and the timing doesn't sync up right. But that's more of a fallacy of that new device, not the spec of the standard, because everything else has been pretty good.
The video showed that this came with DOS 3.3 on disk. Did it come with any Yamaha developed diagnostics MIDI programs? The old Music Quest MIDI Man cards came with some simple DOS diagnostics just so you could test your install and serial communications.
It actually did. There's a disc called MIDI Monitor I think the program actually allows you to in-flight modify data coming in and out so that you can kind of use the computer as a MIDI router. And there's actually the source code. I noticed the other day there's actually the source code to the C API driver included, and I put all that online. So I've imaged all the disk, and the one disk that has a lot of text files. So in those text files you'll find the printed gems of information, and I put all that online for the greater community to have if for some reason theirs doesn't come with those discs. And there was someone else that perked up that I guess he had two machines that belonged to Yamaha, both a C5M and a C1, and he was doing something for, I don't know if it was like a museum exhibit, a temporary thing, but he had the stack of discs that are all demo copies. So it's the software that's all restricted, it's just can't save or stuff like that. So he's shared that, and I've put that online as well so that if someone comes across a machine and wants to toy with it. But Cakewalk released the full DOS version to the public years ago, and that works.
Cool. How does it compare with the MIDI cards available on PC?
The MPU 401 and the others, like the Sound Blaster game cable, 15-pin cable, I think good chance it's not MPU 401 compatible, which is a downer, so the games won't work. But it definitely has more inputs and outputs. So by far the I/O is way above what any of those cards would have ever had, because you might have found a 2x2, I think, in the DOS world, until you got into the more later FireWire and all those kind of bigger interfaces on the faster computers.
It appears super portable. Would this be stacked into a travel case and used for live events?
Possibly. The only thing that there's talk that Kraftwerk used them to sequence the robots that they had on stage, like the physical machines that they used for part of their show. But past that, I couldn't find any cases of people using them in an actual live setting. It is very heavy. It actually weighs like 22, 24 pounds. The one I have came with a padded case, but even then I would be careful slamming it around that it might crack the plastic. It's beefy, and it's not just, they just didn't design it to be lightweight, because a lot of the weight is in this power supply module. It's just a switch mode power supply, but it just weighs, must be 10 pounds on its own.
Well, it looks like we're out of questions, Ethan. We really thank you very much for doing this. Can you, before you go, show us your T-shirts? Let's show us your T-shirt. What's
yes,
T-shirts?
I went amber on this one.
Yeah, I love the amber. The amber is very clear. Some people like the green. I like the amber. Again, that's our Vintage Computer Festival T-shirt for 2020. Some sizes are out of stock, but we still have some. You know, Mike Brutman made this. You have the bit bucket there, a little teapot, demo. I think it's from the B box. You have some binary trees there. You have a general. It's like a TRS-80 Model 2.
It looks like a Model 2, yeah.
Yeah. You have a little Tron tank there, a little Tron cycle, or maybe that's from Battlezone. I think the tank's from Battlezone. A little bug. Yeah, 6502 chip, because this was sort of our theme this year. And the AT&T symbol. So those are available at vcfed.org/WP/T-shirt. We still have some of those available. Again, thank you, Ethan, for that great demonstration. He's going to go to the Discord channel and answer any more further questions that you have there. All right. Thank you, Ethan.
Have a good one. Looking forward to seeing your stuff.
Next up is going to be Marcus Mera, and he's going to do King's Quest. He has the IBM PC Junior. That's actually the museum's computer. We had unboxed that. It's new in box. It's in mint condition. But he's going to show off some Sierra software that we have. That he has. He had gotten it inexpensively. Someone had a yard sale or something. He'll explain that. So it's Sierra games on King's Quest on the PC Junior. So we're gonna switch over to Corey Cohen, who will be interviewing Marcus Mera.
Outside? Yeah. Welcome to the Vintage Computer Festival East. I'm your host for this segment, Dr. Guillotine, and I'm going to be talking about online, it's otherwise known as Sierra Online systems, otherwise known as Sierra Online. And we are going to be talking about a little bit about the history of their software that they developed and the games that they developed, as well as the IBM PC Junior, which was the system that really took them put them on the map, but not really made them financially successful. So the story starts with Ken and Roberta Williams meeting and falling in love. That's a great start to a fairy tale. And what happened was Ken was a developer, a computer programmer, and Roberta would follow him around to the different jobs and got involved in tech as well. And one day he brought a game called Adventurer, written by Scott Adams, and she fell in love with the game and played it all the way through and wanted more. And she decided that she could write her own story. And the first game that was developed was called Mystery House. And what it had was graphics, which is the first game with graphics adventure game with graphics. And the way that they were able to create this artwork and input it into an Apple II system was using a VersaWriter input device that allowed her to take her simple artwork and put it into the Apple II and allow Ken to write simple code that was very small and fit onto a disk for release. And the second game coming out after Mystery House was this one right here, Adventures in Serenia, which was first known as Wizards and Princess. IBM renamed it. We'll get to that in a moment. But I kind of want to tell you why I'm here. I'm not an expert of this, to be honest with you. So why am I here? Well, it's really luck. 2 weeks ago, on Facebook Marketplace, I'm searching for video games because I like to collect them. I'm into collecting vintage games, into computers, and that's how I came to this festival. And I saw this image with a bunch of other games, about 15 of them. So I went on and I sent the message saying, hey, I really want to get this game, how much do you want for it? The lady says, make me an offer. I said, $80. She said, no. She said, I got 6 more boxes of this stuff, and I really want more money. I said, well, okay, what's the number you want? She didn't reply to me anymore, but I'm a persistent guy, and I knew that she was blowing me off. But I had a second account on Facebook for my product, Guillotine MMA. So I logged in, and I sent her another message, is it available? She didn't know it was me, she replied back. Basically, I made the deal at $200. I drove 250 miles. I went, I grabbed the games. I come back home and I pull out this one here. And I had no idea really what it was. But I posted a photograph with the King's Quest on the Big Box PC Game Facebook group, which is an amazing one, by the way. If you're into big box PC games or PC games in general, I highly recommend you sign up for that account. And when I posted the image, all of a sudden, world famous collectors are sending me messages about it. I knew I had something. Did a little research on it, and then I found out that this was actually the second game that Roberta Williams created, which was Wizard and Princesses, but it was rebranded IBM and renamed Adventures in Serenia. Why is that? Well, we got to go to 1981, when IBM launched the PCXT. And they're all business with the IBM PCXT. But they're noticing computers like the VIC-20, the Commodore 64, the Apple II, people like to play games. Because you know the old saying, all work and no play makes Johnny a dull boy. So we like games, and they saw money in games. But instead of creating brand new games, they decided to go to different people and have games ported, especially off the Apple II. And one game in particular was this one right here. And it was, they approached Ken and Roberta Williams, and they said, can we make a deal in launching a video game on the IBM XT? They make the deal, and as you can see, this is actually a complete specimen here with a beautiful, I'm very lucky to have it, including all the warranty cards and stuff in here. But basically, the gist of it is, this was rebranded by IBM to sell video games on the IBM XT. As they developed a relationship with IBM, which they nicknamed BFC, and I'm sure you know what that means, big effing company, they were telling them about another system that they were developing, codenamed Peanut. And that is the IBM Junior that we know today. And they wanted a game that was more advanced than this to launch as a launch title for the IBM PC Junior. It had to have more advanced graphics, colors, sound, and more playability and replayability, which is important in a game. And they made a deal in order to launch this game. But what it really did, it saved Sierra Online, which was named Online Systems at that time. They were in financial trouble because they invested heavily in the video game sector of cartridges, the cartridge base. So in 1982, there was a huge collapse. They were financially in trouble. They were going bankrupt. IBM paid them advanced royalties on this games that they were developing. But what they also did, because they were being sued by the government and were having, what's the word I'm looking for, Corey? The word that when monopolistic practices. So antitrust lawsuit, that's the word I was looking for. So they weren't able to sign an exclusive deal with IBM. IBM purposely said that this cannot be exclusive to us. And that allowed a window of opportunity that we're going to discuss later on. So Sierra launches the King's Quest. Let's take a look at this for a second. If you know anything about the game, this cover will confuse the crap out of you. Though you play a knight, you look nothing like this character. And I gotta say, in the beginning, the artworks were all designed by Roberta. I'm assuming IBM graphics department was involved in here. I mean, look at this box. It's so boring, but I still love it. I mean, just the way it opens up, it's super interesting to me. It's totally IBM corporate, but yet it's got a little splash of fun. I mean, you got a red label over here. I mean, how cool is that? But what else we got in here is a keyboard overlay that goes on top of the IBM PC Junior keyboard. Now, why do I bring that up? This is actually not the first edition game. This was released in 1984. But if you look into the history of King's Quest, it was really released and developed, the first edition, 1983. And we have here the original keyboard that was launched with the IBM PC Junior as a chiclet keyboard. I don't have that overlay for that. I wish I did. Feel free to donate to the museum at the Vintage Computer Festival. We'll definitely take it. We'll get a keyboard overlay that goes on top of the chiclet keyboard. But people didn't really love the chiclet keyboard, and this was discontinued. But what I just found out today, because again, like I said, I'm not an expert, but I'm surrounded by experts, was they used the same internals for this keyboard and just added new keycaps. And here we go.
It's a little mushy. If you know anything about the IBM XT, it's a much more clickier keyboard with a tactile function. This one's a little mushy, and that's because they basically just used the same one from the chiclet underlay and just replaced the keycaps. And then we have the overlay over here, which is much more simplified for the 1984 release of it. So what happened after the IBM PC Junior launched? Did it make Sierra wealthy? No. It just saved them from the initial royalties that they got, or the initial, not the royalties, the initial signing of the contract. The royalties didn't come because the IBM PC Junior is considered a failure commercially. Now, I'll argue that this system is a successful system. Reason being, I think that the graphics are fantastic. I couldn't believe how fast it loads up. So this must have been great in 1984 to have such a fast loading system and 16 color graphics and the sound capabilities that it had, and the expandability with the side carts and the different things that you're able to do with it. So I thought that was really, really a successful computer overall, but financially, not so much. So what I just learned today was, in 1984, in Christmas, they discounted the system for the holidays, and when they did, it completely sold like hotcakes. But by this point, they thought it was going to be a flop, and they were just trying to make them fly off the shelves, close out the inventory. They stopped production. Then they realized they had a winner on their hand. It was too late to go back into production of the systems. And they just used it as a bait and switch technique to sell the more powerful IBM XT, or the ones that they were continuing production with. So then what happens? Well, Tandy, which is a Radio Shack company, basically, I'm going to say they stole the technology, they stole the architecture, made one little switch on the audio. I'm hearing that you take a soldering iron and you do a little this and a little that, and you all of a sudden have a Tandy computer, or you can take a PC Junior, turn it to Tandy, vice versa. You go back and forth if you wanted to. And the Tandy was a success, huge success for Radio Shack. Why is that important? Well, we'll go back to that licensing agreement I was talking about. They didn't sign an exclusive license agreement, meaning they, Sierra Online, they didn't sign an exclusive agreement, so now they were able to market King's Quest for Tandy. They changed the artwork, they changed the box, and they relaunched it, and it became the goose that laid the golden egg for them. They became very, very successful with it, sold tons of titles, and have a huge history. I have a ton of games that I brought to show off from Sierra Online, and was very, very successful then on. And that's kind of the legend of King's Quest. Started off as a text-based with a little bit of graphics adventure, launching on the IBM PC Junior as a commercial disaster, and then becoming a huge success with the Tandy 1000, the Apple IIc, and the rest is history. So I think now, why don't we boot up the game and see what it's like? Now, in all honesty, I have not played this game. I've played some of it in the past. As a child, I'm totally aware of King's Quest, but I was more of a Space Quest guy and Police Quest and some of the other Sierra titles, Leisure Sulari. I mean, come on. We all played Leisure Sulari. And those were more the titles I was familiar with. I was more of an Ultima guy when it came to fantasy. King's Quest is more like a fairy tale, and I was more into like Dungeons and Dragons. But I still love the game. So let's boot it up and see what it looks like. Let's turn on the monitor, and boom. And I think the part that I really love is how quick this computer actually boots for 1984. Let's give it a little moment here. Is that too loud, you think? Wow, look at that. We're already at the screen. Press the button and the game begins. That was it. But it was, 1984, you got to imagine that this was something that nobody's ever really seen before, this kind of colors. They used to fake colors on the Apple II with dithering, and you can only have a very limited color palette. But here we have full 16 color graphics, and as you can see, the game looks, I think, really cool. Yeah, that looks pretty cool. Now, what's really interesting is that if you start walking, you don't turn, you're dead already. I mean, come on. Roberta was relentless. Relentless. She was absolutely relentless with the deaths. And Sierra was infamous for being very difficult puzzles to solve. You literally had to read literature in order to understand some of her puzzles and trying to solve them. Again, I just wanted to kind of turn it on. I'm not going to play the game, but just wanted to show you a little bit about it. And let me see if I just turn down the volume a little bit here. Yeah, so it's a game that requires you to actually use text in order to play it. So as we're walking, we can control the character with the keyboard. Also, I believe the joystick works. Did it plug it in? Yeah, we're having a little issue with the joystick, but I believe that the joystick does work for this game, but you can't play the game with just the joystick, because once you get to the door, I mean, how do you get in? Using the joystick, you don't press the button to get in, you're going to have to actually type in. So right here we have the command line down here, and we're going to type in open door. And I believe if you don't use those exact words, you don't go in. So that can become kind of difficult when you're trying to solve puzzles, that you have to be in the mind of Roberta Williams and Ken Williams and understand what they want you to say to the game in order to get it to work. But look at these graphics. I mean, I just love it. I mean, back then on a Commodore 64, everything was kind of brownish. And don't get me wrong, I'm a huge Commodore 64 fan. But to me, like, this game loads quick and looks gorgeous. I wish I had a little bit more sound. That's the one thing the Commodore really definitely was very successful with that SID chip. But here we are, and we're going to get points. Let's see, how do I stop? Stop. All right, how about bow? Can't do that from here. All right, guys, I don't know how to stop here. Is it enter? Nope. Anybody know how to stop? All right, anyway. You guys get the gist of it. It requires commands in order to play the game. Good looking game. I think it's wonderful. So I want to talk a little bit about some of the other games that I brought with me. Yeah, here we go. So let's talk about Ultima for a second. The reason why I bring up Ultima is that Richard Garriott launched Ultima, and I heard from Ken that the one person he wished he could continue to work with was Richard Garriott. So if you see, this is actually labeled Sierra Venture on it, because this was a Sierra Online release of Ultima. So what happened was Richard Garriott and his brother had a business meeting with Ken Williams and was able to negotiate that they developed the game with a box, with a cloth map. And these are all expensive items to add, but these feelies made their game very special. And they also got a very favorable royalty deal. And when IBM did go to Sierra, they wanted something similar to Ultima, which again is a game that I was more fond of for its Dungeons and Dragons style of play, and the fact that it had this open world style. And when Richard Garriott launched Origin Systems, he left Sierra, and Ken feels pretty sad about the fact that he couldn't continue to work with him, because they went on to do some really great things. Another game that Sierra launched, and this is probably the one that I was most familiar and loved, was Space Quest. Woo! Space Quest 1. And I got this black box edition of it. Super, super rare. First edition, Space Quest 1, black box, love it. And this was a very successful series for Sierra. They had many other titles throughout the years that really took them to places that I wish I went as a company, selling hundreds or maybe millions of copies of games throughout the years. And over here we have the rest of the games that I brought, but the one in particular, just give me 1 second, I'll grab it. This is one of the later releases here, is Gabriel Knights in the origami box. Pretty rare, expensive game to acquire. Also a Sierra title. So they worked with a lot of different artists and were able to, do things that were legendary in the industry and historic today. I'm sorry that they don't exist anymore as a company. I believe Activision purchased them out. But I'm very, very lucky and fortunate to have had them in my life as a gamer. It definitely shaped me as some of my comedy, some of the storytelling. I just love what they've done. And I mean, that's kind of the gist of it, guys. I guess I'm going to show also here. I went a little out of order, but they also had a couple other titles on the PC Junior that were cartridge based, which is kind of neat. So if you look inside here, they didn't just have diskettes, which made the PC Junior kind of different, that it also had cartridges. And I'm guessing that was influenced by the video games companies like, the Ataris and the Commodore with the VIC-20 and the Commodore 64. Everybody wanted to have cartridges. There's not many titles that are cartridges for this system, but Sierra Online did make a couple of them for the IBM PC Junior. And I just thought it was interesting that they changed their name around that time when they worked with IBM, because originally they were called Online Systems. And I guess when they moved into the Sierra Nevada, they decided to rename their company Sierra Online. All right, guys, there's not much more I could say about it.
So we're going to open it up for questions in a minute. I just want to really just show some of this collection here. So this is kind of cool if you're really into like Sierra stuff. So
the Space Quest 3 has the mask in it. It's unpunched, so that makes this particular copy pretty rare because it's complete with the little unpunched, ridiculous mask with the pig nose, which is kind of the inside joke of the designers. So that was kind of neat. I was lucky to get that one. And collecting games is fun. And another thing about collecting games, playing games, is that I remember my parents used to give me a hard time whenever I'd play games on computers. When something's fun, you want to do it. So I learned computers by playing games. And for me, it was an important part of my education. I wasn't a book reader, so I would play games like Ultima that helped me read and write, because I have to take notes and things like that. So I really don't think downly on people that play video games, especially as a 3D modeler and using these 3D games. Designing in 3D is pretty much playing video games. So that's one of the reasons why I'm a big fan of the games. And it's just fun and nostalgic to see and touch these things that have been part of my life as a child. Ultima in particular, had a real huge impact on me. And of course Space Quest and all these other ones. And to go find these games in the wild and get them, it's an adventure. Just when I got this King's Quest, I literally drove 250. I don't drive 250 miles for nothing, but I went for these two games in particular. It's just wild to me. And how much time do I need more?
No, we're really just opened up for questions, but I have a few questions myself. So at the time, back when did you, you said you were really into all this, so were you playing them on a Junior, or did you mention, or you were playing them on a 64, or what were you playing all these games on yourself?
That's probably one of the reasons why I didn't play King's Quest 1 was I didn't have IBM computers until later on. I was more of a Commodore 64, Commodore 128 guy, and this game was too advanced graphically and code-wise in order to run on those systems. I only got into Sierra games once I got an IBM compatible and started playing Space Quest and Police Quest, and that's how I knew about Sierra as a child, as a company.
Okay, so you matured and determined that you grew away from the Commodore into a real machine like an IBM.
I really wanted to.
I'm waiting for the pitchforks to come out now and come after me.
No, Amiga's great though.
Yeah. So it's really an amazing collection, and I personally am not someone who generally collects video games. I happen to have some, so
Right.
it's really interesting to see. And I didn't realize, some of these games that I probably threw out when I was a kid, or maybe had an illegal copy, were are worth so much money now. I think
It's unbelievable how much some of these things go for.
So I would advise everyone to take care of your boxes.
Yes.
And don't leave them in your basement.
And don't leave them in the sun because they do fade. So this Gabriel Quest faded a little bit from the sunlight. Whoever had this on a bookshelf probably with sunlight. And you don't want it to fade. So you want to keep them off out of the sunlight, and definitely want to preserve it maybe with an acrylic case or magazine bags is a good way to also preserve them.
Wonderful. I do keep documentation, so I tend to keep them in acid-free stuff, but I guess, it's hard to kind of fit them in those kind of things. So we do have some questions that have come in. So Amiga Bill, I think, wants to know, are you going to play through King's Quest now that you have a copy?
Absolutely. We're gonna, and maybe Amiga Bill can join me and we'll play it together, because I would love to go through the whole game and play it all the way through and be the first time experience playing the game.
So another question has come in. Do you have any tips? Apparently you've got a great collection. Do you have any tips on kind of where you can find this stuff? And because it seems you've been finding some really interesting things. And do you have any tips? How do you find this stuff? Where do you get it? It's great.
So a wizard never shares his secrets. Okay, no. The best place I find gathering large collection of games at one time for good prices is Craigslist and Facebook Marketplace. Craigslist is a little slower, and it has less action. Facebook Marketplace has way more action, but you got to be quick because everybody's on it and everybody's looking for it besides you. Another tip is you got to be constantly looking. Don't give up hope. Just keep searching. But here's the real thing. I live in New Jersey. New Jersey is, I think, a tech center in some regards, especially back then. You had Commodore that was in Pennsylvania, you had IBM was here, you had all these different companies, you had New York City, and people loved to buy technology back then and have these collections. So if you're out somewhere in Minnesota or somewhere, you're not going to find it as easily as I am, these collections. But don't give up hope. Keep looking and be willing to go 250 miles to go pick up a video game. Also eBay, but eBay is also nicknamed ePay. You're going to pay some bucks over there. You're not going to get big collections. You're just going to get items to fill your collection. So is there anyone that I have here? Yeah, so my Ultimate 3, I did get that on eBay. But be careful because there's a lot of scammers and you want to be careful. I find that Facebook Marketplace, when you meet the person, it tends to be a little bit more authentic, and you know you're not buying something that's a knockoff.
Well, we hear you're kind of like the American pickers of the Amiga users group, so we know you have some skills at this and some good luck. Another question that I guess people are asking, I guess Telemonster asked, so do you, when you play these games through, do you use the cheat books? Do you have the matching hint books to get through all these? Because I know when I was playing these games back in the 80s, I had all the cheat books because let's face it, I hit the snake in some of those things and I can't get past it, and I had no patience, so I had to cheat.
So I had a bulletin board system. I was part of the Humble guys with LSD and the Slave Lord, and we had a network of message boards. A lot of the tips I would get were actually in those early message boards back in 89, 90. I definitely needed the hint books, especially the Sierra games. Ultima and these other games, I would take notes and just like I said, it helped me read and write as a child because I was forced to having to take notes on these games. But definitely needed the hint books. And when we do this playthrough, I'm going to keep a walkthrough. I'm going to try to play it without the walkthrough, but I will keep the walkthrough next to me just in case.
Well, thanks very much. We've really kind of learned a lot about how we can find this stuff, because that seems to be the question we get from a lot of people. Is, wow, that's an amazing collection. How do you find this stuff? And it's just amazing to see. And and I'm so happy you were able to show off the PC Junior kind of the most underrated computer at the time, because everyone makes fun of it, but at the same time, Coleco thought they could make a machine, and theirs failed as well. So
this is the first time you're using it, and I'm very impressed with the system. If I had this in 1984, I'd be bragging about it. I'd be showing it off to my friends, and I'd be very proud of it because it is a very capable machine. And it's a shame that it goes down as considered as a failure, but not in my heart. In my heart, this is a successful machine.
Well, thanks very much, and look forward to seeing you at future VCFs.
Thank you very much, guys. Looking forward to being here and doing a lot of things with VCF. I love you guys. Thank you.
All right, thank you, Marcus Mera, and he had the IBM PC Junior and all that great box software from Sierra Online. That was a great presentation. Thank you, Corey, for doing the camera work and questions there. Next up, we have Ken Williams, who was one of the founders of Sierra, and he's here with us. He's going to give a presentation, and they take questions afterwards. Welcome, Ken. How are you doing today?
Very good. Very happy to be here.
Yeah, we're happy to have you too. People were kind of not sure that they read that right. Ken Williams is going to be on there. How is that possible? He's like a very famous guy in vintage computer history.
Well, okay. Thank you.
All right. So you ready for your presentation here?
Sure. Why not?
All right.
Let's do this. Am I on? Am I doing it? Is this it?
You're on live, and everybody
okay.
Watching you now.
Greetings, everyone. I'm excited to be here and talk about Sierra Online. And and thanks everybody for remembering us. I mean, the company, basically my role at the company ended almost 25 years ago, but people still remember it, which is kind of amazing. What I was going to do, give a quick history of Sierra. Talk about what it was like developing games in prehistoric times, 1979. I just wrote a book about Sierra, and I'll probably plug my book, and then I'll take some questions from anybody that has any questions. Quick story, founded the company in 1979, ran it for 20 years, started developing for the Apple II. We shifted in 83 to the PC, wanted to keep going on the Apple II, but it really wouldn't do the graphics and didn't have the horsepower we needed, and the Mac never really took off as a game machine. Let's see, we dominated. I mean, we really kind of owned the PC entertainment market toward the end of the life at the company. We had around 1,000 employees in 1996 when I sold the company. Yeah, and a lot of the book is about the sale of the company and what happened and why you haven't heard of Sierra today. Products, most people know us for the adventure games, and we're still kind of considered the adventure game company. But we did a lot more than that. We had a lot of flight sims, productivity products. I was trying to push us deeper into education. We had action games. Half-Life's one people have heard of, Leisure Suit Larry. We were divided into a bunch of divisions, and a lot of what I did was just fly around and meet with the different divisions. My life, I used to describe myself as a professional airplane rider. And that's what I did, because some of these, like Cocktail Vision was in Paris, and I had to go over and visit them, and Papyrus was on the East Coast. So that was what we did. And during the years that I ran Sierra, as you can see, it was kind of a transformation, starting as kind of a hippie living in the woods, having fun, and then becoming kind of the corporate type as the company matured. So big difference in culture at Sierra over the years. Anyway, I'll go back to 1979 when I started Sierra. Really, I had never seen a computer, and then I happened to run into the TRS-80 and thought it was pretty cool machine. Bought one. And at the time, it was only a cassette drive. I was loading programs off of cassette, and I kind of had this vision at the time of programming a Fortran compiler for the TRS-80. We used to call it the Trash 80, and I assume people still do. But Microsoft had written BASIC for the TRS-80, and there were no other programming languages. And I'd been a computer programmer in LA for years before that. and doing compiler development, and wanted to see if I couldn't put a Fortran compiler on the TRS-80, and started on that when the Apple II came along, and wanted to. Well, my wife got involved in Roberta Williams, who many of you might know. She started playing a game on a teletype machine I had that was called Colossal Cave, that was running at MIT. And she played it, and she thought it was pretty fun. And even on the TRS-80, we grabbed some of, I think it was the TRS-80, it might have been the Apple II. A guy named Scott Adams had written some text adventure games, and she played through all of those, and then started lobbying me to dump the Fortran compiler and start working on a game for her. And and then she upgraded me that year from my TRS-80 to an Apple II, which was a much better machine. And the best part about it was that it suddenly had a floppy disk drive. And coding off a cassette tape was not very practical, but suddenly I had the Apple II and it had a floppy drive, and it was pure heaven for me as a programmer. And she wanted me to do this game that she had talked about called Mystery House, that was going to be a kind of a murder mystery type game. And she took me to dinner one night. Actually, she pitched me on the game, and I said no, because I was too busy with my Fortran compiler. But then she took me to dinner and started talking it up and got me excited about the idea of doing the game. But the Apple II, as powerful as it was, wasn't quite ready to do games, or at least I didn't think so. Especially, she mapped out the game with like 80 different locations. If anybody's ever played an adventure game, you go to various locations, solve puzzles, and then go to a new place. And she wanted, actually, I think I was the one that suggested pictures. And then when she got all excited about the idea, I realized that I probably shouldn't have said that, because it was impossible. And but then I kind of had the idea of doing vectored graphics, which is pretty standard these days, but in 1979 nobody had heard of. And how you get those in. She kind of drew like this house on a piece of paper, and there was something called a VersaWriter sold that was based. It looked like a joystick to the computer. It gave me an X and a Y position, and so I had her take her hand-drawn drawings of each of the locations in her game, tape them to this little VersaWriter, and then move that little arm around, pick different points, and mark endpoints. And I discovered that by focusing on endpoints of lines instead of the entire line, that it would condense an entire picture to 50 to 100 bytes. And that allowed us to do hundreds of locations and put it on a floppy. And the floppy disks, for those that have coded for those old drives, didn't hold a whole bunch. And I forget what it was. I think 100K, something like that, which is not a lot of data when you got to fit the whole game on there, plus the operating system, plus everything else. We started marketing it. This was we kind of put together ourselves, and it's pretty ugly, but it worked. In fact, what happened was I was still working on my Fortran compiler, and Moore did the game to kind of get her off my back. It was and even it was what worked out really nice for us was that because I didn't really want to have to code the game, I'm more focused on creating tools for her, who was a non-programmer, to build the game. So I gave her, in effect, she coded by using plain old yellow notepads and writing down things. I told her just make a list of the rooms and then start a new page and make a list of in each room or location what could be done in that room, and then start another page and write down what commands she wanted the game to react to. And then I gave her a little word processor to type things in. So I just focused on writing tools. And the beauty of that was once she had done the game and it took off, then we could do other games using all that same methodology or those same tools that I'd written. And that's why this one isn't labeled. It says high-res adventure. There wound up being a high-res adventure 2 and 3, and then we went back and did a 0. But she kind of developed the game herself. And when we had an early version of it, I took it to a store, and I was still busily working on my compiler. And the computer store in Northridge, suddenly everybody loved her game and nobody seemed very excited about my compiler. So it became pretty obvious we were going to be a game company, not a compiler company. So, and Mystery House, when we shipped it, sold crazy well. Insanely well. I don't remember how many copies we sold, but it was in the tens of thousands. And we were living at the time in LA and hating LA traffic and kind of had this vision of raising our kids in the woods. So we moved up to Yosemite National Park, just outside of it, in a little town called Oakhurst, and started doing more games and started publishing games for others. And one thing that became pretty apparent was that the black and white and vector graphics wasn't going to excite too many people too long. So Roberta started pushing me for color. And I took a look at doing a game called Wizard and the Princess. And I look at this now and it looks pretty horrible. And I forget that it was the basis for the company. But the Apple II at the time really didn't do color. You could kind of pull off color by taking advantage of the artifacting. And I remember when Wozniak kind of saw this for the first time, he was kind of surprised. He hadn't thought that the Apple II would do these kinds of graphics. And as you can see, you see kind of the checkered board approach. And it was because within a given byte, you could only get, I think it was either purple, green, or orange and blue. So you can see that like the worst possible case was when you had something blue next to something green. And and you could also see that because there were so few colors, what I did to simulate more colors was to mix in blue and black dots or green and black dots to get like a dark green or a dark blue. And and this is still vector drawn. This was done on the old Versa writer that I showed in the prior picture. And you can see that, and the other thing that would happen was I could color things in by having Roberta take that Versa writer and click anywhere within a hollow area on the picture and it would flood color outward. And the Apple II was so slow that you could actually watch the color get drawn in those days. So I was constantly trying to optimize those routines to get the thing a little bit faster. And I wound up writing a book that still probably those of you who are trying to code for the 6502 called Apple II Computer Graphics. And it's still available. I bought a copy when I was researching my new book just out of curiosity, and I found it on Amazon. And it quickly was pretty boring. I'm not going to code for the 6502 again anytime soon. One of the magics of Sierra in the early days, I mentioned that we started by doing tools, and it became, I guess because of my background, I'd been in compiler development, and I was always focused on building technologies that other people could use to produce products. And so when it came time for the Apple II, I was very interested in being able to use a higher level language and came up with something called the Adventure Game Interpreter. The original games, the original Mystery House and Wizard and the Princess and Cranston Manor, and I think even Time Zone were done using that same, where they had used a yellow notepad and kind of in effect code by making up series of tables that the game would interpret. But then at some point, we started coding for the IBM PC Junior, which was a little higher horsepower machine, and we wanted to do animation. So for that, we wanted to build our own kind of procedural language. And by having our own programming language, and there was nothing in those days. I mean, I couldn't have coded in C if I'd wanted to. And if I'd had, I mean, maybe we could have, but I don't think so. I mean, we kind of had to invent our own language. I mean, today if you code, you have your own, you have Visual Studio and you have interactive debuggers, and none of that existed then. But I guess because of my background, we wanted to build our own programming language and compile it to, at one point I coded a language called Pascal, and the way Pascal worked, it was kind of a C-like language that compiled to something called P code, which was, it was like an assembly language for an imaginary machine. And that was the approach we took, was that we did our own little language and we compiled to machine code for an imaginary machine. And that was nice because at that time, hardware was changing so fast that in order to adjust to the new changes that Apple would do as they, as they would transform their hardware, and as the PC came along, and the PC was kind of a moving target, by having our own little programming language, we were able to keep up with it. And that was part of what made Sierra always kind of ahead of the pack, is that we had our AGI programming language, and then later we did a major update to it and called it SCI. And most of our games are coded in our internally developed language, and that allowed us to move faster from platform to platform. And with that, I should mention my book. For those that don't know the story, the quickie recap, this was just a picture somebody sent me of their having bought my book, which is available at Amazon. And if you go to kensbook.com, it talks about it there. But Sierra went through kind of a crazy time, and that from Roberta and I starting it, it grew to 1,000 employees scattered everywhere. We really owned the charts. And I remember we even had a competition versus Electronic Arts, where we were going to give everybody in the company 10 shares of stock on the day that we passed Electronic Arts, and we did that, a couple of years before we sold the company. But then we sold the company, and that became a major fiasco, and that the new guys kind of locked me out, I guess, or took me out of the action, and thought they knew more than me, and that didn't turn out so well for anybody. And today, other than I think King's Quest, there's still some games being made, and Leisure Suit Larry, but overall, Sierra's pretty dead. And with that, I'll take any questions if anybody's got any.
All right, so Ken, thank you for that presentation. And I think you were surprised about how excited people are to see you, because I think a lot of these games that people played, it was very personal to them. They spent many hours as a kid or maybe as an adult playing these games, and it was really special to them. So I think that you being the creator of a lot of these games in the company, I think, is why there's such excitement about it.
It surprises the hell out of us. I mean, like when I sat down to write the book about Sierra, I figured, who could possibly care? And really thought I was writing it, maybe for our kids or family or something. And then suddenly, when it came out, there was a couple of thousand copies the first day. And that's kind of humbling, I guess, for Roberta and I. We really didn't expect that. So there's still a lot of people that, even though it's been 25 years, that still think of Sierra. And we got all these emails and postings and stuff about how a lot of people are in software engineering or game design because of Sierra back in the old days. So it is it's pretty wild.
All right, Chris has some questions to ask.
I just want to say, as soon as you mentioned your book, which I had never heard of before, I did a search for it. And I found a PDF online and downloaded it because I'm trying to teach myself 6502 machine language. So I'm looking forward to reading through that. We do have some questions. Which of your tools was the most challenging tool to create?
Well, I mean, in the beginning of the company, everything was. I mean, so I mean, there was different times, like at the beginning, writing that first interpreter for Roberta, because there wasn't even an assembler in those days. Or I guess there was. There was Lisa that we wound up marketing, or Liza, I think I pronounced it, which was the 6502 assembler. And, if you're learning 6502, is that what you're using to code, or is that still the assembler? Well, I guess I don't know. But
yes,
yeah, that's still it.
People coding in 6502. So yes, I guess you don't have a real conception of how pervasive the vintage computer community is, and it's growing every year. So yes, there's a lot of people that code in that. I don't know for a job. I don't know how much it's done, but I know definitely in the hobby, it's
wow.
A lot of people using it a lot.
Yeah, I remember it was a cool processor and fun to code for. So no, at the beginning days, I mean, that was probably the toughest thing to do, was just to do anything. I mean, because there were no text editors, there were no graphics editors. No matter what you wanted to do, you had to do it yourself. Even Well, and I remember Copy Protect, because at that time you could talk directly to the hardware, and reverse engineering some of Apple's code and trying to copy protect the disks and creating a whole industry out there of hackers. Kind of the day we'd release a game, would have to figure out how to reverse engineer it and get at it.
Yeah, that was the one thing that I mentioned yesterday. Was I wanted to do an exhibit, and the exhibit would be on the battle between the pirates who would defeat the copy protection and the companies who would make new and more difficult copy protection for the software, and then the copy program manufacturers, software developers that would make software to defeat that, for people that are less adept at hacking. So that was something that I thought was very interesting.
Yeah, people don't relate to it today because on the internet, it's much easier to kind of lock down whether or not people bought or not. But in those days, it was a floppy and people could go over to their friend's house and copy the floppy. So different world. Well, I went through it with my book. You write this book, my most recent one, and I tried to decide, do I really want to put a PDF out there because they're so easily moved from person to person? And then I thought about it and I said, I don't really care. I'm not trying to make money on the book. If people pirate, and there's not much you can do about it. But because there's no way to copy protect a PDF, I don't think. But anyway, sorry. What
Well, that's
else
very
you got in there?
generous of you. I'm sure we definitely appreciate that, and we definitely try to share information when we're not infringing on somebody's intellectual property. So we appreciate it. A few more questions. Could documentation on those internal tools be posted 30 years later, or did EA took everything and buried it?
There's websites. If somebody Googles the three letters AGI and then Sierra or SCI, I think AGI stood for Adventure Game Interpreter and SCI for Sierra's Creative Interpreter. And if you look for those, you'll find them. And they're out there. There's websites dedicated to them. People reverse engineered our code. And I noticed for like AGI, that there were hundreds of games that people had built using our old Adventure Game Interpreter. And it was pretty powerful for the time. It would do a lot of stuff. So all that stuff seems to be out on the web. Even our animation editors, graphics editors, I found a lot of broken links. I wanted to go out and kind of play with it myself. But, and I'm sure that if I had hunted around enough, I could have found stuff, but it's out there. Yeah. The internet's an amazing thing.
I think it's possible that this person was asking, do you personally still have the original information that you would be willing to post? That at least that's what I would thinking when it goes through my head. Like,
I know, I
the
don't.
legit, original stuff.
There was no cloud to back things up on in those days, and in fact, I found when we were going through our warehouse a plastic tray with a bunch of my old floppies on it. And I wondered what was on them, and but I never took because I didn't have an Apple II with a floppy drive, and we kind of took an old warehouse that we had full of stuff that Roberta and I had, just shipped it off to a museum in New York, figuring maybe they could do something with it. But I don't know if they ever actually booted all those floppies to see what was on them. But we personally have really nothing. Al Lowe kept the old source code to all of his games. He wrote Leisure Suit Larry. And it was funny in that there's a story in the book, or most people I think kind of know it, where he tried to put the source code to his old games online on eBay and offer it for sale, the original floppies with all of his source code. And kind of overnight, it was valued at like $10,000. And he got a nasty letter from Activision, who currently owns the rights, saying, don't do that. And he had to pull it offline. But there's a lot of interest in that old source code and those old utilities. But no, I don't have anything. I probably should have kept it, but I'm kind of a by the book guy. And when I left the company, I signed one of those pieces of paper saying I wasn't taking anything with me. Like, I'd love to have all my old email and stuff, but I don't think any of that stuff exists anymore. So.
Yeah, if only we had known what the future was going to look like. So another question: how many people worked for Sierra during the original days?
Well, I mean, the original days was me and Roberta. You know, she did the design, she did the art, I did the coding, and we it probably took. I'm trying to think. Probably the first year we grew to like 50 employees or something, and it was kind of cool. We were up at there's a book, another book about the early days of Sierra by Stephen Levy called Hackers. That's kind of fun because it talks about the very founding when we moved to Yosemite and started hiring really young kids. I mean, we had kids as young as 16 and 17, and we rented a house and put all the programmers in it. And we had all these young guys that would kind of party and write code. And then we had some crazy times, like when the author of a game called Frogger lost his source code toward the end of development. And there was no cloud at those days. And there were no source control systems. None of that existed. If you lost your floppy, you lost your game. And he was pretty depressed getting it. You know, I imagined that, you know, when I was writing my book, I thought, boy, if I lost my copy, what would I do? You know, it'd be tough to go back and do it again. So what else is that? Well, no, we grew. I mean, God, it was like kind of we grew to about 130 employees in '83, and then we kind of hit the skids briefly, and then fired up again, and then kind of nonstop grew to like 1,000 employees.
So. Oh wow! Were your games successful outside of North America, such as in Europe?
Yeah, we were. We at some point. I realized that there was Europe out there. We had been kind of licensing our games to people, but I don't forget what year, maybe like 91, something like that. We acquired a company called Cocktail Vision that was based in Versailles over in France. And they started converting our games to different languages and distributing the games in Europe. And by the time we sold the company, over half our revenue was coming out of Europe. So we were pretty happy with that. It was huge. And a lot of it was because of this guy, Roland Oskian, who ran our European operation and just did a fantastic job. So Europe was big for us.
Cool. So this question is referring to something called SCUM VM, SCUMM VM. And it says, yeah. Are you aware of it and or have you contributed to it? And then he goes on to explain a little bit what that is. But do you know what that is?
No, I don't know what it. I've seen the name.
It's a program which allows you to run certain classic graphical point-and-click adventure games and role-playing games, provided you already have their data files. The clever part about this is ScumVM just replaces the executables shipped with the games, allowing you to play them on systems for which they were never designed. That's interesting. Cool. So you're not familiar with that?
I wanted to see some of the old games and found by Googling that there are places you can go and play almost any of the old games. And I assume some of them are running on something like Scum or something where people have found ways to execute our old games. Since all of our games are developed, and like I mentioned, compiled to a P code, if somebody wrote an interpreter for any machine, then there it is, there it's running. So yeah, I think our old games, they're fun to play. And it was a different kinds of games in some ways because they were smaller, simpler, kind of, when I look at today's games and I look at, and I try to think, I got a weekend free, I want to go play the game. Some of these, I mean, it takes all weekend to just kind of get in the groove or figure out what's going on. Our old games are kind of fun. You just get in there and play. So
a few more. And thank you very much for taking the time to answer all these.
Thanks.
So this is a very personal one here. Ken, do you still have any of the old original game cover artwork? Looking for the ones my dad did for you, Duke Halbelt, Haubelt?
I don't have any of those. No, I don't know which
Duke,
game
right?
his father did. No, unfortunately, I don't know.
Okay.
Well, plus I was pretty removed when we started getting, where you've got 1,000 employees, you suddenly are dealing with a VP of marketing who deals with a director of marketing who deals with an art department who finally somebody that actually does work for a living gets involved. So no, I didn't preserve it. Like I said, I was kind of a by the book guy, so I didn't take any of that art.
Yeah.
And I heard that at the end of the company, some of the people took home artwork and luckily preserved it. And some of those old paintings are still around, but I don't have them. And I heard that 95% of that stuff was just taken out in the woods and taken to a trash dump. That it's really sad. I mean, we had all these carefully preserved archives, and people they weren't smart when they shut down the company. But oh well, depressing.
Did you actually see the Netflix High Score documentary when it was done? And if so, what did you think of the final cut in terms of representing your work and that history?
Yeah, it was funny when they called us. They came out to film, and were there for like a week and shot so much. And they, well, I don't know if they didn't know or they didn't want to tell us, but we had the impression that we were going to be like 2 hours or something because they shot so much footage, and they edited it all down to 10 minutes. And the beauty, I guess, of having 100 hours of footage to chop to 10 minutes is you get a really great 10 minutes. So when we watched it, we liked it, but it came and went pretty quick. And at the end of it, Roberta and I looked at each other and said, God, did they ever mention Sierra or any of our products? And we couldn't think if they did or not. So it was, that was kind of weird. It's fun footage. It's real entertaining. It's real short. And it doesn't, we liked it. I mean, yeah. And we watched Richard Garriott's segment. He did Ultima for us, and it was kind of fun to see him again. I hadn't seen him in a lot of years, but well, I don't know if that answers the question.
I think so. So there's a YouTuber called Metal Jesus Rock. His real name is Jason. He's been trying.
Oh, yeah.
He's been saying forever wait, I'm trying to read what it said here. You've been work on Sierra. Do you remember him?
I do. And apparently he went on to great fame and fortune as a YouTube influencer. So, I mean, it's great to see some of the Sierra alumni that actually did well. And he's one of them. And yeah, I watched one of his videos where he was talking about life at Sierra before I even knew that he was popular on YouTube, and you could sense the fun. So that was good. Yeah, and I wrote him, and then I discovered he's this famous guy. So what the heck? Congratulations to him. But I remember him from the old days working there.
Great. Do you and Roberta have a personal favorite from all the games you released? One that you are most proud of?
Roberta loves, she did this series kind of early with a female protagonist, which was kind of innovative for the time, called Laura Bow and Colonel's Bequest. And I remember at the time, everybody wondering, would players be willing to play a game where they're playing a female character? And that was popular, and nobody cared. Everybody loved it, enjoyed the game. And me, what's funny is I never really was a gamer. I liked working with people that developed games, but I was more of a technology guy than I was ever a gamer. I liked, we had a division called Dynamics, and I liked the flight sim, so I liked the pinball game. I liked their incredible machine. I mean, they did really nice stuff. So I was more a fan of their games.
Cool. I think I missed this question here. What was your favorite game to work on and favorite game to play, Sierra or otherwise?
Well, let's see. I talked about what I like to play as far as work on. The last game I really kind of worked on was, I think in Leisure Suit Larry, there were some gambling games, and I coded the poker game in there. And I coded at the beginning of Leisure Suit Larry, it kind of does a screening to figure out how old you are. And I wrote all that. That was kind of my idea. It was to keep kids out. But it looks like they're about to pull the hook on me. So I'll thank everybody and wish you well and enjoy the day.
One more quick one here. Can I still get my I Survived the Night at Mystery House t-shirt?
No. those are rare these days. I had one that was in our storage unit, and I think it went to the museum. Those were pretty cool shirts. We did some fun stuff in those days. You can see why we did well. So, yeah, I think that's it.
Great.
Okay.
All right.
Well,
Yes.
enjoy,
All right,
everybody.
Ken. Hey, thank you very much, Ken, for coming and doing that talk. It was a great surprise addition to our show. I'm sure there's going to be a lot more people interested in having questions in the Discord channel. So if you need me to tell you how to direct you to that, we can do that.
Yeah, send me an email and I'll flip over to there and see if anybody has more questions. And there'll probably be questions at the bottom of the YouTube, and I'll check there.
Oh, definitely, definitely. So, just one little side note. So, you had mentioned that about the book Apple II Graphics that you wrote.
Yeah.
You might want to, if you haven't already, look at Stephen Edwards' video that we did yesterday. He did for 30 minutes about Apple II Graphics. He might even have that book referenced in that video. I don't remember distinctly, but he might. So look at that one. You might be interested.
Yeah, I don't know if anybody still prints it or if when you buy it on Amazon, they're recycling old copies. I just placed an order and it came. So, kind of funny.
And next year we're going to have two themes, but one of the themes is tax adventures. So might be interested. I hopefully, if we have a live show in April, I'm hoping to get Scott Adams here. And also the guy who wrote Colossal Caves, William Crowther.
Cool.
So that's just a side note to you. And then that's it. Oh, thank you very much for coming and presenting. It's really exciting. A lot of people are enjoying that you're here and giving this talk.
Okay, well, thank you, and good luck with your show. And I hope by April the world is normal and you can do it the right way. So,
yes, and we're hoping for April. Thank you. Have a great day.
See you later. Bye.
Bye.
Where did I click?
Here we go. All right. That was wonderful. That was Ken Williams, and talking about his story with Sierra Online. He has a new book out, and you can find it on Amazon. What's the name of the book again? All right, you'll find it. All right.
hang on.
So next up, we have a Commodore Assembly Programming. It's a class.
Real quick, the book was a 1983 book, Apple II Computer Graphics.
Oh, I'm talking about his new book. He has a new book.
Oh no, I don't know.
But you'll find it. You'll find it online. So next up is Jeff Salzman, and he's going to be doing his Commodore assembly video. And you ready, Andy? All right, let's go.
Hello, everybody, and I want to get started talking about programming the Commodore 8-bit series of computers, specifically the Commodore 64 and the VIC-20. I'm going to be programming in assembly language. I want to teach some tricks on how to use the Commodore kernel to better affect some output on the screen and still have it somewhat cross-platform, I'll say. It's just going to be a short little program we're going to build up here to demonstrate a few techniques. You'll have to take it and run with it if you want to do anything more with it. But I'm going to be referencing a number of kernel routines that can be found in either Programmer's Reference Guide for the Commodore 64 or the VIC-20, your choice. They're both listed in there. Some of the routines I'm going to try out are the plot routine, which allows you to set a cursor position on screen to output text. The character out routine, which will actually output text. I want to go over the scan key to scan the keyboard, the get in to get a value that was typed in the keyboard, and the stop routine, which detects detects when somebody presses the stop key. So to get started, we're going to put some characters on the screen here. There's different ways I can do this in assembly language. On Commodore computers, screens are bitmapped. That means there's a range of memory that has a starting address and an ending address, or I can leverage the power of the kernel. The kernel has some routines that we can call within our own assembly language programs, and indirectly we can call them through BASIC, but it's it's a little difficult to do it through BASIC. You're still going to need some machine language hooks to do some things with some of the kernel calls. Anyhow, I'm going to get started here. I'm just going to write a little bit of code that will put the letter A on the screen after it clears the screen. And the letter A we're going to put, as I said before, the first row, the 6th column. But rows and columns are actually considered zero-based, which means instead of the first row and first column, it's row 0, column 0 to start in the upper left-hand corner. So if I'm counting the columns, first row, 6th column is actually row 0, position 5. I am going to be using the Hezmon editor. It's a very simple machine language editor and assembler, and I can enter 6502 or 6510 based assembly language straight from here using the regular mnemonics and the opcode configuration. So I'm going to demonstrate it in the Commodore 64, and I will also demonstrate it on the VIC-20. Reason why is because if I would write my programs using the screen RAM locations and try to figure out where at in screen RAM and color RAM, I need to put my values to put a character in place. The screen RAM locations are going to be different between the Commodore 64 and the Commodore VIC-20. If I use kernel calls, the kernel calls work exactly the same, because Commodore has what's known as a jump table for their kernel calls. It's one spot in very high end of the memory map that the calling address would be exactly the same, but when you call that calling address, it redirects your call to the actual code in the kernel ROM for that specific computer, but still gets the same job done. So getting started here, I want to write my program to clear the screen and put a letter A on, and I'll start using the zero-based values, row 0, column 5. And I need a starting address. I'm going to use address 1200. All these values that we're using here are going to be in hexadecimal. I'm not going to use any decimal values. So in Hezmon, along with a lot of simpler editors, I want to start to assemble a program from 1200. That's my starting address because I know the VIC-20 has available RAM at that location and the Commodore 64 has available RAM at that location, so my same code can be ported to the other computer. So starting at 1200, I'm going to load the accumulator with the value of 93. 93 is the hexadecimal value for the key code on the Commodore keyboard to clear the screen. So we load the accumulator with that value. And then to clear the screen, I just print that value using the character out routine in the kernel. And to do that, I'll do a JSR for jump to subroutine, followed by the address for the character out subroutine. In this case, it's FFD2. Next, I need to set the cursor where I want it to go, and to do that I need to use the plot routine, and plot requires two values. First, it needs to have a value in the X register, so we'll load the X register with the value 00. It's actually the row number. X gets the row number, and notice I did not put a $sign here. Now it's optional. It's going to be easier for me to type this way, and so I'll load the X with the 00. That means I'm giving it a specific value. That's what the $sign indicates, that I want to give it an explicit number and not retrieve something from a memory address. If I didn't put that $sign in there, then I would be asking it to load the value from memory location 0 as opposed to the value 0. So we have the row here, row 0. Now we need column 5, that goes into the Y register, LDY, and it's an immediate value 05. Now, the plot routine can work two different ways. The first way is we can put these values in X and Y and tell plot we want you to move the cursor, the print cursor, to that point, to that location on the screen. The other thing it can do is if you're unsure in your code where the cursor currently is, you can tell the plot routine to return the X and Y coordinates into the X and Y registers. And the way you tell it to do one or the other is if you want to set the position of the cursor and you want it to move the print cursor to where you specified, you would have to clear the carry flag first. That's CLC. If I wanted to read this stuff, I would use set carry to activate the carry flag, but CLC means clear the carry flag, and this is a prerequisite before running the plot routine. And the plot routine is at location FFF0. Next, with our cursor there, we want to tell it to print an A. To do that, we load the accumulator, just like on the first line, but with the value for A, which is a 4-1. And then we call character out again, JSRFFD2. And then, now that the A is out there, we're going to put a break code in here so our program stops the way it should. And that's all there is to putting the letter A on the screen in a position where we want to after we clear the screen. And to test that, we'll just hit G1200, means go to that address and run the machine code there. And you see up here, here's our A. It's in place. It's on the, I can't go any higher, so this is the first row, or row 0, and then 0, 1, 2, 3, 4, 5. There it is in the 5th position. Now all this stuff here, since we're running in Hezmon, as soon as we relinquish control from our own program, Hezmon takes over, and the first thing it does when it's initialized is set up all the CPU states and other information. So that leaves us here. If we do a disassemble, what was it? 1200 to, oh, where did we go with that? I didn't keep track of it. 120D. I think this shows our code. Oh, there we go. We can see our codes in memory here. I'm going to continue on. I only have 30 minutes to do this, and there's a lot of stuff I want to cover. Now the next thing I'm going to do is, okay, we have an A there, and it's in purple. So I want it in a different color. I want it in red. So how do I do that? Well, just like I can send a clear key press, I can also send a key press just like on a Commodore keyboard when you hit the control key and hit one of the color characters. So really what I can do with character out is I can send out anything that I can type on the keyboard as long as I know the code for it. So I am going to modify this code. I'm going to interject instead of here where I load the accumulator with my A, I'm going to start at 120D and insert 2 additional lines of code. First thing I want to do is load the accumulator with the value for the typing the color red on the keyboard, which is actually a 1C. And then I will JSR to character out FFD2 to send that out to the screen. And then I'll just type in again LDA 41 for the letter A and JSR FFD2. Alright, so looking at this again, let's disassemble 1200 to 1216. And there's our code. We just added 2 additional lines right here. This one will send, this is the code for red, and we send it to the character out. Code for the A, send it to the character out, and we'll go to 1200. Whoops, I needed to do something here. There's other code in here from before. I need to add at 1217 the break so I can tell it to stop. And we'll go 1200. Now it's in red. And so is the text from Hezmon, because the last color change that there was to the system, it was red. It stayed that way. Apparently Hezmon does not change the colors. It just rolls with the punches, so to speak. All right, so we have a red A, but we're not really going to be sending single characters to the screen at all times. That's kind of impractical. So how do we do this? How do we put whole words up here? Well, so what we can do is create a loop that goes through a sequence of memory, and as it gets each value in that sequence of memory, those values will be screen codes or character codes that go out to the screen. We just loop through that until we hit a stopping point of some sort. This is where the code gets a little more complicated, but it's actually still pretty easy. Now I'm going to clear memory here using the fill command. I'm going to clear all the memory I'm working with to zeros, just to prove that we cleared it, because I want to just type it all in again. See, those are all zeros. Zeros are actually break commands, or break opcodes. So I'm going to start from scratch using a similar code that I was using before, but I'm going to add some additional functionality to it. So starting at 1200, we're going to repeat a bit of what we did before, LDA 93 and JSR to FFD2, the character out. So that sends out the clear screen. LDX 00, LDY 05, clear the carry because we're going to use those values to set the cursor position, and then call plot to move the cursor for us. Next, we're going to reuse the Y register. Since we already used it for this, we can use it again now. And this is kind of how you do things in 6502 assembler with just a tiny little bit of processor registers to work with. Is we're going to first load at this point, when the program executes at this point, we're going to load Y with a 0, an explicit value of 0. Now with this, we're going to use this 0, this Y register, as an offset to a base address. And with this offset, we're going to tell the computer that starting with the base address, add the value of Y to it, and use whatever that adds up to as the address where you get our data from. And you'll see how this works as I go along. It's called indexing. So now I need a base address. What I'm going to do is I'm going to print the phrase "Hello World," and I need to store the characters that make up the character, or store the values that make up the characters "Hello World" somewhere else in memory. And I'm going to define that right now as location 1300. I think that's far enough away from our code that it shouldn't be a problem putting it there. So now that I loaded the Y with 0, I need to load into the accumulator a value from that base address plus the value of Y. And to do that, we do LDA, and it's 1300, or well, actually it's 1300 hex, comma Y. That's our index. So when it runs across this command, it's going to take 1300 and add the value of Y, and then whatever that adds up to, it'll pull the value of that point of memory. We're going to check to see if this value that comes in is a 0. A 0 is I don't want to say it's an unprintable character, but it's a character that we really can't do anything with on the screen. So we're going to add a 0 to the next memory location after that, that's going to be our stopping point. So when we load this accumulator with that value, with whatever's in memory at that offset, if it's a 0, the CPU sets a flag saying it's a 0 value. So we're going to make a decision. If it's 0, we're going to branch to another part of code. We're done and we want to go somewhere else. So now I've defined this earlier. I've done some manual calculations to figure out where this is going to go. So I'm going to put in the value right now. BEQ is a branch command that says branch if branch on equal, and it means equal to 0. And to make it work, you just give it an address you want it to branch to. And the address I'm going to is 121B, which is a little further down, and you'll see where it ends up. So if the value that's pulled into the accumulator is a 0, meaning we've got to the end of our hello world text, we will get out of this. Otherwise, any other value should be a printable character. So we're just going to, now that we have it in the accumulator, we're just going to go ahead and send it to character out, FFD2. We're going to print it. Then we need to bump up Y, the Y register, by 1. We do that by the INY command, which means increase Y by 1. And then we're just going to loop back and keep doing this over and over again. We're going to loop back to the line where we loaded the accumulator with the index address. So we're jumping back to 120F. That's the line that has the LDA 1300, and then finally, you see what line we're on, 121B. As I said for the branch earlier, 121B, this is where we're going to put our break to end our program. So this code here will do like it did before. It'll clear the screen, set our cursor position, and then start looking at memory location 1300 until, increasing the address one at a time with the Y register until we get to the end of the character sequence. But we're not ready to run this right now. We don't have a character sequence at 1300, and I can verify that by typing I for inspect 1300 to let's do 1310. Oops, okay, it's making a liar out of me. I preloaded some of this stuff, but I'm going to show you how to do it anyway. I didn't clear that memory out, so practice makes perfect. But let's just say I wanted to, well, okay, we'll do it this way. We'll fill 1300 to 1310 with zeros. Okay, now if we inspect 1300 to 1310, it's all cleared out now. So now I'll show you how to put that in. On this assembler, if I use a colon, all right, we'll do the right colon here. I think I have my keyboard mapped a different way. I am doing this through emulation. So I think the emulator changed modes on me. There's the colon. There we go. 1300. If this were a real Commodore 64, I wouldn't be running into some of these problems, but it's hard to get a nice clean video capture from a real Commodore 64. So colon followed by an address, followed by, in groups, in 8 pairs of hex numbers, I put all my values in, my converted hex values, to spell out hello world with an exclamation point. So the first ones are 48, 45, 4C, 4C, 4F, 20, that's a space by the way, 57, what we have here, we have 7 of them, and I'm sorry, yeah, 57 and 4F. If I hit return, you see how it's starting to build hello world in memory. Continuing along, after the 4F, it's 52, 4C, 44, and then 21 is the exclamation point, and we need to add 00 just for good measure. Alright, now if we inspect 1300 to 1310. There's hello world back in again. So disassemble from 1200 to 121C. There's our code. We already have our memory, or our phrase in memory at 1300. So we're going to go ahead and run this. And if all works out well, we will have hello world at the top of the screen. And there it is. And of course our program ended. All it did was just, this was in location 1300, this was in 1301, 1302. So that loop, using kernel calls to put this out, all I had to do was loop through a sequence of characters stored in memory that was elsewhere, and keep calling the same kernel routine over and over again. I did not have to keep track of what memory address it was going into in screen RAM. The kernel took care of that for me. And now I have one more thing that I want to demonstrate on this, and we're going to do what we can to let you change the color on the fly. Okay, for this last example, I'm going to go ahead and clear things out one more time. So I'm going to fill 1200 to 1230 with zeros. And wipe out our existing program. And with this one, I'm going to introduce a couple more kernel routines. One of them is the scan key to scan for keyboard press. I'm going to also do get in, and actually I'm going to do a third one. I'm going to check for stop. So starting off just like before at address 1200, we're going to do LDA 93, because we're going to clear the screen with a jump to character out with the screen clear code, and we're going to set or plot our cursor position with LDX 00, LDY 05. This is all getting familiar now, isn't it? CLC for clear carry, and let's jump to the plot routine. Then we're going to load the Y register with 0 to start our counting loop, and we'll load the accumulator with address 1300 indexed by Y, and branch, if that value is a 0, we'll branch to 121B to get out of this short loop. And any other character we're going to send to character out, FFD2, and then we'll increase Y and jump back to the start of our loop at 120F. Next, we're going to check to see if the user pressed the stop key, and that's really simple. You do a JSR to FFE1. That's how you call the stop routine. If what comes back is a 0, then the stop key was pressed. So again, we can do like we did before, checking for 0 with BEQ, and then we're going to jump to a once again predetermined location. Now I could put any value here and then come back and edit it if I don't know the predetermined location, but I have the predetermined location, so I'm putting that in here right now. If the stop key is pressed, this comparison will now jump us to the end of the program. Otherwise, we're going to run 2 routines in a row. The first routine is to scan the keyboard, and that's JSR FF9F. That runs scan key, which causes the kernel to check to see if a key has been pressed. And if it is pressed, it will put it into the 10-character keyboard buffer. It can buffer up to 10 characters in sequence. And then immediately after this, we're going to call the get in, which is JSR FFE4. 64. And get in will retrieve the next available character. It's first in, first out. Next available character in the keyboard buffer, and it will put it into the accumulator. Now once again, we can check for a value here, and we have to, because we need to know if we have to respond to something. If the value that gets returned by get in is, if there is no characters there, it will return a 0. So we're going to compare, and it returns the value into the accumulator, by the way, but we're going to compare the accumulator to an actual 0. And if they match, if it is a 0, then we use BEQ once again to branch to another location, 121B. In this case, we would branch back to where we check for the stop key again. So I can do this. We would branch to this one here, which will put us in a loop, checking for the stop key, then checking for a key press, and nothing like that happens. It's going to go back again, check the stop key, check for key press. It'll do this until something causes it to break out of the loop. So BEQ 121B, and then at this point here, if there was a key that was pressed, that value is sitting in the accumulator, and it's a printable value. So all we need to do now is send it out with the character out routine. And the convenience here is we don't have to put that character out call in here. All we need to do is loop all the way back to this line, or the second line in our code, and we start this whole routine again. So I will then do a jump to 1202. It means if a character's in there, it's going to jump back to that second line, which will call character out and continue us in a loop, in a much bigger loop. And then finally, BRK for break. Notice that this is 122D, and I said here, this is going to jump us out. If the stop key was pressed, it would go to the break. And this is our code. And that's all there is to it. It's not a whole lot to it, but it is functional, and it uses 5 kernel calls, or 5 different types of kernel routines. And I'm just going to verify that 1300 to 1310, that our hello world is still there. And we're going to go 1200 and cross our fingers that this works. There's hello world, but this time it's sitting by itself. Why is that? Well, we're looping through our code. That means Hezmon has not taken over control yet until we release our code. So there it is, hello world. And if I want to change its color, I can do so by holding down the emulated control followed by number. And you who remember the Commodore computers, they have those color codes on the front of the number keys, and you hold control down to get to it. So let's do control 7. There's the code for blue. Control 8, there's, I guess that's yellow. Control 2 is white, that's why it goes out, but it's still there. Control 1 is black, control 3, 5. So all these different colors are available now. Look at that. We can experiment here. What happens if we do control 9? Isn't that reverse on? Look at that. It's reversed. And reverse off makes it go reverse off. So neat stuff, isn't it? All that in just a handful of code, and using 5 kernel calls, and the same code will work on the Commodore VIC-20.
It's always 5 minutes when it's less than 1 minute.
Wake up, everybody. I know my low droning voice probably put some of you to sleep. I must say I was up 18 hours before I actually started recording that. I was about ready to fall asleep at the keyboard. One thing I did want to show, and one thing I said at the beginning of that video, is how these techniques of using the Commodore kernel work on the Commodore VIC-20 as well as the 64. I didn't have time to record the VIC-20 part, but I do have it live here. This is pretty much the same code that you saw at the end of the video, minus one thing. I do not have the code in here that checks for the run stop key to stop the program. I found that there is a bug somewhere, and it or just be the way the Commodore VIC-20 works as opposed to the Commodore 64. It's the same kernel calls, but it's different kernel code, if you know what I mean. So I just took that out. It interferes with what I want to do. So I'm going to go ahead and run this just to show you that pretty much the same code works on the VIC-20 because of the use of the kernel calls. There's Hello World. I hit Control and hit green. See how it changes colors and stuff like that? It's exactly what I wanted to prove, that if you wanted to start getting into programming on a Commodore VIC-20 or 64 and want to be able to quickly produce output for other people to use without having to manage all these odd RAM locations for screen and color memory, the kernel is your friend for that. So yeah, the bug with the stop key was every time I would change color, it would somehow exit the program. So it was like reading other keys and not just the stop key. That's why I took it out of this example. But anyway, that's what I wanted to get across. I hope was informative. I always like to learn new things, and then in turn I like to teach the same things that I learned, because I learned that stuff recently myself. And if we have any questions, if we don't, well then you're all still asleep, but do we have any questions, Corey?
So I'm asked into the room if they have any questions, put up on Discord or into microphone at VCF. So just give me a minute on that.
Okay. Meanwhile, I can continue from what I
actually,
Okay, go ahead.
I think I've had a VIC-20 sitting like in my loft for years, and it's just now you've inspired me to go take it and bring it out and plug it in. I think we figured out I probably have a really early one too. Because
you probably have the one with the 2-pin connector, so you won't have to worry about power supply issues so much, unless there's actual bad parts inside the VIC-20.
Cool. Yeah, I might have to. So we've got a question here. What references do you recommend to someone learning Commodore Assembly, assuming the person has programming experience in languages like C or BASIC?
Okay, there are books out there and from the day. You can find them in PDF format now on archive.org. There's a lot of references. I don't have a specific one because I look at a lot of different ones myself. I pull a little bit of information here, a little bit of information there, and I basically what I can find online in PDF format. However, if you want to learn more about the kernel calls and what they're capable of, and this is where I got some of my documentation, the Programmer's Reference Guide, they have one for the VIC-20 and one for the Commodore 64. They do have a whole machine language section in the middle. And this is how I actually first started to learn about machine language. So here's opcodes, other information, useful memory locations, and in here is, I should have bookmarked it. Here's all the different kernel calls. Like vector, which manages RAM vectors, that's a little bit more advanced stuff. The save kernel call, which once you set up certain things like file name and whatever memory, you can call this and you can save programs out to disk drive or cassette tape. So, and this details all the steps. So some of the stuff I was demonstrating, I kind of repeated from what was here. And this actually will help you unleash the power of your computer quickly if you wanted to get into assembly language and wanted to make the computer do stuff real quick. And then you can, later on, you can think about if you're like making a game, then you can figure out your logic and stuff, how you want to do math and other information in assembler.
So there was another question about, so what development environment for assembly were you using for the demonstration?
I was using Hezmon, which is a cartridge-based editor. Now here I have what's called VicMon. It was actually Commodore's version of Hezmon. Hezmon is actually a little bit better because of the way you can enter, like when I was entering the Hello World text, I can't do that on VicMon real easily, but I can do it easily on Hezmon. Any plug-in machine language editor, Hezmon has always been my go-to, and what I was demonstrating with is I was actually using emulation with the Hezmon cartridge image. So it's still like using the real thing with the real cartridge. But Hezmon is available for the VIC-20 and the Commodore 64. And if you want to do it on a real machine and you have extra memory available for it. You can actually get Hezmon as a cartridge file and load it up into RAM and use it that way. There's many different ways to get on the system, but you can do it in emulation. If you really want to play around, just get Vice, the Vice emulator, load up your favorite version, find a cartridge image for Hezmon, and load it from there. It'd be like you're using the real thing.
So actually, I have a question.
Sure.
So I'm looking at the cartridges, and as I said, I have a VIC-20. I really haven't used it. I think when I actually used a VIC-20 for real, it might have been in like 9th grade in high school. So I don't remember much detail about it. So I'm looking at the cartridges. Are those cartridges just stacked up, or are they plugged into each other?
Well, yesterday in my presentation of the Ultimate VIC-20 setup, I had this device that lets you it's a multi-cart expansion. So it's a board that goes into the expansion slot and gives you additional expansion slots to put a cartridge, to keep them all in the same spot. And there's a reset button here that I can use. I don't have to turn the computer off and on all the time. It wasn't working yesterday, and I found out overnight what the problem was. It had a bad fuse. It has a little power fuse in there, and it looked good. The wire was clean, but it was actually broken somewhere behind the end, so I couldn't see it without testing it with a multimeter. I replaced the fuse, and now it's working. So I have extra memory here. I have the VicMon assembler program here, and then I have that right now that I was doing with the word processing. I can hit the reset button, which is hidden behind here, and I can launch right now using the command that they expect you to write to make it work. And I can launch, after hitting reset, I can launch VicMon by issuing the appropriate address. There's VicMon running. And if I want the extra memory, there's a few dip switches here. I have to switch one to turn on the RAM pack, and I go from 3,500 bytes free to nearly 20K free. And I don't have to pull cartridges, and I can put my favorite 3 cartridges. I can even make a game. I can put a game in one of them and just switch to that.
It makes it very convenient.
It is very convenient, and it saves wear and tear on the expansion port.
Have you figured out how you would transfer a program that you wrote in machine language to a cartridge so that it would automatically run?
Yeah, if this were actually an in-person live event, I'm actually working on a cartridge to teach myself more about VIC-20 machine language programming. I was actually creating a demo cartridge to show off some of the features. Because of everything that's going through, and this is becoming a virtual thing, I had to do things differently. I wanted to write software in assembly language, create an actual file, and then burn it onto a EEPROM and put it on a cartridge. You can actually buy blank boards out there that will fit in a VIC-20, and all you have to do is solder on a EEPROM socket and have some way of burning your file onto the EEPROM, stick it in the socket, goes into the Commodore, and works just like any other cartridge. Got to do your homework a little bit, but it's out there, and there's plenty of people out there to help you figure it out, because that's how I'm learning this stuff too.
Well, thanks very much. And I really appreciate you put a lot of time into this, and you really are putting, I want to say the word hybrid into all this, and that you did a recording and you're doing the live as part of a single one, not just yesterday's live presentation.
I wanted to get a point across. Thank you very much. I enjoyed every bit of doing this, and I hope people get some ideas. Roll with it. See what you can do with it. If you have any inclination or personal expectations, just go with it.
Well, thank you, and I guess it's time for us to move on to the next presentation. So thank you.
Hello again, this is Jeffrey Brace from Vintage Computer Festival East 2020, our virtual show this year. That was Jeff Salzman, and he was doing Commodore VIC-20 assembly language programming. That was wonderful. So now, next up, we have Bob Roswell, and he's going to show off early calculating devices at his museum in System Source in Hunt Valley, Maryland. And without further ado, Andy's going to start the video.
So welcome to the System Source Computer Museum. I'm Bob Roswell, founder and one of the curators. My cameraman today is Brendan Becker, and he also has a museum here with focusing on music and games. So come visit us when you are able to here in Hunt Valley. Today we're going to talk about when computers were human. We're going to talk about the calculating aids that human beings used to do addition, subtraction, multiplication, division, and of course more complex things after that. Over here, we're going to start with the very first artifact that we got for this business. I told my college roommate that I was going to open up a computer store, and he said, ha, 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 here's your first piece of inventory. And of course, it's an abacus. And this was in 1980, so there was no internet. So I went off and I bought the book. And I read the first 3 pages of the book, and the book doesn't work. What I didn't know at the time is that, like the title says, this book is about a Japanese abacus. So here's a Japanese abacus. You'll notice it has 4 earth beads and 1 heaven bead. This is a Chinese abacus that has 5 earth beads and 2 heaven beads. So being, of course, a total nerd, I went out and bought the right book for the wrong abacus and the right abacus for the wrong book. Further come to learn that the Koreans have a different variation of the abacus. This has 5 earth beads and 1 heaven bead. And the Russians have a shaki, which looks like this. These are the 1s, these are the 10s, these are the quarter rubles. So that's why there's 4 beads there. So lots of different ways of using an abacus. There are, on our website, you can use most of these online, but I'm not going to demonstrate them today. The next thing we're going to take a look at is Napier's bones. So this is John Napier. He was born in 1550 and he died in 1617. He's known in mathematical circles as the discoverer of what today we would call logarithms and exponents. So he discovered them. He discovered that if you added exponents, that was multiplying. And in the late 1500s, he built calculating devices that made multiplication and division much easier. The original ones were made out of ivory. We're not going to kill any elephants here. So ours here is a wooden replica. So I'm going to pick a 3-digit number. Here's 867. And the way we use this is 1 times 867 is 867. That's the easiest case. A more complicated case here is 2. So that's 1, add across the diagonal, 7, 3, 4. So 867 times 2 is 1734. It can get more complicated when we have carries. So I'm going to start here with 867 times 6. I'm going to make my life easier and start over here, 2 in the least significant digit, 0, because 6 plus 4 is 10, carry 1. So that's 11 plus the carry is 12, so 2, carry 1. So it's going to be 5, 2, 0, 2. And that's how you would use Napier's bones. Of course, it works with any number at all. So here's 867,831 times 6 is 8, 9, 6, 0, 2, 5. And if I have to do a 2-digit number, I offset them just like you learned how to do multiplication as a child and add up each partial. So that's Napier's bones, late 1500s. That then led Arkwright to develop the slide rule. Those of us in our mid-60s and older probably used these while we were in high school or college or even in our professional lives. In my early 60s, so I was in the last class in my public high school in New Jersey that was forced to use slide rules. We couldn't grab a shot over. When I took honors chemistry in 10th grade, we spent the first 2 weeks, the teacher had a large slide rule like this, and we sat at our desk with our small slide rules, and we learned how to do multiplication and division and all the other things we needed to do to put our molds together or whatever we were doing in high school chemistry. So that represented a really long era, early 1700s until electronic calculators really hit in 1972. Slide rules have two major problems with them. The first, which was never conquered, is that you have to have another algorithm to keep track of the decimal places. So 3, 30, 3 billion, 3 trillion, they're all in the same place on the slide rule. So that was a big problem for all of us who use slide rules. The second problem was resolution. So there's a very small space here between 90 and 100. So that little piece right there is 95. One dot over is 96. Not much space to see the difference between 961 and 962. So that was a problem. We can get approximations on a standard length slide rule, 2 to 3 digits, depending upon which scale and where we were on the scale. So what you can do about that is make the slide rule longer. You get more resolution. That might give you another half a place, one decimal place with a longer slide rule. And over here we have Thacker's instrument. So this is sort of the ultimate slide rule. So Thacker in 1891 got a patent on this device. What he did was he took that slide rule and made it 40 feet long. Obviously, if it's 40 feet long, we can't use it. It's too big. It doesn't fit in my cube. So he took the slide rule and took the C scale and divided it up into 18-inch segments. And these are little triangular pieces. There's one side on each. And then the D scale is on a very long spiral. So this is effectively the same thing as a linear slide rule. But with a Thacker, we can get 5 to 6 digits of precision rather than the 2 to 3 that we got on the standard slide rules. So slide rules give us an approximation. Mechanical calculators begin to enter the scene in the 1600s. Chicard, others. We don't have any here. They're incredibly rare. But by the late 1800s, we start to get the Industrial Revolution, and you begin with the mass production of mechanical calculators. The 900-pound gorilla here in 1887 would be Dorr Felt and Mr. Robert Torrent, who started the comptometer company, and they mass-produced comptometers like this. Fairly simple machine for adding. These are the ones, tens, hundreds, so it's color-coded. So that would be $123.45. 1, 2, 3, 4, 5, and you can set a decimal point right here. So to add, I can hit 5 plus 7 is 12, plus 48 is 60, plus 275 is 335, and then of course I can clear it. So that's addition. Subtraction is done by tens complement arithmetic. So if you notice, each of these keys has a big number that's used for adding and a small number that's used for subtraction. This is very much the way modern computers do it. The only difference is we use two's complement to do subtraction. The problem here does get harder and harder. Here's a manual from a comptometer. Addition is easy. Multiplication is not so bad. Long division is sort of a pain. Here we're on page 15 of the manual. These are the easy instructions. We're going to divide 63,542 by 77. We're using these little placeholders. We're using our fingers. The directions start here on page 15, go through page 16, go through page 17, and we get our answer. And then here on page 18, we get a review that takes 2 pages for the review. I'm sorry, it takes 3 pages for the review. You would have seen offices filled with men and women. They were the computers. They are going to use the calculators. And this was a fairly skilled job. So I was giving a tour here about a year and a half ago when Mr. Hollifield came in. This is a photocopy of his mother's certificate that she earned in December of 1938, having graduated from comptometer school. So that's comptometer land. If you're doing complex arithmetic, there are many, many, many steps. Accuracy is always a problem. So when you took your math from grade school or high school, you probably heard the phrase, check your work. And when I do an operation using a comptometer, it's very hard for me to check my work because I don't know whether I pressed the 5 in this column or that column or this column, or I pressed the big 5 or the little 5. All kinds of mistakes can creep in. And there's no way to audit other than do it again. And if I do it again, I'm likely to make the same mistake twice. So we don't like that. So Mr. William Seward Burroughs comes along. And I'm going to grab a new sheet of paper here. And he marries a calculator with another existing technology, a typewriter. So we're going to insert a piece of paper in here. All zeros, similar adding, 654 plus 55, 88 is 6242. Give me a subtotal, add my tax, add my freight. I now am at 6341, and give me a grand total. So very much like we had before. The big difference now, of course, is that I have a full audit trail. So it's very easy for me to go back and proofread and see everything that I've done. As a museum person, one of my favorite things about this Burroughs is that we have a invoice for a service contract on it. This service contract, as you can see, was valid from May 11th of 1925, and it was good through 11/11 of 25. So somebody paid $4.70 minus a 24-cent discount to have this under service contract. The bad news is the service contract expired 95 years ago. The good news is they probably didn't need it because except for changing the ribbon, this machine still works, as you can see. So fun calculator. When you look at the 1880s calculator, when you look at the Burroughs, early 1900s, when you even look at the Monroe in the 1930s, you'll see that they don't look much like modern calculators. They have many, many keys, rows of ones, tens, hundreds, and so forth. In 1917, Dalton invents the 10-key calculator. And I love the ad here. In very small print there, it says, an inexperienced girl and a Dalton will replace two men who figure with a pencil. Love the political incorrectness of that ad. Anyway, the Dalton hits the market, and 10-key machines were not very popular for many years. And once I show you why, it will become incredibly obvious, and we will wonder why our modern calculators don't look much like the older calculators. So I'm going to jump over here to my grandfather's Monroe. He purchased this in the 1930s. Obviously, it was after 1917, so he could have had a 10-key calculator. But like most people, my grandfather had 10 fingers. So if he wanted to enter a number like 123, he would do it in parallel. He could, just like a piano player, hit lots of keys at once. So today, even though I can talk to my phone and ask Siri or Alexa to do the arithmetic for me, I don't have the ability to enter an entire number at once. So data entry is in parallel on this style machine, whereas today it's in series because we only have one of each digit. So here's our Monroe. It does plug in, weighs about 35 pounds. Everything's zeroed out, so I'm going to hit 25, plus 987 is 1,012, and we added 2 items. We'll clear it. We'll do a multiplication problem. So the repeat key is down, so 25 times 1 is 25, times 2, 3, 4, 5 is 125. Move the decimal over 1 spot. 25 times 25 is 625. I have more fun with the Monroe than any of my other calculators when it does long division. So to do long division, I'm going to start at the other side. I'm going to type in a nice odd number. There's 137. And I'm going to divide it by 37. So the algorithm here is to repeatedly subtract 37 from 137. It does it once. Remainder is 100. It does it again. The remainder is 63. It does it again. The fourth time it subtracts 37 from 137, it gets a negative number. Oops, that's wrong. Add 37 back in. First digit will be 3. It's then going to move the decimal over 1 spot. So now effectively we're subtracting 3.7 from the remainder. It's going to do that 7 times successfully, move the decimal over again, and continue. So 137, you can try and beat me to it, divided by 37 is 3.7. 027, and now we've run out of decimal places, but the answer is right here. So it takes a while to get this done. Monroe was the IBM of the period, but they, of course, had many competitors, lots of defections, lots of corporate history as people went back and forth between Monroe, Marchand. So lots of history going on here. The Monroe was really cool, but it has a problem. When I'm done with my calculator now, I put it back in my pocket. This weighs about 35 pounds and requires a plug. So not real great for field use. So that led Mr. Kurt Hertzark to develop the Curta machines. Hertzark was working on the Curta in Austria before World War II. He was put in the concentration camps, forced to manufacture these for the Third Reich. He lived, was sent to a camp after the war, and then eventually settled in Liechtenstein and began production of the Curta calculators. These were made from 1947. The Model 1 was made starting in 1947. The Model 2 came out in 1954, and these were sold until 1972. So we're going to set our 25 again. 25 times 1 is 25, 2, 3, 4, 5 times 25 is 125. Move the decimal over 1 spot. 25 squared is 625. When I lift this up, it does division. So I just subtracted 10 times 25 and got the answer, which was 375 up here. Brilliant machine. I have a bad habit of taking things apart to understand how they work. This would be a counterexample because the Model 2 here has only 719 parts and 139 of them are different. This is the Model 1, which is the same thing, but fewer digits and a little bit smaller. From here, I'd like to actually move back in time a little bit to 1919. And here you're looking at perhaps the most famous calculator in America. Doesn't have much competition. The reason this is the most famous calculator in America is this very machine with the serial number did appear on Pawn Stars. So the prior owner took it to the guys at Pawn Stars. And they filmed a segment on it. And you can look it up on our website or find it in the Pawn Star archives. So the Millionaire is a really interesting machine because you may have noticed when I was using the Monroe or the Curta, if I wanted to multiply something by 5, it was 5 cranks. If I needed to multiply 25 by 25, it was 7 cranks. 5 cranks in the 1 position for the 5, and 2 cranks in the 10s position. On this unit, each decimal, each place only needs 1 crank. So we're going to set this. This is addition, multiplication, division, subtraction. I have it set for multiply, making sure everything is zeroed out here, which it's not. 25. 25 times 5 is 125, only 1 crank. 25 times 2 is 50. 25, and the answer here is 625. So it's only 1 crank, two cranks, because it's a 2-digit number times a 2-digit number. So this is pretty cool. This is invoiced here in August 11th of 1909 for a millionaire calculator. The Mossbacher was the sole agent. These were made in Switzerland. And the last calculator that I would like to demonstrate today is my favorite. It's also the simplest. It's called Console the Educated Monkey. So here we have a photograph from 1909 of a chimpanzee. His name was Console Peter, and he was trained by his trainer. And the story is that his trainer could point to 2 different numbers, let's say 5 and 7, and the chimp would scamper over and point to the answer, which would be 35. There was a movie made of this, but no one can seem to find a copy of it. Anyway, Console Peter was brought to the headquarters of the National Cash Register Company, and an engineer built the educated monkey calculator. So we're going to look at his feet. There's 4 times 7 is 28. 4 times 8 is 32. 4 times 11 is 44. 6 times 11 is 66, and so on. I can't physically put 2 feet together. So if I want 5 squared, I take it over here to the square icon, and 5 squared is 25. Here at System Source, we have several hundred different types of calculators on display, many different ways of getting to the same place. So we have AMCOs and summits and addiators and facets and even variations here. So here's an original monkey calculator that we just saw. The monkey calculator had different inserts. So here we're doing addition. If we put this insert behind it, it does addition. And of course, it was cloned. So here's the queen, and we're looking at the queen. 5 times 7 is 35. It's just another variation, but this particular one's made out of cardboard. So thanks for paying attention today. We also, of course, have lots of computers here, and come and visit us when you have a chance.
All right, welcome back, everyone. This is Jeffrey Brace at the Vintage Computer Festival East 2020, our virtual show. That was Bob Roswell and his early computing devices. So Bob is here with us. He's going to answer some questions. So first of all, Bob, that seems to be like a really extensive collection. And how did you get interested in collecting all these different items? I mean, how did that start? I mean, in general, and then specifically what we saw.
The first thing is I was a little boy. My grandfather died in 1965. I was born in 57, so I was 7 or 8. And I love that Monroe that I demonstrated a couple minutes ago on the video. So I asked my dad to save it. And that's really the first item in the museum was that Monroe, long before I had any clue what a computer was in that time. For myself, probably 2 years later, I received as a birthday present the plastic Digicom computers. I know they've been featured at prior VCFs. Then we opened up a computer store And almost overnight, all of the inventory that I had ordered became museum items. So what happened is we had some S100 Krememco systems. The IBM PC came out, and the Xerox 820, their oh gosh, a big black box, Dynabyte, became useless. So I put them away. And then we had a retail Computerland store that was in an old bank building, and we had a gorgeous space, and we put some old computers there, and it's just grown every year since then.
That's great.
The goal is to do a East Coast version of the hopefully will rise again living computer museum. So it's to have a really good collection and to have workshops and have things that actually work and keep them running. It's a big job, and I have a budget, but we don't have as big a budget as Mr. Allen had.
Oh yeah. Paul Allen had a great deal of money. I do hope that the Living Computer Museum, that something good comes from that. Right now, it's in an uncertain situation, so we're looking to see what happens, to see however we can help. And I know the Computer History Museum is still closed with the pandemic going on and the fires, so we try to support museums as much as we can. I know there's a museum in the Netherlands that we're trying to support. They have some common computers that are common there, but are not common here, and the vice versa. So we're doing some sort of vintage computer trade between that museum. I don't remember the name of it exactly, but we like to help out other museums, is my point. All right, so I think Chris has some questions.
Yeah, somebody in the chat asked, do you run any mini computers?
We're turning on a lot more mini computers now. So we've been working. We have some IBM 32, 34, 36s that are operational or partially operational. We have PDP-11 that's PDP-1144 that's certainly bootable, and would love to have any volunteers or, if necessary, paid employees to work to get more of them restored. So that is definitely the goal. As you can see just from walking around, there's a lot of computers out on display and a lot more in storage. So it's a big job, and people are working on all of them. Also, Jeff, do you want to talk that we will have a workshop coming up in a couple weeks?
Yes, we have a workshop scheduled for November 14th and 15th at System Source. It's a repair workshop. So basically you bring your computer. We have on our website, we should have the information. If not, it'll be up there soon. To sign up for that workshop, you bring your computer, you go, you meet other people that can help you repair them, and you all work together to repair them. It's a great place to do that. We do a lot here at the InfoH campus, but we like to do one or two in other places. So System Source is a great place to do, especially for those that are further south, and it's a long travel to where we are. It's a little closer there, Maryland and Virginia. A lot of people will come to that one. It's really a great time. You learn a lot, and it's we thank Bob for providing that space for us to work on that. Bob,
I have a question, and people can contact me offline. I have a computing device that I have half learned how it works. I'm trying to learn the rest of it. It's called a sector. They were originally made out of ivory. Some of them are made out of brass. It's a little hinged slide rule that you then use calipers. And I know how to do some very basics with it. But if anybody has any expertise about that, I would love to learn.
Yeah, maybe somebody in the Discord channel can chime in either now or later on after I watch the videos. There's a lot of people watching it online live, but even afterwards. And then all these pre-recorded videos will go live on Monday through YouTube, and then people could put comments in there. Yeah, I'm sure. I mean, this is a great way to spread the word about if there's something that you're looking for, if you need information about that you can't find very easily. Maybe somebody knows somebody who knows somebody, and you can find out a little bit more about that. Looks like we're having another question come in, right?
Yeah, we got
Chris?
one more came in. Which early calculator has the most advanced function calculation ability? Any one in particular that was ahead of its time?
So one that I did not show that I think was probably way ahead of its time was the Olivetti Programma 101. So that was a very early programmable computer from the mid 1960s. It's heavy, it's large, but probably the most advanced, standing out from the rest of its era.
Yeah, I think they did the Olivetti. There was like, who's the inventor? Do you remember? You often the inventor, the Olivetti. There was at VCF Italia. I think they had either they had an Olivetti or they had the inventor of the Olivetti at the VCF Italia.
Yeah, I want to say his last name begins with a B, but my retrieval without Googling it is not.
Bob, what was the model of Olivetti you mentioned?
I believe it's called a Programma 101, if you want to Google it. You could probably share a screen and show it.
Let's see what I can find here. Let's see.
So do you have so those are the devices that you have? What's sort of the time period range that the ones that we saw in the video, like 18 to when?
So mechanical calculators, as I said in the video, really come in with the Industrial Revolution. Handfuls of them were made in the 17th century, even in the 16th century, Jacquard, Lazy, Pascal. But the difficulty of manufacturing them kept them from, they were oddities, they were rarities. But in the 1880s, we started to get very large numbers of mechanical calculators because the capital cost became better than sitting there and figuring with a pencil. There's a nice picture online of the Olivetti 101.
It's interesting.
That's not ours.
Really advanced.
I have
No.
one.
It's very interesting. It has. You always look at the design, and like it's mostly white, and then has like the red and the blue. Where's the red and the blue part? Do you know the different functions of this device? Just by
I read about it, but it is out of short-term memory. I'm not
okay. No, not to worry.
So,
Not to worry.
You're on Wikipedia there. Wikipedia has quite a bit of information on it.
So, all right. So, do you have further calculating devices? Like a lot of people are getting into a whole niche subgenre of like calculators, for instance. Like,
Yes, I have probably 600, 800 calculators. Most of them, unfortunately, are in storage, but there were just huge calculator wars, both in the mechanical era, companies suing one another as employees would steal intellectual property and move from Marchand to Friedan to Monroe and around the corner. All different manner of ways of dealing with carry bits, making it lighter, making it faster. So there were astonishingly large number of ways of adding several numbers together. And I have samples of each out on display, but there's not enough room in 8,000 square feet display space to have all the calculators and the mini computers and the micros and all the other fun things.
Yeah, you don't have. I mean, it's a workspace plus a museum, so you can't just like sacrifice workspace for museum.
We've already done that. My employees live in fear of me taking over another cube, taking them to a less desirable part of the building.
Just backing up to the Olivetti, somebody in the chat says that they kind of used the Programmer 101 in junior high, and that it was surprisingly mechanical. Each key went clunk. So I could just imagine that experience. You're not touch typing, you're like pounding on the keys, I'm imagining.
Yep. And I'm wrong. I mean, here I've got the Wikipedia off as well. So it was launched at the 1964 New York World's Fair, and the designer was a guy named, Perotina. I'm saying it properly.
So you seem to be very knowledgeable about the early computing devices that you showed today. Are you equally as knowledgeable about, like what I just mentioned, the further calculators? I mean, you said you have them physically. Are you also knowledgeable about the history and evolution of those?
I mean, obviously, I was very excited when the fellow who lived across the street from me's dad bought an HP 35, and we learned to program that when it first came out. My recollection is that would have been about 1971, 72. I didn't have the budget for that, so I bought the TI programmable one that served me in high school and college. I became a computer science major, so I didn't have as much of a need for the calculator because we spent too much time in the computer lab. But I didn't spend a long time with the electronic calculators.
So another thing came to mind was, what is that device that you found that was found in Greece? That was an ancient
Right.
device.
That's the Antikythera mechanism. So that is a really, really interesting device, probably made on the island of Rhodes around 200 BC. The best thinking right now is it was a student of Aristotle's. So people went and they plotted where the position of the sun, the moon, the visible planets. And then if you plot that, you're going to come up with an epicycle graph. And then you can instantiate that, or they instantiated that in gears. The device probably made its way to a museum in Athens before the year 80 BC. Around 80, the Romans are going up, the Greece culture is going down. The Romans said, this stuff in the museum is really cool. It's really inconvenient to have it in Athens since we're Romans. Let's take it on a ship and take it to Rome. So they loaded artifacts from the ancient museum, bound for Rome. Ship ran into a storm and sank off of the island of Antikythera. In 1900, sponge divers, Greek sponge divers, are going deeper than they've ever gone before. They had just come out or just made their way to the Greek islands, the diving helmets. So a sponge fisherman went down to 145 feet, which those of us who are divers, that's deep, particularly without advanced gases and stuff like that. And when he came back up, he said there were these dead people looking at him. His crewmate said, you have too much nitrogen narcosis. But he convinced people to go down with him. And in fact, what he found were these ancient Greek sculptures. So the next year, 1901, the Greek government paid for the first real scientific underwater archaeological excavation to bring up these Greek sculptures. And you can go online and see the pictures of them now. They're back in the museum in Greece. And along the way, they found this bronze object. I don't know if you can see my hands here, but 14 inches or so across, obviously terribly corroded. It wasn't beautiful like the sculptures are. They also found plenty of fragments of writing that pointed to astronomical phenomenon. The object was kind of put away, not well preserved, pieces cracked off. They were able to see gears, and people speculated on how it worked really until the 1970s. In the mid-1970s, a guy at Yale named Price was able to get the object, and there was a new form of X-rays called X-ray tomography that was able to see inside the inside the bronze, and he was able to get enough measurements of enough gears to model this and show that in fact it is an orrery. It predicts the motion of the planets, and he made a model of it, and people have been making models of it ever since because it's sort of the ultimate unobtainable artifact, given that they couldn't find an airliner that, a couple of years ago that disappeared in the middle of the ocean trying to find something that's this big.
Yeah.
Which may or may
Back, I came across a YouTube channel. It's called Click Spring. It's a guy who does amazing handwork with machining metal, and his first series was a beautiful pendulum clock that it's just intricate. All the handwork this guy did on making these gears and things. And his current project, and I think it's current because I didn't finish watching the whole series, was on the Antikythera, and I posted a link in the chat on Discord with one of the videos of his YouTube series. So it may be an interesting thing if people are interested in that device. I know you have a wooden model, correct?
That's correct.
Yeah, this one's made out of brass and other metals. And just watching this guy machine metal, I mean, I could just I could never do what he's doing, but it's just really interesting, and it was a little bit on the topic, so I thought I'd mention it.
The other wild thing is some of us will remember from the 70s, Chariots of the Gods. It was a TV program and a book. The author of that has chapters on different archaeological finds from around the world and claims that they couldn't have been made in the time they were made. So, of course, we were visited by aliens. So what is interesting about this machine is the best minds believe, again, it was made 200 or so BC, and nothing of its mechanical or computational complexity shows up until the 1500s. So it's a 1700-year gap. So it's a really interesting artifact. You're welcome to come and play with it.
So it's that was just a special find because there was no other place other than the bottom of the ocean that these devices were found. Is that correct?
Nothing like it. So there is a reference to something that might be it in one of the Greek writers. I think it was Plutarch who mentions a device. And other than that, this thing was lost in the year 80 BC.
So is there any idea about what, obviously that couldn't be the only device in that time period. Is there any idea about what happened to the other devices throughout that area? Is it just simply people took it and then lost it or didn't know what it was?
There were many dark ages.
Yeah, I guess so. I guess it was like at some point it's discarded. I don't know what this is. I'm going to use it for some other purpose.
Yeah, I mean, who knows? There may have been things about it in the library in ancient Alexandria. I mean, no one really knows.
Someone in the chat mentioned there was a Nova episode, and they give the episode number 4007 from 2016 about the Antikythera. So I didn't know about that either. I'm gonna look that one up.
Yep, that one's really good. And I also have a collection there are about 5 or 6 books on it.
All right. Well, that's great, Bob. Do we have any more questions, Chris, or is that it?
No more questions, but I just want to continue on this. Like, since we're talking about this device, it's not a computer as we know it, but is it? I mean, tell us why this kind of fits the genre of the machines we're talking about.
Well, first of all, it is lightly programmable. So the replica that I have, the way the wheels are set, the way the gears are set, will show the position of the planets and when there will be eclipses for 76 years, starting, I believe, in 1976. I would have to take it apart and reprogram it for a different time period. I'm not planning on being alive 76 years from 1976, so it's not going to be my worry to reprogram the model. Secondly, it is a mathematical model that is instantiated, in this case, in years. But that's a lot of what we do with computers today is we have a model. We say, here are the observations, the atmosphere. This is what we think is going to happen with the weather. Obviously, we can go up online right now and look up where the position of the heavenly planets, as well as satellites and everything else, all being done with algorithms that are better based on gravity and knowledge that did not occur until many
Much
centuries
later.
But it is still a mathematical model of a natural phenomenon.
All right, Bob. Sorry to cut you off, but we're out of time. But we
Okay,
really
thanks,
appreciate
Jeff.
it. This was amazing. I loved it. I'm glad I talked about that device. What do you call it again?
Antikythera mechanism.
All right. I was like, why didn't he show this? This is very cool, and I like that. So anyway, how can people get in touch with you afterwards if they have more questions besides the Discord
If they
channel?
look up System Source Computer Museum email, it goes right to my mailbox.
That's it. All right, great, wonderful. Thank you, Bob. I will see you around.
Great. We'll see a lot of you in November.
Yeah, that'll be great. We'll be glad to see you again. All right, that was Bob Roswell, and he had early computing calculating devices. That was great, really great. I like to have that there because this is like the evolution of computers. It started with these early calculating devices and evolved from there, and shows the whole reason why we created computers to make things easier, because the mechanical machines had problems or not fast enough for different reasons. So it's great evolution. Next up, we're going to have Jason Perkins. He's going to be showing off VCF's Xerox Star. We recently restored it, and him along with Ian Primus helped to restore it. And he's going to have that demoed along with a Appalisa. So Andy, are they ready to go over there?
Yep.
All right, we're going to switch over now to Corey Cohen and Jason Perkins.
Hi, I'm Jason Perkins, and today I'm going to be giving a demo of VCF's Xerox 8010 Star. First of all, I wanted to show the actual size of this thing. So this is the main cabinet of the Star 8010 workstation. For reference, this is a 3.5-inch disc. This is an 8-inch disc, and then a regular Sharpie. So it is not a small system. On the front of the machine, there is a maintenance panel with some 7-segment displays that give the current status of the machine, a reset, alternate boot, and your power switch. It has a Shugart 8-inch floppy drive, which holds 600 kilobytes. Going to wheel this back under here so that it's out of the way. All right. The graphical interface that the Star uses is called Viewpoint, and is arguably the first commercial graphical user interface. Certainly there were ones that existed before this. This was really the first one meant for public consumption. It's often been said that Apple copied Xerox and the ideas that the Star had with the Lisa, and certainly a lot of people who worked on the software on this moved to Apple and developed the software for the Lisa. But I don't think that's entirely fair to say, because while certainly there are concepts that were invented on this system that the Lisa implemented, there are enough differences and innovations between these two systems that they each stand on their own. So, first thing I'd like to show you on the Star is on that diskette, I have a document and I want to edit it. So I need to retrieve the file from the disk. Before I go into the graphical user interface, the first thing I need to show you is the keyboard of the Xerox 8010, because it's very integral to how the system works.
So we should mention to everyone, you might see us slowing the video down and speeding up. The Xerox system used a very, very, very strange refresh rate. So we are slowing the video down intentionally as we zoom in, so that you don't have as many artifacts. So it may seem a little weird while you're watching his hands move, but trust me, it makes it a lot easier to see. We'll switch it back when we zoom out.
Yeah, it's a 38.5 hertz interlaced display. With the two phosphors, one of which is long persistence. So in person, the screen does not look this green. It's a paper white screen. So on the keyboard, you see we have the normal typewriter keys, and then off to the side there are these clusters of function keys, and these are critical for the operation of the system. When you're using the computer, you'll select an object, a file, text, and then operate on it with these function keys, which are like delete, copy, move, properties, skip next, font, margin, stop. So the functions to make the computer work are on the keyboard. They're not on the screen. So we need to get our floppy drive. On the Star Viewpoint operating system, all of your software and system utilities live inside the directory. So I'm going to go ahead and open that up and go into the workstation node. Go into my local devices, and then here's my floppy drive. So I'm going to click on that. I'm going to push the copy key on the keyboard, and then this bar at the top of the screen is not a menu bar. It is an information bar and occasionally has error dialogues in it. So if you see, hopefully you can read that, it says, please select a destination. And my mouse cursor is changed to this arrow. So if I move over here and click, I now have a floppy drive icon on my desktop. But I don't want it there, so I want to move it. There is no click and drag. I can't click and drag this. So to move the icon, I have to press on it, push the move key on the keyboard, which is here on the side, and then again my cursor changes, please select a destination, and then I can move the floppy disk icon where I want it. So I'm going to close this window out, open my floppy drive, and here is the list of files that are on that disk. Someone will probably tell me that I'm doing this wrong, but as far as I can tell, you can't edit documents that are on a floppy disk. You have to copy them off to the desktop first. So I'll do the same thing again. Click on the file, copy, select destination, point. The system is now copying the file off of the diskette, and there it is. So I will close my floppy. The Show Properties key on the keyboard is one that you'll use a lot. So I'm going to push that, and that will bring up a Properties window. And in this case, this is how we would rename this document. If I wanted to call it demo document live, I could do so. And then hit apply, and you'll see the name change. Well, no, it didn't because it cut off, it's too long. But anyway, let's open this up. You can have overlapping windows in viewpoint, and you can drag them around. So I'm going to drag this just up here to the corner. Notice in the information bar I've got the helpful button up on destination. So if I release that, my window will move. If I right click, I can resize the window to make it a different size, and that's all well and good. Inside of this document, this black rectangle is a graphics frame. Graphics have to go in a graphics frame. You can't just put them into a document. And you might say, great, how do I put the graphics frame in the document? It used to be that you could go to the office supply store and they had these like carbon transfer sheets with like shapes and stuff, and you'd rub on it on your paper and it would transfer that onto the other paper. And they use that paradigm on the star, where in this basic transfer sheet I've got all these various shapes. So if I want to add a box into this, I can grab this box shape. I can choose copy on the keyboard. Oops. Oh, I didn't open this document for editing. Let me do that. When you open a document, first of all, it's in read-only mode. So, copy, paste. I don't like where that is, so I'm going to press move. I can move it around. Now I want to resize it. So the function keys that are on the top of the keyboard are also labeled on the screen now as soft keys. So I want to stretch this direction, and then click there, stretch, go down a little bit, move it, okay, good. So there's a little box. If I want to change the line style or the fill, I can do that. Properties key, this property sheet now has things related to that box, so I can do that. Click done. And if I wanted to add some text inside the box, you have to click on the corner of a window to activate it, which is kind of interesting. I can copy this text frame, paste that in. Oops, I'm not typing. Click on this, move, get my destination. There we go. So now we have the fox going over the lazy dog. Let's say I wanted to take this and move it to the bottom of the document. Let's select it, push the move key, and click where I want it. And it actually did it. Sometimes it doesn't actually repaint the screen when you do that, which that took me about an hour and a half to figure out why it wasn't working, because it was working. Yeah, so I moved it, but it doesn't show it. Unfortunately, the system is slow enough, they can't always update in real time. So you have to go to one of these little menus at the top and choose to redisplay. A repaginate, as they call it. If I release that, it will go blank for a moment while it figures out what it wants to do. And we've moved our graphic. So now I'd like to show you a similar operation on the Lisa. We'll wake her up. I've got a document on this disk. If I put it in, the system will automatically mount the disk and resume the document that I had open at the time. I'm not going to worry about that right now, though. I'll just set that aside. So here's another little sample document. So if I want to insert a graphic here, I need to copy paste it in. So I need to create it in the drawing package. In both of these systems, there is no file new. You take a blank, empty document template and make a copy of it. On the Xerox, you have to click on it, use the copy key on the keyboard. On the Lisa, you can click on it and say, tear off stationery, or just double click it.
And we noticed that you're not actually using the keyboard at all on the Lisa.
That's correct.
On the Xerox, you were constantly having to go to the keyboard. I didn't show it on the video because I wanted people to see the screen, but it's really obvious when you see you do it. You're constantly on that keyboard.
It's a very different interaction where on the Xerox it's almost like right hand, left hand. Each one is doing different parts of the operation, and on the Lisa, everything is done simply with the mouse. And the keyboard has no function keys on it. Well, I guess it's got a command key, but there are no predefined function keys on the Lisa keyboard. So we tore off a copy of our Lisa Draw document. I had started to prepare this earlier, and inside of Lisa Draw we get kind of a familiar palette of tools. So we can draw a box, again, not touching the keyboard to move it around. Fill menu, let's make it look like that. And then we can add some text. And move it there. That's good. I can select all. I can group all of these things together as one object. I can take my object, copy it, switch back to the other document I was working on with the desk menu. Edit, paste. And you see that it also redrew the whole document right away. I didn't need to issue any specific command. I've also created a few other little business graphics type things in this with the Lisa software. You can see all these vector-based images will redraw as you scroll. Scrolling complicated pictures is definitely not fast on Lisa, but there's a pie chart generating application which actually, to create that I used the pie chart application and then pasted it into the drawing program to pull this particular wedge out. And then this was done in the spreadsheet, and that was all that was easily copy pasted into a document. So in the lead up to this event, I had a number of people who were new to the Lisa. They'd never used one before, and I asked them to sit down at the machine and create a document with text and an illustration, and gave very little other instruction. And everyone was able to do it, including our roommate, who I think was 6 beers in at the time, and it took him about 10 minutes. So the refinements that Apple did building upon concepts started with the Star really makes this software, I think, a big iteration compared to this earlier system. So let's see, how are we doing on time? We've got 10 minutes left. Do we want to move to Q&A?
Sure, we can.
Yeah, I've got the Discord up here.
Yeah, we got some questions coming in. Oh, cool. So, so first of all, we have a question. What is the resolution of the Xerox? It looks surprisingly high resolution.
The Xerox is it is 1024 by 809, and the screen is set up such that there's the kind of the viewable area of the screen, and then beyond that there is a border texture which can be defined so that the screen is borderless. The whole screen is illuminated, but there's only a center section that is actually able to display data.
Okay, we have another question. What year, again, was the Xerox Star from, and what year was the Lisa from? So how long from that to that?
The Xerox Star is built upon concepts and done by the same team that did the Xerox Alto of 1972. The Star shipped in 1981. I'm sure development started at some point prior to that. I don't know exactly when. Development on the Lisa started in 1979, and it was originally going to be a text-based interface. But when Apple was invited to view the Smalltalk system at Xerox and see the concept of Windows and the mouse pointer, Lisa was changed to a graphical interface, and then actually I think it was like 6 months before the Lisa shipped, the interface, the filer interface was changed to this one that we're now familiar with that is still kind of common today. So.
Okay, there's a question about networking. Basically, I guess the Xerox has Ethernet.
Yes.
What kind of networking was available for the Apple? Did it have, for the Lisa, did it have Ethernet? What did it have? And
so that's actually an important thing. The Star was the first computer to have 10 megabit Ethernet. On the back there's an AUI port, so you can plug this standard transceiver into the back of this system and cable it into a modern twisted pair Ethernet switch. It's called a AUI module, I believe. And there were various types of this depending on the physical cabling that you would use. The Lisa, internally to Apple, had an Ethernet-like network and network cards. That never shipped. I believe they were very close. They had the hardware was done, and they used it internal to Apple and at the factory where they produced the systems. The hardware project was scrapped. The software side of that became AppleTalk, and then was implemented over the serial port of the Lisa and subsequent Macintoshes.
Okay, a second part of that question was, can either of them be used as a file server for other systems?
Yes. So running the Lisa Office system, no. As it shipped, the Lisa is a standalone system. It has a terminal application. You can do text, copy-paste text and whatnot. But there is no file server or networking. That was planned but never actually released. I don't believe that in this configuration the Xerox would be a file server. It would be a client. The same hardware running different software connected and maybe connected to additional disks could be used as a file server. But if you're running Viewpoint, I don't believe that this will act as a file server, although someone might correct me. I'm not 100% sure on that.
So someone just had a comment. They said, can't help the feeling if you had an e-paper computer screen, it wouldn't look too dissimilar, about the same speed of other slow updates instead of slow screen refresh.
Yeah, the Lisa is a 5 megahertz 68,000. The Star does not have a microprocessor. Because Xerox was so far ahead of everyone else with what they were trying to do, powerful microprocessors hadn't been invented yet. And so this has 4-bit AMD processors in it, running microcode to stitch them together into a 16-bit processor. And amongst that and all other things, this has about the processing power of a Mac Plus. It's about a Mac Plus, which is more processing power than a Lisa.
Now, how much memory did it have, and how much memory did the Lisa have, and what's the CPU of the Lisa?
So the Star has 768K of RAM. This particular one, I think you could order
1981.
In 1981. I think you could order it with less. This particular one is fully optioned. The Lisa in 1983 with the 5 megahertz 68,000 shipped with 1 megabyte of RAM, which again, think some of the other presentations we had people showing Commodore 64s from this time period, which had 64 kilobytes of RAM. Both of these systems were hugely expensive, and the RAM was a significant portion of that. In 1983, the RAM alone in a Lisa cost Apple about $5,000, just the parts.
So another question is more, I guess, personal to you. How long did it take for you to get proficiency in using the GUI on each of them?
So the Lisa, I'll quote the comment of my husband, if you've used a classic Mac OS, System 7, 8, 9, the Lisa is very familiar. Really the only difference is that it's document-centric, so you're tearing off copies of stationery instead of opening an application and choosing file menu. The Star took me a little while. Fortunately, our friends at the Living Computer Museum developed an excellent Star emulator, and I was able to spend a fair bit of time with that using the interface and also watching some of the demos that the Star team has given that are available on YouTube. So I'm by no means an expert on the Star interface today. I know enough to work my way around. It's been quite a few hours to get to this point. It took me about an hour and a half to figure out how to move the text or the graphics frame from here to here.
Okay, wow, we have a bunch of questions coming in. First question is, did the Star have peer-to-peer networking?
I honestly can't answer that. I think I might have to backtrack what I said earlier. I'm thinking back to the demo that Xerox gave at the Computer Human Interface Conference in 1998. I don't know. I know that they had, Xerox had extensive networking set up, file servers, print servers. It was very easy to send you could take to print a file on the Xerox. You would take your document, you'd choose copy, and then the destination is you click on the printer icon. Unfortunately, so Xerox likes to carefully control their assets, and hopefully have monthly recurring costs on them. And the Star is no exception. Everything on the Star is licensed with specific license keys, and I don't know if we're missing the software or I haven't been entering the license key properly. So, like if I select this text, so you left click at the beginning of where you want to select, and then right click at the end. I'm going to choose properties, and this is the property sheet for that text. Let's say I wanted to make that text bold, right? That's pretty easy. I would click on bold here, and Corey, if you could pull in on this line here. When I click apply, you'll see what happens. If I click apply, oops, we're not licensed for bold. So there is a lot more functionality in this system that this particular instance doesn't have right now.
Okay, well, we've got a few more questions. Let me just pull out here.
Sure.
So let me read these off. So we've got what kind of hard drive is in the Xerox? Capacity? Is the whole OS on a disk, or where's the OS stored? And I guess one more question to that. I guess I'm going to combine two questions. Are we running a flash drive or a real hard drive? And you know, who supplied it?
Yep. So yeah, those are very related questions. The system had an SA1000 interface 8-inch hard drive in it. I believe you could order a 10 meg, a 60 meg, or an 83 megabyte drive. This system had, I want to say it was a 63 meg drive in it when we got it. It might have been the 83. It does not have that currently. We are using one of David Gesswine's MFM emulator boards, which is based on the BeagleBone computer, which has solid state storage on it. So we are using an emulated hard disk on this system. And I also need to mention that David has been extremely important in getting this system going. I would not be able to get this demo without the work that he did. So, and I guess for clarity's sake, this Lisa is also running a more modern hard disk. It's not solid state, but it is noticeably faster than the Apple 10 megabyte.
And quieter.
And quite a bit quieter. Yes, you can hear me clearly.
If we actually had the Lisa with the original drive, the noise that would be created by that drive, you probably wouldn't hear anything in the room. It's rather loud. And it's interesting that was intended for an office environment.
Yeah.
Someone did have a question about the hardware on the Star. Did it have blitter circuitry, do you know? Or did it not do that in hardware? It did it in software?
Blitter circuitry. I am not familiar with what that is. I do. So does does there have blitter circuitry? The loadable. Yeah, it's everything on the Star is in microcode. So one of the first things, there's a minimal boot ROM, and then the actual. I don't know exactly where the delineation is, and I don't want to misspeak, but all of the code all the things that make this work are microcode. It's not so much hardware and TTL logic like the Lisa. I don't know if that code comes from disk or from ROM more on the Star 8010.
On the Lisa, it would have been in ROM because they had a toolbox.
Yes. Yeah. Well, some of it's in ROM. Some of it is also loaded for disk. Like if you boot a Lisa into MathWorks, it loads the Macintosh ROMs into RAM memory and then executes them. So, essentially.
So I have a couple of questions that have came in. Number one, do we have any hardware upgrade plans for the system? Someone said his system, but this system actually is the system from the VCF Museum.
Yes.
So you can come in, and obviously
More normal
with
times.
with the COVID restrictions of how many people can be in the museum, and come in and actually work on this system if we wanted to. So we do have,
I believe, and correct me if I'm wrong, we have the only one of these that is currently on public display that works.
I believe that is correct, and that the public can touch. Obviously, we'll give you some assistance. We'll turn it on and everything.
Yes.
So I can tell you, I don't think we have any upgrade plans, as from what I understand.
I mean, I don't really think
Other than a mouse pad.
Yeah. Yeah. That's actually another important distinction. I'm glad you brought that up. So, I wish I could insert some pictures I took of this. I'll pop them in the Discord. The Xerox mouse, this particular one was made by Alps Electric, and it is a beautiful piece of mechanical engineering inside. It's machined aluminum. It has a steel ball bearing, and it's all machined aluminum, clamped together, steel rollers supported on steel caged ball bearings. It has these encoder drums with the finest little wires that touch the drum to sense as it rotates, and it looks like it might have been hand soldered. An amazing bit of craftsmanship in this mouse. You'll also notice you can't, to take this apart to clean it, you have to completely disassemble it. And I would do that, but it is very fragile, and I don't want to risk damaging it. VCF was, when we got this system, we didn't have a mouse, and we were fortunate that someone donated one to us, and we greatly appreciate that. These were quite expensive to make. The Apple mouse is made out of injection molded plastic, has the ring that you can rotate to dump the ball out, has rollers that are plastic on metal shafts with no bearing that go into an injection molded plastic frame and have LED opto interrupters, the interrupter wheels. This cost Apple, I think, about $40 to make. I could be misremembering, but this was something that was cheap enough to put on everyone's desk. This is an amazing bit of machining and craftsmanship that is very delicate, sensitive to dirt, and difficult to clean. So, I forget exactly how I got on that tangent, but hardware upgrades. I don't think there really are any hardware upgrades to do to this system. I think it's about at its maximum configuration now. There was a later version of this system called the Daybreak, which was it's essentially the same computer shrunken down into fewer chips in a smaller cabinet, but with some other various peripheral upgrades. It's got some additional processing for peripherals, but at its core, it's still the same micro-coded CPU interpreting the Mesa object-oriented programming language, which is what this is written in. That's a language that Xerox developed. The Lisa software is, I think, a mix of Pascal and 68,000 assembly.
Mostly Pascal. That was a big change, I think,
with the Mac.
Macintosh.
That's how it was faster.
Right. Was because the Macintosh was RAM restricted. The Macintosh, they wrote everything in machine code as best as they could.
Yeah.
To be a lot smaller.
The
higher level language and the amount of RAM, they could do a lot of work in Pascal, which wasn't as efficient from a code perspective, but it was way more efficient for the developers themselves.
Very flexible.
Okay, so we have a question about, I guess this is more, someone was wondering, in 2020 Science Advance is optimizing compilers. If it would be possible to do the same thing as it does right now, but with faster redraws and operations in general. I would say the emulator, right?
Yes. The issue is that with both of these systems, that the the software is still pretty close to the metal, right? And for example, this machine, the Lisa, has an 8 megahertz rated chip in it. The 68000 is rated 8 megahertz, but it only runs at 5 for various reasons during development. But you can't easily speed that up in the Lisa office system because that 5 megahertz clock is also what drives the video and the floppy access. So all these things are interrelated. So you can't speed up one part of it and not have it have issues. The same way on the Xerox, the graphics on this is bit banged out by the processor, and so the microcoded processor has like a list of. Hopefully, you have watched the Apollo guidance computer videos from Curious Mark on YouTube and seen how the Apollo guidance computer had a number of tasks that it would run and spend so much time on each task. The Xerox does that too, and one of those tasks is draw a scan line on the CRT. So you can't speed up the processor without it throwing everything else off. And in fact, the Dark Star emulator has an option where if you have a very fast computer, a limit clock speed option, because if it runs too fast, the system will crash.
Wonderful. So I guess you've tried that.
I have not, but that's what the very helpful help file said that.
So I guess one final question we have, this will be our last question, is someone really wants to know, because Xerox was kind of a big company.
Yes.
What division or what part of Xerox, because there's software and hardware and there's the interface, what division actually produced this and sold it, and who is the real intended audience or the real intended purchaser of the product?
So the Xerox, all of the, as far as I know, and I am, as Corey will tell you, I'm more of an expert on the Lisa system, and I know some things about the Xerox. So as I recall, all of this was done at the Palo Alto Research Center by I think the team had a name. It might have been Advanced Products Team. I could be misremembering that. The intended audience for this, actually the intended audience for both of these systems is the same. It was the knowledge worker, the person who is not a typist, who is not clerical, but is someone who is dealing with ideas and preparing presentations and charts and solving business process issues. So both of these systems were targeted at that knowledge worker segment. And Xerox actually, if you search on YouTube, has a really excellent presentation about the star and how they target it at knowledge workers.
Well, thank you. This has been really, really great and very informative. And then we're getting things from people like, this is the first time they've actually ever seen one of these working. So I think that it's amazing that, you're able to share it and really just show the difference. Because I'm with you. Mm-hmm. People ask me all the time, did Apple steal from Xerox?
Yeah.
And
and everyone says, oh yeah, Apple stole from Xerox, blah blah blah. I mean, and it's in movies and whatnot. And yes, there are elements and paradigms that are implemented in the Lisa that are present on the Xerox. But I did a demo earlier for my YouTube channel, and Andy then asked me, hey, can you do this? Where I compared the Lisa Office system to DRI's GEM. And in that instance, DRI GEM kind of copied some of the look and feel of the Apple system, but without the depth of functionality that was behind that look and feel. In this case, we have some similar paradigms, some similar graphics stuff, but the depth of functionality behind it is different on the two systems. So I guess that's my point, is that inspired by, yes, copied exactly. This is not a Xerox of this.
Thank you very much. It's not a Xerox of that.
Yep.
So thank you. And we're going to move on to our next, which is really something I always love watching. Ian Primus repairing CRTs, so he's going to talk CRT repair. So thank you very much, and we're done.
Thanks, everyone.
Hello and welcome to Basic CRT Repair. I am Ian Primus. I have done this talk a couple of times at VCF East over the years. It's usually an hour long, and I also usually have an audience to interact with while I'm doing it. So this is going to be a little bit new for me. Shooting and editing and producing video is not really my forte, so forgive this if this comes out kind of messy. But I'm going to do the best I can to cover the information I like to usually cover in these talks, get it down to an hour, to half an hour long, and be able to show things clearly on camera. Of course, the one thing that comes up the most when talking about CRTs is safety. The number one question I always get, or number one concern from anybody that's never worked on one, is how to discharge the CRT, how to work on one safely. There's a lot of myths, there's a lot of misconceptions, there's a lot of scary things out there talking about how, CRTs store a charge after they're unplugged, that the high voltage can kill you, that you should never work on one alone, you got to keep one hand in your pocket. A lot of that's pretty excessive. While it's true that they do contain high voltage, I mean, this is a set I'm going to be using for several demos. This is a boring, ordinary 13-inch color TV. I'm using a TV set because the casing design makes it really easy to show inside clearly what's happening. It's also very simple. This is a cheap TV, so it's cost reduced to within an inch of its life. It uses as few components as necessary, so it makes it pretty easy to see what's happening. Computer monitors, the monitors in terminals, all those things operate on exactly the same principles. But the first thing I want to cover is safety, how to discharge a CRT so you can disconnect the anode and work on it, because I'm sure this is the one thing that everybody wants to see the most. The component that stores the high voltage is the CRT itself. It actually works as a capacitor in the high voltage circuit. It is coated on the inside and the outside with conductive paint. The flyback transformer generates the high voltage, but it's a high frequency AC. There's a diode built into the flyback transformer's casing that turns it into DC, and then it is filtered by the fact that the CRT functions as a capacitor. One plate is on the inner coating inside the glass that this anode connects to. The other plate is this outer gray painted-on coating called the aquadag, and then the glass of the tube works as the insulator, and that forms a capacitor. The problem is that whenever you unplug it, turn it off, that capacitor stores a charge. Some sets bleed it off, most sets don't. And even if the set does bleed it off and you know this, I wouldn't trust it. Always discharge it before you disconnect it. Discharging is something that scares a lot of people, but it doesn't require any special tools and it's completely safe. All you need is a flathead screwdriver. This is just an ordinary plastic handle flathead screwdriver, and a clip lead. This is just a cheap, probably Harbor Freight clip lead. It's nothing special. So what you're doing, though, is you're not grounding it. You're not doing anything weird. All you're doing is you're shorting out the capacitor formed by the picture tube. What you want to do is you're connecting the internal plate to the external plate, shorting out the capacitor and discharging it. So what you do is first you have to make sure it's unplugged. Don't try to discharge a CRT that's still on. And you can see that you can see this inner coating here, kind of through the glass. You can see the gray outer coating. You see this strap. This is the DAG ground strap, and this connects along the back of the tube, pressing against that gray coating, and it goes to one of the metal mounting ears here. And these ears are all connected to each other by way of the implosion band that goes around the front of the tube. So all you have to do is connect one end of the clip lead to the shaft of the screwdriver, connect the other end of the clip lead to this metal, that DAG ground strap, or to one of the metal mounting ears of the tube, and then slide the blade of the screwdriver under the suction cup until you touch the contact inside. Hopefully the camera picked up that snap noise. That was it discharging. Now there's no voltage here. Now I can take this apart safely without hurting myself. The contact here looks about like the top of a Christmas ornament, where it's got two little prongs, and that clips into this hole. It's like a metal button with a hole that's recessed into the tube, and this clips into that. I like to use the screwdriver to unhook one side of it and then lever it out. Now that it's discharged, we can work on it safely. One thing to be mindful of is that some larger tubes, like 25-inch, 27-inch, and other big stuff, and even small tubes to some degree, this can sort of start to recharge in the same way that certain large capacitors do. It's not a big deal. It's not going to hurt you. Just be mindful that there might be a charge that comes back to this after it's been sitting unhooked for a while, but it'll be minimal. It'll be like getting zapped by a doorknob or something. Now that that's disconnected, this is safe to work on. Like I said, there's nothing special. You don't need a special high voltage probe. You don't need any kind of special insulated things. I've heard of people wearing rubber gloves and standing on a rubber mat. It's not that big a deal. The high voltage, even if you get zapped by it, it's not going to kill you. You're going to wish you hadn't done that. It'll hurt, but it's still a very low current. It's not enough to injure you. I've done talks like this and demonstrations and shown people how to discharge CRTs for a long time, and I've always told my audience that if you ever manage to kill yourself working on a CRT, send me an email, let me know how you did it. So far, never heard from anybody, so I think everybody's fine. But in all seriousness, no, it's nothing to be afraid of. It's not that big a deal. It just requires a little bit of confidence and understanding what you're doing. You're shorting out the picture tube. You're not grounding anything. You're not, I've heard of some people that try to make a discharge tool by attaching the screwdriver to the ground pin on the AC wall socket. But that doesn't work because that's not a complete circuit. It'd be like trying to discharge a car battery by connecting the 12-volt terminal to the ground. There's no current flow there. But that's really all there is to discharging a CRT. The basic components of a CRT. At the neck of the tube, we have an electron gun that fires the electrons toward the face of the screen. The second anode up here, this high voltage anode, this is responsible for generating the accelerating voltage that pulls the electrons toward the face of the tube. On the inside of the tube, it's painted with phosphors. When these are hit by the electrons, they glow. So you have this beam, it's accelerated, hits the face of the tube. Left to its own devices, it would just create a spot right in the center of the screen, and that's not too useful. So we have this magnetic coils here on the neck of the tube. Electrons are deflected by magnetism, and these coils bend the beam around in order to draw it across the screen, left to right, top to bottom. And in fact, if you've seen the slow-mo guys did a fantastic video on this where they filmed the face of the CRT in slow motion, so you could actually see the beam being drawn across the screen. It's pretty neat. The yoke, here's one off of another TV. You can see these are the horizontal windings are here on the inside, and the vertical windings are here on the outside. The three beams here need to be aligned with each other. That's what these rings do. These contain tiny little magnets that set the convergence and the purity to get the beams aligned with each other and get the beam aligned with the shadow mask in the face of the tube. In a color set, just behind the glass, there is a metal screen, like a metal mesh, kind of like a screen door. Most sets use a piece of metal with a bunch of round holes in it. Sony Trinitrons famously use an aperture grill of wires that looks much more like a screen door. The purpose of this is to prevent the electron beams from striking or bleeding over onto the other colored phosphors. If you've ever had a TV that had like a weird colored splotch or got magnetized, you hear of a TV needing to be degaussed. That's because that shadow mask in the face of the tube got magnetized somehow. The other thing is that the Earth's magnetic field affects the shadow mask, and it affects the electrons. So just simply moving the set around in the Earth's magnetic field will cause the beam to hit the wrong spots. So the tube needs to be degaussed frequently. So this coil wrapped around the outside edge of the tube is the degaussing coil. This fires every time the set is turned on from cold. There's a thermistor in series with it. So as the current flows through it, the thermistor slowly increases in resistance until no current flows through the coil at all. But that creates an AC magnetic field that demagnetizes, degausses the screen at power up. Down here we have the flyback transformer. This is the component that actually creates the high voltage for the second anode. It also creates the focus voltage for the focus anode and the G2 by way of this divider network here on the back. This is a resistor divider network, and there's controls here that lets you adjust the screen and the screen and focus voltages. Pull the chassis out here. I mean, this is just a TV, but it shares a lot of things in common with other monitors. Here's the DAC ground wire. This connects the outer coating of the picture tube back here to the neck board, which in turn is connected back to the main chassis. I already discharged this a minute ago, so I'm safe there. Speaker. This is a very cheap TV. This is kind of an interesting example of cost reduction. You see there's this hole in the chassis? Well, if the neck board fits right in there because they manufactured this as one plate, one panel, and then broke it apart later. Much cheaper that way. There's the yoke connector. If you've ever had a problem with a TV or monitor where the picture collapses into a horizontal line and then you hit it and it pops back, chances are it's a bad solder joint on the back of that yoke connector here. Bad solder joints are a very common problem with monitors in general. If you've ever had a monitor, TV, whatever, that you can hit and make it do something weird, or it fails and you can hit it and it works again, there's a bad solder joint somewhere. Key components of a TV like this transistor here is the horizontal output transistor. This drives the flyback primary. So the horizontal frequency of a monitor is key to creating the high voltage. It works very similar to the way a switching power supply works. You have the horizontal frequency, which in this case, being a TV, is 15.75 kilohertz. That horizontal signal drives this horizontal transistor, and this drives the flyback primary and the horizontal yoke coil to scan the beam horizontally across the tube. Being a TV, this also has its own local horizontal oscillator. Many monitors do, especially if they take composite video. Some monitors don't have a horizontal oscillator at all. An example of this would be the IBM 5151 display, the monochrome one. That relies on the horizontal sync signal from the computer to then go through a buffer transistor and then drive the horizontal output transistor. So if it's not connected to the computer, it produces no high voltage. The high voltage is derived from the horizontal, so any failure in the horizontal circuit will cause lack of high voltage, lack of picture entirely. The filament in the picture tube in most sets is derived from a winding on the flyback. There'll be a separate winding just for the filament, because the filament usually is 6.3 volts. Other parts of note, this component down here is the vertical output chip. Kind of hard to see. See if I can get a better picture of one later. But this is responsible for the vertical circuit. Again, you get the vertical sync. Gets sent to this, and this handles the it's like an amplifier, specialized amplifier for driving the vertical yoke winding. And if you ever have a TV or monitor that has weird fold over, then you'll have one of the capacitors connected to the pins of the vertical chip will be at fault. So you'll have like a little fold over on the top of the screen. I've got another set. I will probably show you that later. This is the degauss thermistor. It's actually usually a big black block, like a square plastic block in most sets. But again, this is a very cheap small TV. TV circuit boards, monitor circuit boards in general are very simple construction. This is phenolic. This is single-sided. This is made as cheap as possible. The nice part about that is it makes it really easy to solder to. You don't need any special equipment to desolder parts off of a board like this. The holes aren't plated through because there's nothing on the other side. Common failures in monitors in general tend to be electrolytic capacitors, but it's not like the be-all, end-all. You can't just rely on capacitors being the one true failure with everything. This particular TV is hot chassis. You'll hear people talk about a hot chassis set or a cold versus a cold chassis set. This is hot chassis. It derives its B+ from rectifying the AC line and filtering it, and then there's a voltage regulator in there, but there's no galvanic isolation. This is directly connected to one side of the AC line. This is why this set has no inputs. It has an antenna input, but that's coupled to the tuner with a capacitor in here. And it's not actually electrically hard coupled to it. So that means that if you were to try to modify this, like I know hear a lot of people these days RGB modding a TV, don't even attempt to modify a hot chassis TV like this because it's not safe. Because you're at mains potential, the difference between your RGB input and the RGB, the ground of this TV, and the ground of your computer or game console could be 120 volts AC, which will lead to a lot of smoke and burning. But I mean, this is a very simple TV, very simple overview. I'm going to try to get into the more details in other segments. Yeah. Okay, so this is an example of a common sort of a failure that you see on a lot of different kinds of monitors. This is a Panasonic professional monitor. This is a 9-inch. Even conveniently on the side, somebody has written broken. And this has a vertical fault. So if I turn this on, warm up. And turn on my pattern generator here. So it's kind of hard. Hopefully it shows up on camera, but you can see that the top of the picture, like it's squished a little bit, and then the top of the picture is getting like folded over and stretched out. So you see all these extra kind of lines that show up in the picture, how it kind of messed up like that. Let's see if I can. The color bars show it too. You can see these lines. I think it's showing up on the camera, but it is folding over. It's just the folded over section is getting all stretched out. And this is a little bit more obvious. This is a crosshatch pattern. And this line, this flickery line, is supposed to be up here, but like that top, I don't know, quarter inch of the screen is now folded over and stretched across half of it. So I mean, this is broken. This is something wrong with this, and this is a problem with the vertical deflection circuit. This is one or more of the capacitors in that circuit has failed. So I'm going to open this up, and I'm going to try to get some close-ups and explain the problem and how to find it. Okay, so I got the chassis out of that little monitor. And there's a lot more to taking apart a professional monitor than there is a TV set, but that's okay. Just a whole lot more screws to deal with later. So here's the main chassis. Now, again, it looks more complicated than the TV, and it is. There's a lot more going on. But it still works on the same basic principles, and we can look at it and kind of understand how the circuit is put together. I don't have the schematic for this monitor, even though I'm sure I could probably look it up someplace, but I don't think I need it for this. And again, here's the flyback transformer, and you can see the horizontal circuit, horizontal output transistors right here. It's the linearity coil. You know, this is all very common horizontal stuff. We're not having a horizontal problem, we're having a vertical problem. And this chip here, this is the vertical output chip. Remember, this is just like in that TV. It's the single chip with a lot of pins, and this drives the vertical deflection. And there's another. This is the kind of a vertical control, and then there's the actual vertical output chip. And we're having a problem with the vertical deflection circuit. So it's going to be in this circuit somewhere. Now, if we look at the board, we can see that it says that chip is IC402. And then this is IC401. These are the vertical chips. and this being the output. So I know then that at least the way this monitor and the way most monitors are built, you can look at the board and you can see that the other components that begin with 400, all the 4 series, are in the vertical circuit. So like here's the D403, C412, C410. There's all the vertical parts begin with 4. Similarly with horizontal, like here's the horizontal output transistor, and that's Q502. So that means the horizontal parts begin with 5. And then you can kind of find the rest of the horizontal parts. So in our case, this is a problem with the vertical. So, and I know it's going to be a capacitor because that's generally what causes this sort of fold over. So, I mean, I could dig out the schematics and try to really work my way through it or spend a lot of time on it, or I could just replace these couple of capacitors in the vertical circuit, and that should fix it. Obviously, you could simply recap the entire thing, and I know a lot of people are into bulk recapping a board, but in many cases, it's just not that necessary to replace every single electrolytic capacitor, especially in a monitor like this that's not very old. You can also see how the heat from the vertical circuit has kind of browned the board here. Like it's darkened here. The vertical circuit in this monitor seems to run pretty hot, and the heat will also shorten the life of the capacitors. And again, this is fairly common to a lot of sets in vertical circuits where the capacitors that are right next to this heat sink where the vertical is kind of get baked by the heat, and they dry up and they fail more quickly. So I'm just going to replace these couple of electrolytic capacitors, and I'm pretty sure it's going to fix it. Okay, and here we have that little monitor. I replaced 5 capacitors, and I put it back together, and it's working now. No longer, it doesn't have that line at the top of it anymore. You can see the color bars are nice and clear. There's no more flickery line. Got a crosshatch pattern, and there isn't a line repeated down here. So yeah, it was a problem in the vertical circuit, and without the schematics, without really spending a whole lot of time, I was able to just look at the circuit board, look at the vertical circuit, and recognize which components were in the vertical circuit, and then just change the couple of electrolytic caps in that circuit. I mean, yes, with more in-depth troubleshooting, one could figure out exactly which of these 5 caps is actually bad. But considering this represents about $1 worth of parts, it's a quick and easy way to repair a monitor without having to, replace every single capacitor or rebuild the entire thing. One question I get an awful lot is, what special tools do I need to work on CRTs? Although sometimes I think it's more of, the mindset is more of, what special tools do I get to buy in order to work on CRTs? You really don't need any. There are, the tools you see here on this bench are what I use for 95% or more of repairs. All basic stuff you should probably already have for working on old computers. I do have a couple of pieces of specialized equipment that I do find I use occasionally, but it's kind of rare. An example would be a high voltage probe. This plugs into my multimeter and lets me measure the high voltage of a monitor. And so, like, if it's 25,000 volts, this thing steps it down to 25 volts, so the meter can display the 25 volts. Not necessary. It's very rare you actually need to measure the high voltage of a monitor. I think the big thing that I use that's the specialized tool is a CRT tester. This is handy for what I do because I work on so many monitors, but generally speaking, you don't normally need this because most of the time the CRT is not the problem. CRT tester comes in more handy when working on very, very old TVs because you can check the condition of the CRT before you go to all the effort of trying to get it to work again. Basically, if you need one, you'll know you need it. It's not just a whim. Other than that, though, there's really nothing special here. It's all very basic electronics and very basic single-sided circuit boards we're dealing with. CRTs are not as scary as you might think. Another piece of specialty equipment that I use is a degaussing coil. This one is an old piece of TV serviceman's equipment that came from a hamfest or something. It's just a coil of wire with a plug on it and a momentary switch. But I'll show you more about degaussing later, and I'll show you how to build your own degaussing coil without needing any special tools or equipment. You can build your own degaussing coil by using the one from an old TV. The bigger the set, the better. This is a 32-inch JVC. This one was found on the side of the road, laying face down. It's beat up. It doesn't work. The picture tube's got a big gouge in it. It's really not worth fixing or dealing it with. But we can use the parts to build our own degaussing coil. First thing we need to do is take it apart. Looks like, I think it's a number 2. Yep, number 2. So now we have the set apart. You can see that the degaussing coil there. It goes all the way around the outside edge of the picture tube, and it's zip tied together, and it goes down into the chassis where it would plug into the circuit board. There's a thermistor on the circuit board that controls the degaussing coil, but we don't need that for this. We just need the degaussing coil itself. So all we have to do is clip it out of its zip ties and remove it from the set. Okay, so here's the degaussing coil we scavenged from that junk TV, and the power cord, also from the TV. And really all we're going to do is combine these two items. I'm going to cut these zip ties off of this. Makes it just one big loop, and then I can coil this up smaller. It's all coiled up neat and smaller. It's got some zip ties on it holding it into a nice ring shape. I can trim those zip ties off, and I can splice on this line cord, and it'll be ready to use. One word of warning though, I'm doing this in a 120 volt country. I'm in the United States. This works here. I have talked to other people in 240 volt countries, and some of the degaussing coils in their TVs are actually 120 volt coils with a great big resistor in there to knock the voltage down. So if you're trying to do this in a 240 volt country, I would be very careful. Check the circuit of the TV you took apart. You might want to run this this coil in series with a light bulb, or in series scavenge that resistor as well out of the TV. But in America, we have 120 volt line cords, or 120 volt AC line, and the coils are designed for 120 volts. We don't need any extra circuitry. So here's the degaussing coil I made. I spliced the cord onto the cable coming out of the coil, and it's all zip tied up, ready to go. So I know I touched on degaussing earlier and how the Earth's magnetic field interacts with a television set. And here's a good demonstration of it. So right now the TV is working and the colors are correct. But if I turn this upside down, now it's different with respect to the Earth's magnetic field, and all the colors are screwed up. And if I turn it right side up again, it's fixed. So now, let's say I moved this set and the colors were screwed up when I turned it on, and I needed to degauss it. I'm actually in my kitchen right now, owing to the fact that it's one of the few places in the house that isn't already full of magnetic media and computers, because you want to be away from other things that could be damaged by magnetism, basically. Here's the coil. I've got a power strip to turn it on and off with. I can plug in the coil. What you want to do is start away from the TV, turn the coil on, bring it close to the set, and then bring it away. And see, now the colors are fixed, and it only takes a few seconds. Now this coil gets hot. You can only run it for a few seconds at a time, but it's all you need. And so now the colors are fixed, but if I were to turn this the other way, right side up, now the colors are all screwed up again, so I'd have to degauss it again. Again, you don't want to run it for too long. These coils do get hot. It's It's important to turn the coil on and off when it's away from the set. Well, if you turn it on while it's close to the TV, if you turn it off when it's close to the TV, it'll impart a magnetic field on the shadow mask, and you're trying to remove the magnetic field, not create a new one.
I think you're muted too. Okay.
Yep, there you are.
All right. Welcome back, everyone. Welcome back to VCF East 2020, our virtual show. That was Ian Primus and CRT Repair. Ian, you need to unmute. Okay. So we're going to take questions for Ian. We have a whole load of questions for Ian. So Chris Falla, do you have the questions ready for us?
Yeah, first question. Does the lead being used for discharging need to be a minimum wire gauge?
No, not really. I mean, anything you have that is wire should work. I don't know if I would. I mean, a 30 gauge Kynar wire should even still work. It's very, very low current. It's not going to burn it out.
Okay. And I'm not sure at what point in the video this question came in, but the question is, would this work on the Commodore 1702?
I assume that this is the discharging. I mean, they're all going to be almost identical. 1702 is basically the same as that TV inside.
Because at some level, a CRT is a CRT. I mean, is that a fair statement?
Exactly. Yeah.
Okay, cool. What do you use for test patterns and sound test?
So I've got a couple different things. I've got a little handheld pattern generator, and that's what was displaying the color bars and the tests in my videos. But then I also use a DVD. There's a test pattern DVD that used to be on techpreservation.org. It's like Creative Commons, it's like free license. It's just that the site it was on has gone down. I have a copy of the ISO. I don't know if there's a good way of hosting it or getting it out to people readily, but it's like a 10 meg file. But you burn it to a DVD, and then you can use the DVD player to generate test patterns.
Okay. I have a 1701 CRT where the picture collapsed to a single horizontal line. Where would you start looking to fix that kind of problem?
That would be the vertical circuit has failed. Like your horizontal is working because you have horizontal. It's just that there's no vertical deflection. First thing I'd do, honestly, is to hit it. Hit it and see if the picture pops back. You'd be surprised how often the yoke connector cracks right where the yoke plugs into the motherboard or to the chassis. The 4 solder points there, those can crack or something downstream. So I would look at that and see if any of those solder joints have broken, traces cracked. It should be a really pretty simple fix.
Cool. I don't understand this question, but the question is, who is hoarding all the PVMs?
Not me, honest. No, not me. No, there's a lot of them out there. They're not that uncommon. Certainly, if you look around, they appear.
Okay, what's the typical cause of and solution for a monitor which leaves a hot center bright spot when turned off? I thought that's what they all did when I was a kid. You turn the TV off and you kind of stare at this thing as you dozing off to sleep.
So it depends on the set. Like it sounds like the high voltage is not bleeding off very quickly. It could be that the bleeder circuit isn't working. It could just be the way the set's designed. Some of them do that. Also, sometimes as the tube gets really weak, they are more prone to the secondary emission as it shuts down, I've noticed.
But it's not really a problem, right?
No, it's not really a problem. It's not going to hurt it.
Okay, hold on one second. Questions are rolling in fast here. I have a VHS tape handheld degausser. Would that work?
Yes, yeah, tape eraser, like the old Radio Shack bulk tape erasers they used to sell. Those work great for degaussing CRTs. Obviously, a standalone, like a professionally made degaussing clothes, basically the same thing. The thing that I made in the video, it gets really hot really quickly. You can only have it plugged in for a couple of seconds, but really that's all you need. You saw it; it does it very quickly. Other things you can use is a big old Weller soldering gun, the big ones. Those generate ferromagnetic fields. You hold it sideways against the screen and pull the trigger. That'll work too. A big AC drill motor can also work. One thing you don't want to do is attempt to use any sort of permanent magnet. Like I've heard of people try to spin a magnet on a drill. That's I mean, maybe technically it'll work, but you shouldn't bring a permanent magnet next to the screen, and you shouldn't be doing things that might involve flinging a magnet across your room.
Yeah, I'll second that, because when I was a kid, I heard about magnets deflecting the TV picture, and I tried it, and there was a permanent discoloration on my mom's TV, so that was a bad thing.
Yeah.
Definitely vote against that one. Okay, do you have a good source for brand new CRTs? What is the most interesting / tricky problem you solved with a CRT, TV, or monitor? So a source and the most interesting tricky problem.
I mean, source for brand new CRTs, I don't know if you're referring to the tubes themselves or the entire set. Certainly there aren't very many new old stock TVs or monitors kicking around, although occasionally they turn up. For replacement picture tubes and things like arcade monitors, I will scavenge them out of televisions found on the side of the road. But certainly new old stock stuff doesn't turn up very often. As far as like what was the most bizarre or most, what was the question?
The tricky problem you solved. The most interesting type of problem you solved.
I think the most interesting type of problem was probably actually on an IBM one. It was all-in-one, like a PS1. It was one of the EduQuest all-in-one IBM machine, where a capacitor next to the flyback was exploding. You'd replace it with a new one, and it would explode. Turns out that there was like double the voltage on that circuit. It was supposed to be like 130 volts or something, and it was getting like nearly 250 volts on it. So it was absolutely detonating this 160 volt cap. And it turned out to be a short somewhere else in the monitor, completely completely separate area. The 12 volt line was shorted, and that was causing the voltage regulator to not regulate and not work correctly. And it was just dumping way too much voltage into this B plus rail and blowing up the capacitor. That was a fun one to find and fix.
Okay, heard about this one a little bit recently. How can implosion lenses be safely removed to clear out bubbles?
Okay, so you're talking about cataracts. I had a segment on that I had to cut for time. Depends on what kind of tube you're talking about. If you're talking about a like a small monochrome terminal tube, then I put it like the glass up in like a trash can or something and heat it with a heat gun. And if you go real slow, you want to heat it evenly, and you can get it to the point where the bubbles will start to kind of expand and collect together, and eventually that glass will lift off and it will come off. The more bubbles, the more like mold spots looking things in there, the easier it'll come off because it's detaching as it goes. For the old color TVs, really old color TVs like the 21 inch round and 25 inch rectangular TVs from the 60s, those are starting to have the same problem. Those are a lot more dangerous because they're much bigger. That requires more special preheating. You want to do it outside on a sunny day. You want to get the whole tube really warm before you start attacking with a heat gun. It's a process. I mean, I should probably do a video specifically on that repair because it's not something I can just explain in a couple of minutes, but that's basically the gist of it. You heat up the faceplate into the point where it starts to detach, but obviously wear safety glasses and gloves and stuff.
Okay, Stephen Edwards asks, is there any cure for CRT burn-in?
You can't unburn a picture tube any more than you can unburn toast. So it's
That is the most apt answer I have ever heard.
Unburnt toast.
You can replace the picture tube with another one. You can live with it. I've heard of people suggesting, oh, well, you could burn the whole rest of it, but that's kind of counterproductive because now the rest of it's dim. You could put a tinted glass in front of it. That's what a lot of the arcade machines did. If you ever look at a Pac-Man machine, it has a piece of tinted glass in there to hide the fact that the maze always gets burned into the tube.
So I'm going to extend this question. So have you ever had a CRT implode on you unexpectedly? And then I would add to that, have you ever had it happen expectedly?
Yeah, I haven't had one explode unexpectedly. Certainly I've had them explode expectedly. Because when you're getting rid of a junk tube, they're incredibly hard to break. However, I remember one time I was getting rid of a burned-in arcade tube because I'd replaced it. It was a junk tube, and I had laid it like tube glass up in the trash can, and I threw a cinder block at it from quite a distance, like, I don't know, it was 4 or 5 feet away. The cinder block hit the tube, the cinder block broke, and the tube didn't. So like it's they're very sturdy to things from the front, but from the back, sure, you can break the neck with your fingers. You have to be real careful with it because it's very fragile back there. They tend not to implode violently. Like they tend to just break. Like it's not really as interesting as you think it would be. Like if you crack it, the air will hiss in. If you smash it, it'll make a loud bang, but it doesn't really throw glass around because it's kind of designed not to. At least the modern ones are. There's a tension band around the rim of all modern picture tubes that work as the anti-implosion. It pushes in on the edges, makes it stronger, and also if that glass breaks, it just kind of keeps it all together. One time I had a junk 32-inch TV in my garage. I had brought it home, figured out that the part that it needed was unobtainium and it was not fixable, so I was just going to throw it away again. But when you remove the back cover from a TV, it loses a lot of its structural integrity, especially when it's that big. And the face with the tube and everything were sitting in the garage, and like the heat or the temperature change, and the thing fell over on its face with an incredibly loud boom. And then when I went out to I picked it up, and the glass was all shattered like a mosaic or something. It was all shattered, but it was all still together. But it kept making these clinking noises for the next hour. Is it just like the tension was getting relieved slowly, and it was clinking and breaking little pieces.
Someone said you can scrape off the burnt parts on toast. All right, enough said of that. Real question: how compatible are tubes for swapping?
Surprisingly so. You have to watch out, make sure that the filament voltage is correct, the pinout and the neck pinout's correct. But I replaced the picture tubes in 12-inch like computer terminals, for instance. Those monochrome tubes are very interchangeable, and you can take the picture tube out of an Apple II monitor, one of the green monitors, and put it in like a VT100 or one of the other terminals if it's got a bad picture tube. I once put the picture tube from an IBM 5151 monitor into a black and white Zenith TV. So I had the world's only long persistence green phosphor television with word perfect burn-in. So yeah, you can swap the tubes around a lot. With color tubes, there's a little bit more caveats because you have to get the deflection right with the yoke and so when you're swapping monochrome tubes, swap only the glass part, swap only the tube, keep the yoke with the chassis. With monochrome tubes, it's really easy to do that. With the color stuff, it starts to get hard because you have to reconverge it when you swap the yokes, and some yokes are incompatible with some CRT neck designs. So you want to, if possible, keep the yoke and the tube together. So there's a whole science behind trying to cobble that together. But it's surprising how many color tubes you can swap too. I repair arcade machine monitors with the picture tubes from junk TVs.
Cool. Somebody said if you hit an implosion band equipped tube on the top with enough force, it will still implode. I just thought that was an interesting experience somebody had. So let's see. I have a Commodore 1701 monitor. The flickering is quite visible on it. Honestly, having nothing to compare to, I'm not sure if this is normal, but assuming a fault, any thoughts on what could cause visible flickering?
Visible flickering. I mean, is it displaying the image correctly but just looks flickery to you? Or is the whole thing just flickery because you don't have an image sending? If you don't have an image source, it will flicker because it has no signals to lock onto. It could also be that you're just not used to what 60 hertz, or if you're in Europe, 50 hertz refresh TVs look like anymore. Because I've known, especially younger people, when they've never seen or really worked with regular TVs, old CRT TVs, they see the flicker and they notice it readily. Whereas somebody like myself that's been watching television for his entire life is just so used to that you don't even notice it anymore.
Cool.
We'll keep taking questions. Keep going.
Yeah. So do you ever remotely walk people through CRT rejuvenation? I have a rejuvenator and a weak CRT, ...
Yeah, no, I can do that. If you want, you can message me on Discord and I can walk you through it later and I can help you figure out how to use your machine. I actually had my rejuvenator with me. I was going to try to show off more, but of course, planning and stuff. And yeah,
that's very kind. Thank you. Are there still facilities to replace elements and phosphors in rare CRTs?
No, as far as I know, but with a maybe. The last picture tube rebuilder in the United States was Hawkeye. When they shut down, they donated all their equipment to the Early Television Foundation Museum in Ohio. They set it back up and they got it to work, and they were able to rebuild some tubes in like small controlled tests and stuff. So the technology is not completely lost. The equipment is not completely lost. They're not doing it as a service yet. I think they wanted to, but there's a lot involved to do in doing that. And not only that, getting replacement guns is going to be a problem because some of the materials you need to make them are now no materials in the environmental world. So that it maybe in the future there will be a way to do that, but right now not so much.
Okay, if you remove the safety shield because of the cataract effect, do you have to put something else back on?
I put the safety shield back on. Once you take the glass off, you clean the goo out from between the layers, and then I stick it back on with like some foam tape at the edges to keep the spacing right, and then use like silicone around the edge, a bead of silicone, or even just packing tape to keep the dust out of it. I don't think that it's really all that integral to the safety of the tube. I've never had one randomly implode. I've never had one fail after been repaired like that. But you do really want to put something back in there, otherwise it'll there'll be a gap between the tube and the casing. So you want to put the shield back in.
So actually, a friend of ours, Doug Crawford, I didn't watch him do it, but I saw the result of him doing exactly that. And I was questioning that as well, because before you do this, there's a material filling the entire void between the two glass. Then after you do that, then there's a gap, and that gap is okay, is what you're saying.
Well, I don't want to speak for the safety of anything. As far as I know, it is. I've never seen it be a problem. Your mileage may vary. Don't sue me.
Good answer. Is that dot in the middle normal? When turning off a TV or arcade monitor, I only see it happen on 2 of my games.
Yeah, it's pretty normal. It's just the tube could be weak. I think I talked about this earlier. Tube could be a little bit weak. The high voltage might be bleeding off more slowly in that particular monitor. Some flybacks have built-in bleeder circuits. Some of them don't. Sometimes the bleeder circuit fails. It's not really that big of a deal.
Okay, and right now I think this is the last question. When you tube swap, which yoke do you use?
If possible, I want to use the yoke that came with the chassis, with the actual monitor. I want to keep the monitor's yoke with the monitor. But sometimes with the color tubes, with like an arcade monitor tubes, like that's a lot of work to reconverge the tube, and sometimes you can't quite get the old yoke to work with the new tube. So if possible, I try then in the color sets for the arcade monitors, I do try to reuse the TV yoke, the old yoke, if it's close enough. Measure the DC resistance. The most critical value is the horizontal coil, making sure that it's as close as possible to the original one. That'll be the low resistance winding. So like one of the things might be 2 ohms, and that's the horizontal, and the other one might be 20, 30s, 50 ohms. You want to be as close as possible on the horizontal, like within I don't know, half an ohm. Vertical, you can fudge more. If it's too far off, the picture might fold over. It might not deflect properly, or if the horizontal is too far off, the thing won't even turn on. But it's kind of up to you what you think is less work. Is it less work to swap the yoke, or is it less work to reconverge it, or swap the wiring and try to get it to work, or is it less work to reconverge it? With monochrome tubes, though, I always keep the yoke with the chassis because it's so easy. There's no convergence. You just slide it off, slide it on. While the set is on, you just turn the yoke to align the picture to make it straight, and that's it.
All right, got another question. What do I need to keep in mind if I want to substitute yokes in black and white circuits? Is there anything I can do to ensure they're compatible?
Keep the DC resistance as close as possible. And technically, what you're really comparing is an inductance, but like most people don't have an inductance bridge, and it's the specs aren't always printed on there. So I just do DC resistance is close enough most of the time. If you don't know what the original yoke was supposed to be, that could be a problem. If you do know what the original yoke is supposed to be, just try to get the replacement yoke to be as close as possible, resistance-wise, especially in the horizontal. And again, with a black and white, I would just, if possible, use the original yoke because it's so easy to swap from one tube to another. With a black and white set, there's no convergence. You have to get the yoke aligned, but then there's two metal rings usually on the yoke of a black and white monitor that allow you to center the image. Those are just magnets that bend, slide the thing up and down, left and right, and lets they kind of interact with each other, but you fiddle with it until you get the image centered.
All right, Ian, looks like we are at the end of the questions. You had said that you had to cut for time on certain portions of your video. You had mentioned the cataracts. Was there anything else that you cut out from your video that you might want to talk about?
I did a segment on rejuvenation. I did a demo on that, but that took too much time. I had to cut it out. I also talked about pattern generators, which I did right now. But the cataracts wasn't a full segment. I started recording it and then realized I was going to run out of time, so I didn't. Maybe I can try to put together more content and publish it somewhere else or something later, if there is enough interest.
I think there definitely be enough interest based on what I see. So it's possible you can do a follow-up video, a second part.
Maybe, yeah.
That's always your option.
Yeah, video production is not my strong suit. This was kind of a new experience for me. I pretty much learned how to edit video badly, creating this. So but I could try to see what I can do.
And just know that you have other people here that can help you with the video recording anytime you're here, because I know you come here frequently. So just keep that in mind.
Mm-hmm.
All right, we had another one. I have a monitor with a slight hole in the phosphor. Is there any danger with that?
No. The electrons are not going to hurt you. You'll have a dead spot there.
Someone said +1 for follow-up video. So obviously there's a lot of interest. Okay, more content, please. So a lot of people have a lot of questions because I guess this is a common thing and it's something that seems to be a little bit more difficult to understand than the typical machine parts. It seems to be a whole different realm than, all right, I'm going to solder this. Well, CRTs, it's like some people, it's like, oh, where do I get started with this? So I think that's why there's lots of interest because people have had some questions. Oh, we have some more questions. Is there any danger of powering up a CRT that hasn't been powered up in a long time? Precautions that I should be taking?
Depends on what you mean by a long time. If you're talking about a television set from the 1950s, then yes. If you just plug it in and turn it on, you run the risk of damaging something because the electrolytic capacitors of the power supply might have shorted. They might need to reform. In the case of an old tube type TV, I always try to bring it up slow the first time, either by using a series light bulbs. You want to use something like a 300 or 400 watts worth of light bulbs for your average console TV from the 50s. Pull the horizontal output tube if you can, if it's not series string. If it is, you disconnect the plate cap. And you bring it up slow and let the power supply capacitors reform. If you don't, you risk burning up the rectifier tube or burning up the power transformer if it has one, and or burning out your resistors and other parts. If it's something modern, like from the 70s, 80s, probably not. It's probably not old enough yet, really. If it's been sitting an awful long time, someplace dirty or damp, you might want to let it dry out, like putting it near an air conditioner for a while or near a dehumidifier to let any moisture get driven out of it, because if it's really filthy, maybe dust it out, but there shouldn't be any real danger unless the power supply looks particularly scary or there's something unusual about it. But if I just found like a random color TV from the 80s on the side of the road, I just plug it in. It'd be fine.
So you're getting different comments. People are saying, well done, awesome session. Video editing skills was also one of the things that I learned this year at Stephen Edwards. Because Zoom, you had to teach classes to his college students. So someone is suggesting convergence alignment demo would be great. So it's just a follow-up.
Yeah, that's certainly an involved topic and something that would take an awful long time to explain. I just kind of mentioned it in the video, but that's one of the things I could literally do an entire video just on convergence because it takes forever anyway.
All right. Another question.
I got it.
All right.
Do you recommend changing all caps after a period? Most CRTs are getting very old, or just wait till a fault?
I tend to, well, depends on what your goal is. Like if it's an arcade monitor, something that's already really high hour, yeah, I change all the caps. If I have to work on it, if I have to pull the chassis, I just recap an entire arcade monitor because there's not very many caps on an arcade monitor. And those were cheap parts in 1981, and now they've been on for a zillion hours, and they're probably worn out. Something like a computer terminal, it's kind of case by case. Like if it's looks like if it's developing issues or has problems, or if I intend to use it an awful lot, then sometimes I will recap the whole thing. Other times I just fix the fault, and then if something else crops up, like if I notice a lot of problems crop up, then yeah, I might recap the whole thing. But I tend to just fix the faults, and like I said, unless there's some other circumstances. But for like I use CRTs literally every day. I don't have any LCD monitors or televisions, and only a couple of the devices I use daily I've actually recapped. Most of them either still work or have had minor repairs.
So you have any 4K CRTs? Just kidding.
No.
No, I definitely appreciate those things, though. I mean, the technology that went into those back in a time when technology was rare. It's just the development of television itself is just absolutely brilliant, and I just have a lot of respect for it.
Yeah, it's fun technology. I enjoy it.
I think we do have one more here. I watched my Commodore PET 4032 screen fail to a single line at the top of the screen. Is that going to be vertical caps that need to be replaced?
So it's a single line, but it's at the top of the screen, so it's a horizontal line, but it's indexed to the top.
That's what they indicate, yeah.
Huh, that might almost sound like a logic problem with the Commodore, simply because like the vertical fail, the image should be centered in the middle, because you wouldn't be deflecting it anywhere, but it's being deflected all the way to the top, which would indicate that the vertical is working. It's being driven.
Yeah, I was going to say, hypothetically, is there a failure mode where the vertical would be permanently driven up, or the vertical would be permanently driven up? Yeah, that's very unusual, isn't it?
Yeah, because and you couldn't just apply like a solid signal to the yoke. You'd burn the yoke out. If we had a DC voltage across it, because it is a coil. It's basically like driving a speaker and an amplifier. You're driving a coil that's, instead of moving a magnet, it's moving a beam. So that almost does seem like might be a logic fault with the computer. Although being a Commodore PET, there's all sorts of things are possible.
Yeah, true. And a follow-up to the caps. So, cap recap not by age but by run hours. That's what you're saying.
Kind of, yeah. I mean, it's kind of hard to tell. Like, obviously things don't have an hour meter on them. But you can kind of look at something and kind of get a feel for how much it was run, how cooked looking are the boards. Like that TVI, the little Panasonic monitor I took apart had a zillion hours on it. You could see how burnt the boards looked, like how cooked everything looked. And yeah, the rest of the caps in that were in pretty bad shape. But I just replaced the ones that were really dead. It worked okay. That's all I would do on that if it were mine. Well, it is mine, but that's all I would do on it, even if I intended to use it a lot, because if it breaks, I'll just fix it later.
Right. Question in the other chat. Not sure if it was among people in there or for you, but it says, have you noticed any common problems with the Heathkit H88, 89, or 90 CRTs?
Yes.
Care to elaborate?
Those have the same kind of problems that a lot of CRTs from that era have. The horizontal circuit has I think if I remember correctly, it still has the bipolar cap that fails all the time. Usually one of the interesting things about that terminal and a lot of other terminals is that the horizontal, there is no local oscillator in the monitor. It relies on the horizontal sync signal from the computer. So if something happens to the computer, and it's not outputting any horizontal sync, then there will be no high voltage, no picture, no nothing on the monitor. It looks like it's a monitor problem, when it's really the terminal or the computer has died. And so if you were dealing with one of those that's totally dead, I would put a scope on the horizontal sync line and see if you're even getting anything. A lot of monitors are like that, like the ones used in a lot of terminals, like the K Pro, the Heathkit terminal for sure, because I've gotten bitten by that before, where the terminal actually had a bad Z80, and that was the reason it didn't work. Then the IBM 5151 is another monitor like that, where if it's not plugged into the computer, you get no high voltage.
All right. That was a lot of good questions.
Yes, absolutely.
We come to the end of the questions. I'm sure we can go on for quite a while. A lot of people.
The more you answer questions, the more people have questions.
So he will be Ian Kremis, also known as Sark, will be on the Discord channel to answer any further questions. That was wonderful. Thank you for doing the video. I know that it was a little bit difficult because you didn't have the editing skills, but to us it looked great. So thank you very much for doing that. And
well, along those lines, Stephen Edward complimented you. He said you did a great job. So Stephen Edwards, is a good source of that. So.
Well, so I don't know what I'm doing when it comes to video editing, but apparently I can fake it. So.
All right, thank you, Ian, and we will see you around.
Yep.
Next up, I know, guys, we're running a little bit late. We're about 30 minutes behind schedule. So next up is going to be Ethan Dix. He's going to have a short video, about 9 minutes, 50 seconds, on 6502, the first 5 years, highlighting different computers that came out the first 5 years that this 6502 was invented. So when you're ready, Ian, hit it.
Oh,
sorry.
My name is Ethan Dix, and this is a look at the first 5 years of the 6502. By the mid-1970s, there were already several 8-bit microprocessors available, the 8080, the Z80, and the 6800 at the head of the class. Chuck Peddle was part of the team at Motorola who developed the 6800, which sold for $300 in 1974. He wanted to produce a much cheaper processor to encourage widespread adoption, so he and several teammates left Motorola to found MOS Technologies, which created the 6502. The initial price was an insanely low $25, 1/10 of the competition. At those prices, by 1976, several companies were developing home computers around it, Apple and Commodore being two of the best known. With only a few minutes, I can't cover each and every home computer with the 6502 in it, but I can show off a few I have handy. Let's have a look. This is the Sim-1, a Kim-1 clone from 1978 made by Synertech, a second source company for the 6502 and some of the I.O. chips. It comes with 4K of RAM and a monitor program in ROM with room for ROM upgrades like BASIC and a resident assembler. It has the basic Kim-1 I.O. connectors across the top, plus a couple of additional connectors, including a built-in serial interface with both 20 mA current loop and RS-232 drivers. The monitor program lets you inspect and change memory, inspect and change CPU registers, save and load to paper tape and audio cassette, and execute code in RAM or ROM. Using either the built-in keypad or a dumb terminal, you can enter a program into the Sim-1 and execute it. This is the Rockwell AIM-65, a single-board computer from 1978. It's an enhanced Kim-1 clone with the same connectors for memory and I.O. expansion, but instead of a calculator keyboard and 7-segment LEDs, it has a 20-character ASCII LED display and a full keyboard. It also usually shipped with a small thermal printer. The AIM-65 came standard with 1K of RAM, internally expandable to 4K, a monitor ROM, and 3 open ROM sockets. There were several firmware options, the most common two being ROM Basic or a resident assembler program. This particular AIM-65 has been upgraded with a third-party expansion, originally sold as a multi-I.O. board sitting on the application connector. This one here is a modern recreation of the primary function made by David Colglazier. It talks to a standard Commodore 64 floppy drive in much the same way a Commodore machine does, and can be used to load and save memory and read and write files from BASIC or the assembler. The included firmware lets you use the disk drive like any other device on the system. The Commodore VIC-20 came out in June 1980 and was touted the wonder computer of the 80s. It featured a color video and sound chip capable of displaying a screen of 23 by 22 characters in 8 colors with one voice sound. The base RAM was 5K, tiny at the time, but expandable to 32K. It was Commodore's first computer to use the new single drive Model 1540 serial interface 5¼ inch floppy drive. In addition to the peripheral interface, the VIC-20 came with a user port that could also be used as a serial interface with either an RS-232 cartridge or the low-cost VIC modem, shown here. It's also the first Commodore computer to sport a joystick paddle port compatible with Atari 2600 controllers. Most programs of the VIC-20 came on cassette or ROM cartridges, but some did come on floppy disk. Less than a year after the VIC-20 debuted, the Commodore 64 was announced, and even though the VIC-20 is credited with being the first million-selling computer, it was quickly eclipsed by the vastly more capable Commodore 64. Still, in early 1980, the VIC-20 was a taste of what was to follow. This is the Commodore PET from 1977. It was one of 3 major home computers that came out that year. It originally shipped with 4K of RAM, 8K optional, a 40-column monochrome screen, basic in ROM, a built-in tape drive, and one of the worst keyboards in history. There were 2 of these at the public library, and I would go down every Saturday to take my turn on one for an hour, writing games in BASIC and hooking up home-built devices to the user port in the back. This arcade keyboard add-on came from my own PET we got a couple years later. My brothers and I used to play a lot of Space Invaders, enough that we wore out 3 keys in the original keyboard. I made this from the shell of a Radio Shack 115-1 Electronic Experimenters kit and 3 genuine arcade buttons I bought from the local arcade supplier. A quick demo of the Space Invader keys. The program is very basic. And after waiting for the cassette to load, here's Space Invaders. Well, let's a quick look at a few of the machines from the first 5 years of the 6502. There are many more, from Apple, Atari, and Ohio Scientific, to name a few. We've barely scratched the surface here. For those interested in comparing the features and capacities of the computers shown here, there's a list at the end, including memory sizes and I/O capabilities. I'm looking forward to the next in-person VCF, where I plan to bring these out and maybe a couple of surprises as well. Hope to see you there.
Right, welcome back, everybody. Welcome back to VCF East 2020, our virtual show. That was Ethan Dix and 6502, the first 5 years. That was a wonderful. I love to see all those computers. Some of those I didn't even know about. Some of them I knew about, like the Commodore PET, but some of them I didn't know about. So, Chris, do we have a question for Ethan?
First of all, a comment. There should have been some mention of the Victor 9000/Sirius 1. Comments on that?
Well, I don't have one, so I didn't have anything to make on it.
There you go. And the other one was a Jolt.
Right. I don't have one of those either. I know what they are, but
Tell me about that, because I never heard of the Jolt, and I love the 6502, so I'd like to know.
It's from the SIM, KIM, AIM era. It's just another one of the little tiny single board processors. They were advertised in the back of magazines. I remember seeing the ads, but the video I did was on machines I actually had. I was in possession of. It wasn't meant to be a comprehensive history of the first 5 years. Just machines I have from the first 5 years.
Okay, cool. That sums it up. Yeah, no criticism on my part. I mean, any 6502 is good in my book. That's for sure.
So, Ethan, you had said that you are running out of time and you wanted to actually include some more computers in your video. What else did you want to include that you didn't include this time?
Well, if I had a bit more time, I could have folded in. I had a later PET that was actually the first computer I ever had from 1979, which was like the PET in the video, except it had the full-size keyboard. It came with 32K, and I had a couple of applications from a science museum I used to work at. They were an energy conservation sort of a themed exhibit when they had 3 PETs running an energy quiz, an energy hangman, and a driving for dollars activity. And those would use the user port to drive an arch of light bulbs, like a circus marquee. And I did not get a chance to finish it, but I began reconstructing. Basically, it's something that lives on the user port and just light up lights based on whatever byte you pass through the user port. So it would have been just a longer demo of some of the machines. I also would have included more time on the SIM1 because it's also possible to put a 1541 disk drive on that as well, but I'd have to construct that from scratch, and that just didn't quite make the time that I had.
Yeah, it makes sense. You have another
Okay,
question,
yeah, we
Chris?
have a question come in. Did the PET use a custom graphics chip, or was it all discrete TTL like in Apple II?
Both. So the PET of that era in the video is discrete graphics. It's TTL shift registers and buffers and a little bit of local video RAM. The later PETs, the 80 column PETs starting in about 1980 or 81, they weren't using a custom chip. It was an off-the-shelf chip, a 6545, which is very much like the 6845, which was used in the IBM PC's monochrome adapter.
That's it for
So, how did you come up for the idea for the exhibits?
Well, as was mentioned earlier, the 6502 is still available from Western Design Center. It's a chip with a very long history, and I just thought that with Chuck Peddle, the 45th anniversary of the chip, that there were some interesting machines in the first 5 years, and we see a lot of 1980s stuff, but 70s stuff we just don't see as often at VCF.
Yeah, that's true. There seems to be a lot of bent towards microcomputers, and I think that's just because a lot of people grew up with them. And it is. We do try to get to the big iron, larger computers, but it's difficult and expensive for people to bring in. But these are little smaller microcomputers that are, in the 70s, like you said, and so it's great to have you show them off. Now, what about the collecting them? All those individual computers, how long did it take you to collect them? Some of them look to be in great condition, the Commodore Chiclet Pets. Can you tell a little bit about how you collected them and your condition?
Well, the SIM1 was from a buddy of mine who was cleaning out his closet. We have lunch together with a bunch of other computer nerds, and he's like, "Who wants this?" I'm like, "I'll take it." The AIM-65 I bought from somebody on the classic computer list. He still has a couple more just like it, and I bought some parts and things from him probably 15 years ago. But that's what I got, where I got it from. The VIC-20, I couldn't even tell you where. It could be one of the ones I got when I was in high school. It could have been It could have been a little bit later, but VIC-20s are VIC-20s. The PET specifically, I bought at Vintage Computer Festival Midwest when Vince Brio was moving out west. He was selling off a bunch of his stuff before moving, and I was there at the right time to buy the PET from him.
That's great. Sometimes it's just opportunity to collect them. How hard is it to like maintain like the machines? When you got them, was there a lot of repairs that you had to do to them, retrowriting and other things?
I wouldn't say a lot. Those are pretty solid machines. A little bit of repair. Reasons why I didn't show off the 1979 PET is it has partially collapsed vertical video and has a motherboard problem. So I definitely was excited to see Ian's presentation because I've got to do exactly that, which is change the caps in my vertical circuit. And also then figure out what's going on with the motherboard that it's not running. PETs, they have failures like the static RAM goes bad, which includes the video RAM. They'll have a usual
breaking up.
Things like pulling all the chips out of the sockets and putting them back in. That'll fix a lot of problems. But it's just really bouncing things up and down and giving it a shot. So minor repairs.
All right. So what do you often play with these machines? Like, try different programs, or is it just a random whatever you're feeling like?
Am I back?
You're sort of frozen up a little bit. I don't know if you're on a wireless connection or a wired connection. Ethan, you're frozen. All right, so all right, let's see. Ethan, hopefully you can come back. You have a question? It's frozen. Yeah. Is he frozen on your screen?
Yep. He's ready.
All right, Ethan, sorry, we seem to have lost your connection. So we're going to switch to Corey Cohen in the Vintage Computer Museum. So maybe, Ethan, we can shift it to Discord. Okay. All right. So Indy, ready to shift to the museum? Yeah. All right. I'm ready to go. Switch.
We ready? Let me know. We're live. We're live. Good afternoon, everyone. I'm Belinda Reedon. I've been a member for about 4 years or so. I got volunteered in the military definition of coming to work for VCF, volunteering for VCF, because I used to work for EAI, Electronic Associates out in West Long Branch, working on the analog equipment that they produce there, hybrid analog equipment. So it's been a very enjoyable time. I'm a full-time member at the InfoAge, as well as VCF, and as well as the electronic radio technology exhibit. So I'm really invested in this place. We have several exhibits going down an aisle and coming back around in sort of ascending order of vintage. We have here the first exhibit, which is a Bendix G15, about 1956. We're getting back a ways. Notice you don't have, for the naive people or the people that are later in vintage computers, we don't have a monitor, we don't have a keyboard. We have a modified typewriter that actually gets hooked to it, and a XY recorder or an X strip chart recorder that's in the rear. So your problems would be dynamically printed on. To actually program the computer, if you want to call it that, there are program cards here. Basically resistors. I don't know if you can get in, Corey, into the side here. Program cards would go into a card file. Way in the back, I actually have a flashlight. Let's see if we can get in here and get a better shot of what's going on. Everyone can see here, part of my shake.
Yep, we're good.
We're good. And in the front, we have also plug-in modules. The plug-in modules are vacuum tube. These are what's called 9-pin miniatures.
usually 12AX7s, 12AT7s. They would also plug in too. The color coding made a difference on what function was actually getting done in here. They're up here in the front in card file. We have some blues, reds, and gold color. We have a gold and a red colored here. So this is not our artifact. This was actually on loan to us, so there's not much we can do with it right now until we get to play with it. You did have a function of loading to magnetic tape. Control data, looks like they made this for Bendix. So very heavy duty in the construction. You'll notice this is forward 19-inch rack mount. So these things were built to last, not knowing when, of course, it was going to be obsolete. But these things were built in order to withstand the test of time. Over here, you can start looking at Remington Rand, the initial part of UNIVAC. We have core memory over here. I'll start with core memory first. Core memory is a ferrite, and I actually have an illustration. I'll bring it over here. I'll walk back over to the illustration so you can see up close. That's very fine core that's been hand sewn. And if you look here, we have ferrites. These are actual ceramic ferrites with a read, write, and sense line that gets put through it. Depending upon the direction of current flow will determine how you magnetically permeate the ferrite. Either the flux is going one way for a 1 or a flux going another way for a 0. All the circuitry here, all these transistors are most likely germanium. These were the drive circuits to actually program core memory. This is very sparse core memory. You probably are only looking at, I don't know, 400 bytes maybe. I haven't actually calculated what's there. But alternatively, look over at what we have framed as very, very fine core. We put into perspective on bits, bytes, and kilobytes, megabytes. That's 1 bit. Notice if you get a close-up, Corey, of the 1 and the 0 indications for a flip-flop. Again, indicating either a high or a low. 8 bits to a byte, 1024 bytes to a kilobyte. Fast forward to today, and you go all the way down to a mini or micro SD card at, I believe that's a 3 gigabyte, if I'm not mistaken, in there. Next to it is, of course, processors, which we'll get down the end of the line there, a 6501 processor. A lot more of the UNIVAC registers that are all, again, vacuum tubes. So is that flip-flop. You can't see it in the back unless you see it through the mirror, but there are 7-pin, 6 CL6s, and probably a couple of 9-pin and miniatures. So again, this stuff all needed warm-up, and we basically was biased as an analog amplification that we basically saturated either one way or the other way. Very early technology. As we walk on down, computers started getting into analog computers. Think of analog computation as a box full of a lot of mathematical equations, mathematical functions, addition, subtraction, division, multiplication with the proper circuitry. EAI TR20, I'm going to pull out some illustrations here because there's some history behind it. Between the transistor being invented at Bell Labs here in New Jersey. New Jersey has been a real hotbed for technology of this era. EAI is a transistorized unit. We affectionately call this whole double racking system George, made by George A. Philbrick. This computer was a custom design. All that came out of George A. Philbrick was custom. It was like a Chinese menu. You went to the Philbrick company and said, I need of these many mathematical functions that I need to do. And Philbrick researchers would put together a combination or a complement of power supplies and functions to do what you needed to do to solve your problem. This is fairly clean because A, it doesn't run right now, it will be restored, but B, you would have a whole mess of patch cords coming off your variables, which are your pots up here. down to the different functions that you needed to do. Very high voltage here. You'll notice down here, if you can get a zoom on, Corey, I don't know what you can do. To fire up a lot of this stuff here, these were monitoring points, but you're talking about power supply rails at plus or minus 300 volts. This was what's called a 100-volt machine. With all analog computers, you have a ceiling at which you can only work from. If you looked at our ceiling here, which is about 9 feet or so, the reference voltage that was used in your computer, very, very accurate reference voltage, we're talking somewhere in the order of 0.01% of either 10 volts or 100 volts. So you had to be very accurate in the voltage stability and regulation. You would then scale your voltage. This is a dynamic type of function that allowed you to model a particular dynamic function. I used this particular model, a TR20 in college. One of the exercises that was given to us, which could also be done here, was a wheel hitting a chuck hole. You have three functions that are happening with that: the tire, the shock absorber, and the spring. They all have different dynamic functions. You could model that over and do your variables up here to decide what's the best ride for the best bang for the buck in suspension on a car. You didn't necessarily get a printout of numbers as you do with digital computers today. This was more a dynamic function that could be done lightning quick. Digital computers of this era, like the Bendix, and as we'll see even back now with the IBM series of computers, were very, very slow. So you needed something else very expensive to have to do any type of problem. You wanted to get something fairly lightning quick, you used an analog computer, especially if you were modeling a dynamic process that you wanted to see. People that were using analog computers at the time and could afford the super big hybrid units were the US government, US Air Force, even petrochemical plants. So a lot of chemical and refineries were using analog computers to see their dynamic modeling of what was going on. Again, 100-volt unit, but also vacuum tube. So you had to worry about vacuum tube failures, drift, that sort of thing. The AI comes out with a little bit better model. Let's open this up so you don't get the glare off. Here. This is a transistorized unit. This unit is made with germanium transistors. We used to call them trays in the AI. These would slide into this rack once you removed the patch panel. Now the TR series was made in two models, a TR10 and a TR20. The TR10 was a fixed panel that you had to program with patch cords your particular dynamic process. Well, if you were several engineers in the particular department that you were working in, you had better make accurate notes before you put all your patch cords, because you're going to have to take them apart for the next engineer to get on. TR20 comes out and says, for a little bit of fraction of the price of the computer, we will get you extra patch panels, and then you could take with a lever, pull this off, slide this away, and walk that back to your desk. Now you don't have to deprogram the machine. Here's your programming, and the next engineer pulls his patch panel on and puts it up. Very ingenious process. Now the TR20 is fairly early, still transistorized, but you're talking about a machine that is a little bit expensive of the era. This is one of the amplifiers that's in there. It is a dual amplifier. That is, there's one complete amplifier to this side, separating right down the center of the PC board, and one down on the other side. The only commonality to these is a double pole, double throw relay that is vibrating at 60 cycles with the filament voltage on. There go the twisted pair that's in that. The actual relay is not in there, it's been taken out. That is the chopper stabilized so that you would get accurate, stable voltages that wouldn't drift. All this stuff would drift back in it. This design probably about 1930. The bandwidth is probably around 700 kilohertz. So a lot of technology coming out. All right, coming over here, we have UNIVAC 1219. UNIVAC 1219 is a ship targeting computer. We're talking from here all the way down to here where the teletype is. Again,
we actually have about 30 linear feet of this machine in our warehouse.
Yes.
This is just the smallest amount that works.
This is the smallest amount that would be put on. The way this was on, it was a board ship. radar would send a signal out to say we have accessed an enemy target. We want to know what the targeting solution is in order for the computer to come out to the I/O cabinet and talk to the servos in the turret of the gun, to point the gun where it's going to go. And then your fire and control officer would then be able to press the button. Let me show you, again, no ICs in any of this stuff. They're all discretes. Hold on, a little bit of the camera down in there. Hold on 1 second, I'll get the flashlight so you can see. I don't know whether you can see back down in there, but there are all these little racks. I pull this out, but it's a little bit of a pain to get out there. But these are individual card files that are in the back there, and they hold these small little cards. No integrated circuits. There's still diodes and transistors, germanium, that are put into there. Very expensive machine, about 1,700 pounds are each one of those racks unloaded. Again, this was put up on a bulkhead. This machine had to keep on rolling, including the tape drives. Once you shot a gun and the ship rolled, this was functioning. Paper tape read. And the teletype, again, we have another teletype. Come on out. In the museum, when you get in here and come and visit, there is the movie that goes along with it. We're right at the beginning, so you can actually see where we have video log this computer actually running. Our two engineers that work on this have actually photographed that actually running. So you can actually see this specific computer doing its thing, which is kind of neat. Normally we have this running, but due to that machine being a 400 cycle unit, being on your aircraft or aboard ship, 400 cycle is the power mains of the day, 3-phase. We had to buy a special 60 cycle 3-phase motor to 400 cycle generator that would actually fire this off to run.
And I appreciate it because I would have probably tripped over it with the camera, Nate. So
Right.
I appreciate you getting run it today.
Yes, but you can, if you keep on videoing it, it runs pretty much right in where you can actually see the teletype. Its hood has been lifted and you see the actual mesmerizing mechanics of this thing actually operating. Quite neat. And here we have Big Blue, IBM 1130. This machine would hopefully be restored someday, but it does have a lot of its own issues here. Again, system administrator would actually be the one sitting in front of the key punch. We're talking about programming cards that would have punch holes into them. And a lot of guys that come into our museum, the older gents, they remember doing this. You would have a program as an engineer working on it and sit down with the system administrator and say, I need you to key punch in that program so it'll run on the PC.
Speaking of tripping while you're walking.
Yeah, right, yeah. So from that standpoint, you walked away and the systems administrator would run your program. If it hung for any particular reason, you would then be asked to go back and find out what went wrong with it. And by the way, we can't run your program for another probably week and a half, something of that nature. Come back then. So yeah, we are quite fortunate nowadays with personal computer that we have a lot of the blessings that you don't have to deal with a lot of that. Digital Equipment Corporation comes in and says you guys are too expensive. We can design something a lot more compact and a mini computer. Again, you're dealing with still discrete. I'll get it out. Components. I don't know whether these are silicon or germanium. Our expert, David Guesswine, is the one that can tell us a little bit more on the PDP, since he's our guru on this particular system. Over here, another one of my babies that I was unfortunately volunteered into is the Wang 4000. Wang calculator came into being and was very successful in the calculator business. But a couple of the engineers working on the 4000 project convinced Dr. Wang that he should get involved in computers. It's going to be the name of the day. He was reluctant on it, as the story goes, to get into it, but they finally did, so long as the engineer that was going to work on this was going to take it. There are two flavors of the 4000. One that looks what they call a monolith, which looks something like the sloped cabinet on the Univac 1130, and the rack mount. This is a very rare instrument. It was given to us, donated to us by a extruded tube manufacturer up in North Jersey that was using this to calculate quench times and different alloys to be put into the metal tubing that they were making for hydraulic lines, for aircraft, that sort of thing. And all the calculations were done on this computer in order to do that. We actually have a portion of this running. I don't know if we can zoom in for it or not, but we can do some basic adding, but the thing gets really confused. So if I do 6 plus 6, the 12 goes on. Let me clear that. Let me try another one. Plus, I still got numbers here. We have a couple of blank displays. This is the one that I actually got. 6 plus. There we go, 13. So we'll do some stuff. The arithmetic unit, if you want to come in, again, no discrete type of components. These are all germanium transistors along the backplane. The unique thing about the Wang 4000 is instead of it being a wire-wrapped backplane like the PDPA is, this is what's called turning point. It's a unique termination system on the back made by AMP in Harrisburg, which is now Tyco Electronics. Very unique of its day. I'm going to pull this open because this is really pretty. This is the core memory. We talked about memory earlier on it. This is under glass, which is nice. So we have completed the documentation of this system by taking all the cards apart and actually photographing them in situ in the card file. Because again, you can take any one of these cards and plug it in the wrong slot. So we have to know of the card model numbers where they actually go inside the unit. But the construction is a work of art. Very heavy-duty rack mount type of stuff in drawers. Just a pleasure to behold. One last thing on this unit with the display. Cold cathode Nixie tubes. As you've seen on some of the other machines of the day that we have, this is not LED, it's not LCD, this is actually cold cathode Nixie tube vacuum tubes that have been put into the unit with the driver electronics on board. And then this would actually get plugged back into the card file with the rest of the control. One last thing I forgot here. Yeah, talking about core memory. I'm going to shine a light. I don't know if you can get in there, core or not. I'll try to get in there. There's a little plastic square that's underneath. So we have mini core on this arithmetic unit for what's going on to be able to store it. So there was local core here before it got up into the main memory of the machine.
Well, thanks, Phil. I'm going to.
You want to do the HP?
I think we're going to, just because we have so many machines here now, we're not going to get to show you guys everything. Really, if you can come down, please come down and kind of view what we have at the museum. We are going to go through some of our PC aisle and our home computers aisle right now, but and really, when you come down, we can spend as much time as you'd like just looking at all the different machines. So where I'd like to start, and we'll go through this at a little bit more rapid pace because there is a lot of individual machines. As the machines got smaller, obviously we have more of them in the museum. We have tons more stuff in our warehouse. But one of the things that we spent a lot of time and are very proud of is we built a 1980s bedroom. A typical bedroom that someone would have in the 1980s, a kid or something, everything from having DVD books, but really, and movie posters, but really the idea is to show kind of what it would look like, for a typical kid to have, when they're working on their computer. And we do print shop here, so if you want to come in and you have kids and you want to, have them print out a sign, we're very happy to. I think this telephone is even actually one of our members. I think it's Tony Bogan's actual phone from when he was a kid at that particular time. So it's kind of neat to see kind of, we'll say, in its own environment, what things would look like. We've also gone out and created a display to show you what a typical office would look like. We've created a cube environment here. I know the bane of all existence, the cube, and show sort of how a business computer would be. Now, in this case, I know a lot of you are probably thinking, why don't you show an IBM PC? But the reality is that we do have a separate display for that. We wanted to show really, something different. So more like the kind of the engineer's desk or something. So we've got a hybrid Dell machine here, and I say hybrid because it could run DEC machine. It could run some DEC software, some of the the PDP software. I'm being told that we don't have any video for the moment, so just give me 1 second to see what's going on here. So, experiencing a little bit of technical difficulty. Just be a second.
Andy's not here to switch over, so say get on there and say something.
Hey Corey, you're muted. You're muted and there's no video. Andy! Oh God.
Don't do that.
There, we're okay. Corey.
Where's Chris?
Hello, everyone. Welcome back to Vintage Computer Festival East 2020. Unfortunately, our video and our audio of the museum cut out. Hopefully, Corey can come back and give a little bit more tour of the museum. What we're going to do now, Andy, do you think, are you ready for that next video? Or
yes.
Okay, so let me talk about that a little bit first. So,
Corey's back.
Yeah. So,
Corey, can you hear us okay over there?
So, are we good? So let's just give me a second. I just want to verify we're good here. And I don't know. It's totally cut out on the machine here. So talking about our 80s bedroom machine. Yes. Are we good? I'm going to assume that we're good. So this is our I'm going to start again. This is our 1980s bedroom exhibit. We've got want to come in with your kids and you want to maybe do some signs. We are very happy to help print them out for you. This is really what it typically would have looked like in someone's bedroom in the 1980s. As a matter of fact, the telephone, I think I mentioned it earlier. I don't know if that audio came through, but that is actually the telephone belonged to one of our members, Tony Bogan. Over here, we've recreated the dreaded cube from the late 1980s, actually probably mid 1980s. Here we have a DEC machine or Digital Equipment Corporation machine. This is a hybrid machine. It could run MS-DOS software as well as run DEC software. That was kind of some of their back software. So I'm going to keep moving along because I want to speed things up a little bit. Here you can see the IBM PC Junior we had earlier, as well as we have a TI portable computer. But one of the things I really want to introduce people to here is something that they don't generally get to see, is some of the early what we call hobby computers. So these hobby computers are things like we've got a home-built DEC computer. So someone went out and actually built their own DEC-compatible computer, and instead of having all the individual switches in the front, so this would be compatible with that PDP-8, they actually made a numeric display, and this was all donated to us, and it's a home brew machine. Another example of a hobby machine is this Selby 8H. Functional. And the Selby was really the first advertised personal computer because they advertised it in a magazine, saying, do you want to buy it? And they really didn't sell a lot of them, about 50 of them. But it is a really good example of what we call an 8008 computer, which is really what the first microprocessor that could really do anything. And it's a really interesting machine. And if you really want to learn more about it, Mike Legal's website has a whole lot of information about it. And it's really kind of a neat machine. Next to it is not actually a computer, but a terminal. So we talk about getting onto the internet using a browser. Well, back in the early days of the ARPANET and even some of the university networks, people built their own terminals to get onto the ARPANET. And this particular one is a TV typewriter. It's in a cardboard case, and there's a television. And you would use this terminal to get onto what was the internet of the day. And I'm going to go a little faster here, but we've got an Altair computer. I actually stopped it in the middle, but kind of froze the terminal because it is a very loud machine when it's running. But this is, kind of the monitor program that allows you to enter data into the Altair. This particular Altair has a ROM in it so that we can start the machine up for our docents. But if you had a really early Altair and you have a ROM card, it could take you a half hour to an hour just to what's called toggle in using these switches in Octal, a program to just start the machine. If you've seen the movie War Games, you might recognize the inside. That was the computer used in War Games. It was a clone, really the first clone computer of the Altair, but it was actually better quality. They used higher quality components and made it a much more reliable machine. Where the Altair was built using a lot of radio electronic components, the inside was that would have been used in business machines or mainframes. So the switches, everything else. And it's built really like it's we can move over and see another machine of the day. Here we start getting out of the hobby and more into the personal computers, but the Sol personal computer, Sol 20, was really one of the first personal computers that you could buy assembled and actually use it without having to spend a ton of money to buy things like a terminal and cassette draw interface and all the other things. It was all built in, and then all you simply provided was a monitor or a television with a modulator. SWTP was a company that made kits. They were like Heathkit. They made like stereos and other things. They also made a computer and a terminal kit. This CT64 is actually the TV typewriter that I showed you earlier, but in a production system where they actually decided to produce them for general consumption because people were buying computers that needed terminals and they didn't want to go out and build them. I'm just going to swing around here just a little bit to show you some of the things in here. We're not going to spend too much time on them, but you might notice that we've got some foreign computers here. We've got a Japanese computer here as well as we also have I believe this is a Bulgarian Apple II system. So it actually can switch back and forth between English and I guess Bulgarian. So we also have some other things like we have some British machines here. For example, some of you in the United States may recognize the Sinclair 1000, but it really started out with the Sinclair ZX80, which was a kit that was available in the United Kingdom. And these are quite rare and quite valuable in working condition, these white ZX80s. And we have one working, and it's really nice to see. Another thing that people had were these sort of semi-computers. And I know some people will complain and say that, a KIM 1 is a real computer. It is a real computer, but it's not, as complete as many of the other machines were at the time. You had to add a lot to it. And some people consider them microprocessor trainers, but the reality is with a few things, they could be a computer. I'm going to keep moving right along. We've got everything from Commodore 128s. We have an Apple I replica here. It's not a real one. If it was a real one, we would probably lock it up. It would be worth a fortune. I should mention some of these machines you see here might look familiar. And I mean, when I say, like, for example, our Altair, you may say, hey, I've seen one just like that in some movies. Some of these machines have actually been loaned or rented out to the movie industry. So, for example, this is the last configuration of this Apple I replica that was used in a movie. We decided we liked it so much we haven't kind of changed it from the configuration set up for a movie. We've got our Apple II, and you can get in here, and we've got a clear cover on it, so you can get in and really look at the insides. This is an early Apple II. It's kind of neat. I should mention, someone's going to say it. Where's the raised key? Why are you missing a key? We've removed that because of the COVID restrictions. All the machines here are cleaned with alcohol, and we know that that key actually has an issue with alcohol, so it's been removed. So the naysayer is asking me, where's your key? Oh, there. Got an IBM PC. This really is the first IBM personal computer that I guess was reasonable. IBM did have a personal computer in the 1970s, the 5100, but it was a giant cabinet, about a file cabinet type of thing. And once you had the disk drive and the main unit, the IBM PC here, a few years later, most of the same development team worked on it, is a much smaller, more compact, and more practical desktop personal computer. Probably the computer here that I believe changed most people's lives the most that we've talked about so far is actually this little Tandy portable computer. And the reason why it changed everyone's life, without them actually knowing it at all, is this particular machine was used by journalists around the world. It allowed journalists, when it came out, to write up their articles and submit them directly in the field to their editors and get them out into the newspapers and to the news agencies. That really brought near real-time news to the world. Before that, your news was stale or old. So that has really changed things. Think about how much we do today that involves the fact that we have near real-time or real-time news. You can really bring it back to this one particular Tandy machine. It ran, many, many, many hours on a single set of batteries and could connect right to a telephone, and they could send their news stories in. You guys already saw the Alto, so I'm not going to talk a little bit about that. I'm just going to kind of turn around and show you a couple of machines. Here we've got things like our TRS-80 Model 1. It's one of the Holy Trinity from 1977, the first real consumer-oriented personal computers. We've got an Osborne computer. Now, I do want to mention something about the Osborne, and for size, I'm going to come into the shot here a little bit. So this is the Osborne. This is really the first kind of portable computer from design. It's called a luggable, but really the thing that gets me the most about this machine, if you can see how large it is. Now, I'm not a small person, but it's a fairly large machine. When this came out in the early 1980s, this would fit under the seat of a coach class airline seat. You could fold it up and put it underneath. Today, this won't fit underneath in a first class airline. So it just shows you how times have changed a bit. Coming over here, we have Commodore PETs. We've got, there's EK, our chicken. I guess he came in to hang out and see what's going on. We've got our Zorba portable computer. Love the name of that. And we've got everything from Commodore VIC-20s and a whole bunch of others. I'm just going to really just show a couple of other machines here just quickly for you, and then I'm going to turn it over to the guys. I think we're almost out of time. So obviously we have our own Apple Lisa, as well as we have the Apple III system. And all of these systems are running and available for you to try. We just ask that you work with our docents because of our COVID restrictions. We do clean the machines afterwards, or may ask you to wear gloves when you use them. We've got the Unix PC from AT&T. Remember, we are located in New Jersey, so AT&T and Unix Bell Labs is really part of our heart here. Tandy Coco, and really a machine that really changed the world a lot as well is the Next machine. This machine is where the first web browser was designed, and a lot of the Next operating system is is your current Mac OS. So one of the things that Steve Jobs brought back to Apple when he came back as part of the acquisition was really to get the next operating system, which became OS X. So I think without really, we've got a ton more stuff to show, but I really want to turn this over to the guys in the studio. So thank you. And really, if you want, come down. We are, happy to really show you around, spend as much time as you need. And really, don't be a stranger. And if you can join our email group and go to vcfed.org so that you can find out more information about what we do. We are a 501c3 charity, so really anything you can do to help us out, we're very happy about that. Thank you.
Okay. Okay, go back to you.
All right, welcome back to VCF East 2020. That was Corey Cohen, and he was showing off our Vintage Computer Federation Museum. If you want a tour of the museum, a more extensive tour, he just gave a quick tour there. You can come in. We're open Saturday, Sunday, and Wednesday, 1 to 5 p.m. We're in Wall Township at the InfoAge Science and History Museums. So we got a sort of highlight of a lot of those machines. We try to get as many of those machines working as possible. And it's gone through a lot of changes since January. We redesigned a lot of parts of it. So if you haven't been to the museum for a while, as you can see, there's a lot of changes and a lot of improvements. So it's a lot more fun. And so next thing we have up is unscheduled, but it's a quick 5-minute video. We're going to add it in real time because unfortunately OBS doesn't allow us to just insert it into our schedule. So you're going to see us actually physically going in and running this video. So this video is from the Team 6502 website, so team6502.org. It was made by Jennifer Holt Winograd, and she is the daughter of Terry Holt. He is one of the designers of the 6502. So it's really cool video, and I encourage you to go to that website to get more information about the 6502. Because the theme, the ultimate theme of our show this year was the 6502, to honor Chuck Peddle and the designers of this famous and wonderful microprocessor. So when you're ready, Andy, we're going to run this short 5-minute video. Just give us 1 second. After that video is going to be Harry Balcom video. So Jennifer had put together this because she had gathered a number of. She was her father. She gathered a lot of his documents when he was working at MOS and working on this microchip. And she's gathered some from other designers and workers. So there's a lot of documentation she wanted to dedicate to her father and all the people that worked on this microchip to have this great historical archive in one place.
It's not showing it. You playing it on your computer? No. I'll play it and share it. I can't.
At the beginning of the 21st century, computers have placed the sum of the world's knowledge into the palms of our hands. Today, any
Let me know, Bob.
Yeah, you're on.
All right, sorry about that. Little technical difficulties. We're trying to insert that video in there. So we're going to switch to Harry Balcom. Harry Balcom was one of the layout designers of the 6502 chip, made at MOS Technology. So Harry Balcom's video, and we're ready to go. Oh. Hello, my name is Jeffrey Brace, and I am the showrunner of Vintage Computer Festival East. The following interview was done by Brian Stewart on September 16th, 2020. He is interviewing Harry Balcom, who is one of the layout designers of the 6502 microchip made by MOS Technology.
I have a little bit of vague connection to Harding myself. For a while, I taught at Rhodes College in Memphis, and I was in the math department there. And our math department and Harding and one other school, I think, had kind of a little consortium together.
So you understand Harding then?
Yeah, a little bit at least. I never actually ended up getting a chance to visit the campus, but I know a little bit about the school. How long were you there?
I was just there to freshman, sophomore years, and it was a pre-engineering course, or what I was at. But I have 120 semester hours of college. I do not have a degree. I transferred to New Mexico State University after the first 2 years. But out of that 120 hours, 20 of them would be religion out of Harding. So it didn't apply to engineering degree.
Right.
Then
so
I
then,
transferred to New
did
Mexico State.
Motorola then did Motorola recruit you directly then while you were still a student at New Mexico State?
Hello, my name is Jeffrey Brace, and I am the showrunner of Vintage Computer Festival East. The following interview was done by Brian Stewart on September 16th, 2020. He is interviewing Harry Balcom, who is one of the layout designers of the 6502 microchip made by MOS Technology.
I have a little bit of vague connection to Harding myself. For a while, I taught at Rhodes College in Memphis, and I was in the math department there. And our math department and Harding and one other school, I think, had kind of a little consortium together.
So you understand Harding then?
Yeah, a little bit at least. I never actually ended up getting a chance to visit the campus, but I know a little bit about the school. How long were you there?
I was just there to freshman, sophomore years, and it was a pre-engineering course. or what I was at. But I have a 120 semester hours of college. I do not have a degree. I transferred to New Mexico State University after the first 2 years. But and out of that 120 hours, 20 of them would be religion out of Harding. So it didn't apply to engineering degree.
Right.
Then
So
I
then,
transferred to
so
New
did
Mexico State.
Motorola then did Motorola recruit you directly then while you were still a student at New Mexico State?
I don't know what. No, I didn't. I was due to the Vietnam War and the draft and whatever. I dropped out of New Mexico State my senior year, and I took an interim job in northern New Mexico, and I promised them I'd stay there a year. And then after that year, I needed to finish my degree, so I chose either to go back to New Mexico State or any other large town. I think I had looked at Denver and Phoenix to get a job. And so when I went to Phoenix, a friend's relative was an employee at Motorola there. And to make a long story short, he hired me there. And no, I was not recruited by Motorola from college.
Ah, I see. And so then, when was that? When did you start at Motorola?
That would be 1969.
Okay. So that was a few years before the 6800 work and
Yes,
the
I was
migration.
Yes, I was I hired into a bipolar, I guess it was a T²L type of semiconductor design. But shortly before I was there, the semiconductor wafers were 1/2 inch in diameter, and then they went to 1 inch. And I think at the beginning of my deal there, they had finally got up to a 3-inch diameter semiconductor wafer. So it's at the very beginning of Motorola's semiconductor research.
Yeah, that's it's really kind of wild to think about just the idea of the wafers getting so much bigger over time. It's been pretty amazing, and of course the feature size is getting so much smaller. It's mind blowing. So
yes, I had no idea
were you
what was coming.
then starting out doing? Yeah.
I just happened to fall into layout. I could do it.
So when you started at Motorola, was that in then IC layout?
Yes, it was.
So back in those days when you all were doing layout, now I've never done chip layout, though I did take a course in grad school that we spent a lot of time drawing out the little pictures on graph paper with the different colored highlighters, getting so much. So you were putting together these masks. Was that done with just kind of black tape?
No.
Yeah.
No, the drawings were made on what they called stabling. It was a mylar with a grid on it, and it had a rough surface to where the pencils could leave a mark on it, and it was called stabling because dimensionally it was more stable than paper, and so that's why it was used for mylar. Then the drawings were taken to at the time that I was there, the drawings were digitized to cut a rubylith, which was a mylar with a red coating on it, and then depending on whether you wanted it clear or red, the people in the mask shop pulled off the red pieces to make the pattern. So the transistor was drawn on the Stabiline. The Stabiline was taken to another department, the mask shop, and they made the various layers from the markings on the Stabiline. It was all a manual operation.
Interesting. That's it's pretty amazing to imagine doing thousands of transistors that way.
It is, but and then they took the large rubylith things and they put it on a horizontal camera. The camera itself was on a vibration isolation mount, so that passing trains and cars didn't shake the thing. And it was a huge room with that camera was in, and they would take a picture of that rubylith, and that's eventually that got down to making a mask, which was I can't remember exactly what the scale of the final of the mask was. Probably 20 times larger than the die or whatever, something like that. I can't remember all of that. But
well, it has been a while. I know sometimes I have trouble remembering what happened yesterday.
So it was all a manual process. There was the advantage I had was I started in the bipolar situation deal where metal, where the chips were single layer metal. And so because of that, you had to use your head a little bit to try and get circuitry together. You could use some semiconductor structures to tunnel, if you know what I mean, to cross leads with. But certain leads, of course, you couldn't put that resistance in or capacitance. And so because of that, you had to really organize your the original schematic so that you could complete it. Well, as times went on, you had the 6502 was the technology was NMOS, and essentially NMOS had the equivalent of 2.5 layers of interconnect. And so it didn't take quite the organization ability to make that work. But at my and people that were only trained in NMOS didn't have to improve their organization or whatever. And so anyhow, I for whatever reason, toward the end of the Motorola 6800 project, I transferred into it, and I wasn't. I was. The schematics for a bipolar chip were very simple compared to the huge schematics for NMOS. The entire microchip is a pretty large schematic at that time. And so as I went off to the into that department, they didn't think much of the guy that worked with the little small schematics, because they were the geniuses with the schematics that took several pages. And so I was just off to the side there. Chuck Peddle was the a central person on the design of the 6800. There was a more of the management level of it. Of course, he was the architect of how the whole thing went. There was a John Buchanan that was the design leader on it. Anyhow, the Motorola project was over budget, behind, all sorts of problems, and Chuck was keeping track with kind of a PERT chart sort of a thing, trying to with the NMOS chips, you divided them up into areas for each person to work on, and so Chuck had a chart in his office, and one day they were looking at it in their desperate troubles to get the 6800 completed, and they realized that this little guy from the other department had an output of 5 times what the local guys were. And like I say, my peers didn't. There were 7 other people involved in the layout of the 6800, and my peers didn't pay much attention to me, but they were in desperate trouble, and so they. The exact dates at all. It was around Christmas, and Chuck came to me right before the Christmas holidays, and said, "We've got to get this thing done." And he said, not telling anybody else what happened, what was going to happen. He said, if I give you one guy, can you work through these holidays and get this thing done? And so I volunteered to do that. I picked one guy, and starting into the holidays, we worked night and day, and we finished it out. One of the engineers afterward, Rod Orgill, had said that if we hadn't done that, it would have taken another month to finish it. But anyhow, it was an extreme effort, and and the Monday after the holiday was the day that the head of Motorola, which is a pretty big thing. I mean, you're looking at 100,000 employee company plus, and he was to come to town and check on the, and they desperately needed that chip done when he arrived. And so about on the Monday morning, the whole thing was only about 3 or 4 days, as I remember it. But on that morning, about 2 o'clock, we wrapped it up. We had it done. The layout was complete, and at 2 o'clock or whatever, I was done. I went home, and that was probably a major mistake. But anyhow, when all the guys, the other 7 other guys, the entire crew came in on Monday morning, the chip was done. and they were just absolutely dumbfounded. And since I was the guy that nobody respected off in the corner, it was quite a shock. And so that morning, later in the morning, Bob Galvin, who was the president of Motorola, came through the department. And by the time that he had gotten there, they had plots of the entire chip. It was true that some of it was just hand sketched into the plot. The plots were made by a pin plotter called a Zinetics thing, and it was magnetic driven pins. Anyhow, they had enough show and tell for him. It wasn't all legit, and it hadn't been checked, and all that sort of a thing. And so that morning, and when I came in about 2 in the afternoon, after you could have heard a pin drop, you know, but so far as Motorola was concerned, I got no credit for that. I mean, it wasn't mentioned to the president, to the CEO of the company, that I had put that thing together. It wasn't to their advantage to do that. And so it would have been more to my advantage to have stayed the morning.
I can definitely see that.
That relates quite a bit to the 6502, because the next during that time, Chuck was constantly browbeating the management that he wanted a cheaper chip, but so he finally, after the 6800 went into production, it was sold for what, $300 or something like that, which is a lot of money back if you compare it to modern day equivalent. And so he finally talked him into making a smaller, cheaper chip. And so they hired a layout designer from California, as a consultant, to bring him in to, that's right. He wasn't from California. He was working at the Geneva, Switzerland facility. That's what it was. And they were going to, and he had the reputation of being the best of the best. And so they were going to bring him over to Phoenix and to put together this small chip. The management at Geneva would not let him go unless somebody replaced him. So they sent me over to Switzerland. You know, the end result, the proof, by the time it all settled out, I was better than he was, but they didn't know that. And so anyhow, I went to Switzerland for 10 weeks while Chuck and the design team were working on this smaller, cheaper Motorola 6800. They didn't get it finished, and they canceled it. When I got back, it was looking at the layout, it was half done. And so, but it was a nice trip to Switzerland. And
yeah,
so,
I can't complain about getting to see Switzerland.
No, that was kind of a reward for my efforts there, even though I didn't get the credit. It felt good. And so shortly after that department was going to move to Austin, Texas. And I wasn't going to go to Austin, Texas. So I transferred out of that department to another department And the engineer there was the guy that founded Micron, the memory deal in Boise, Idaho. This was before he started it. Anyhow, so I was working with them, and I had planned a 2-week motorcycle trip to Alaska, and so I took off for Alaska. I was in the late spring, summer, June sometime, and when I got back to Motorola, I had a call from Chuck. To everybody else had already gone to Norristown, Pennsylvania, but he wanted to know if I would go, and it wasn't really an argument to me. Sure. I mean, it was a good time to see the East Coast and all that sort of a thing. So I just tied my motorcycle to the back of a Ford Falcon and headed out. I think they sent a check for $3,500 to get my butt up there. Any way I wanted to do it. And I lived out in the desert at Phoenix in a mobile home where you had to haul the water. I had a water tank out there. I did have power. I didn't have phone. And so I just locked up my trailer and my mobile home and headed east. And that was a very fortuitous thing, because all of the memorabilia or whatever you want to call it that you pick up from work, I was in my mobile home out in the desert there, and I did not load it into the car. I didn't take it. I didn't have much, but anyhow, various layout drawings and things like that, things you accumulate when you work, was there at home. So I had no problem, and so I headed out to Norristown, Pennsylvania, and Chuck had put. You probably know the whole story. I mean, he chose 2 people of every skill. There were 2 layout designers. There were two logic engineers, 2 architects, computer architects. Not that I understand what that word means, but a little bit I do. And then there were 2 managers, Chuck Peddle, Terry Holt. Terry Holt was to be the product engineer. And so we got there and got to work. And Rod Orgill, Will Mathis was the architect. I guess he and Chuck worked together to design the functions of the 6502. Rod Orgill took the I don't know what the output is of a computer architect, but he took his output to design the logic for the entire chip. And then I and Mike took the logic diagrams and drew and finished up the chip. Now the key to the whole thing was that it took 7 man-years for Motorola to build to lay out the 6800. It was 7 people for a year, and the 6502 was complete within a year from the people arriving there. And so And when it hit the news after that, Motorola was pretty taken aback. And I don't know, you've seen some of the ads for the 6502, and it was sticking your finger in the face of Motorola, to put it mildly. And so they took it personal, and they sued. And I don't know that Brian can or the Jeffrey can has a copy of the lawsuit, but the first portions of the lawsuit are based on the layout. And the only way we could have possibly completed that in much less time than they had was to have stolen it, taken it with us. And so the speed of completion of the layout was the heart of the main thrust of the lawsuit. Now, there are other engineering things in there that I don't understand, but it was further down in the lawsuit. But there are some things there that I'm not aware of. But it was the speed of the completion of the layout of the chip that made them certain that we had stolen it. And so MOS Technology was pretty much a primitive company. And so when the lawsuit arrived, we opened up the package, and there was this beautiful 8x10 picture of the 6502. And we just cheered because we didn't have any way to make such a beautiful picture. And my initials and Mike's were on the chip. And so anyhow, we were in, I didn't realize it at the time, but we was in some personal risk there. I mean, the lawyers hired by the company, they were defending the company. They weren't, if they weren't going to defend me. So anyhow, so we, Motorola hired their Philadelphia lawyer, which is, you know, it's kind of a phrase really, but, and we hired our Philadelphia lawyer, and we went and we were told to bring in everything that we had from Motorola. And so we did that, and engineers more than me, I guess, they had all sorts of technical books and design notebooks and that sort of a thing. And so they had we all brought it into a certain into a room there, and behind our name we were to put all the stuff. Well, there were stacks of books and technical things 2 or 3 feet high and behind some of the other people's names. And I didn't realize it till years later, but anyhow, Mike, the other layout guy, was the greatest violator. And as Chuck said to me years later, he said, that guy cost me $1 million. It was just too expensive to defend all of all the stuff that he had. And he said, if it had happened today, courts and juries and things like that would be more technically oriented, and they could have defended it. But back then, they had to give up. So
that was the suit that ended
a little
up
bit, but making them pay a royalty for every chip produced. Now, what happened is that, and I happened to hear the conversation, but the first legal bill came in and it was $400,000. Well, Motorola had its own legal department, and they knew it was a little company. They didn't need to go to court. All they had to do was just keep the legal bills going till the company was done. And so anyhow, everybody had a tall stack of stuff behind their name on this table that they had brought from Motorola. And they got to my name, and there was a little badge there. That's all I had. So I went through the discovery thing into the attorney's office in Philadelphia, and and they wanted to he wanted to know how come I had that badge. What he was trying to prove is that I had gone back to Phoenix, gone into Motorola, picked up some stuff and whatever. Anyhow, it was kind of a ridiculous thing. I told him, no, I had trouble keeping track of badges, and they weren't very restrictive to them. So you lose one, you get a duplicate, and your other one comes back in the mail or falls out of the laundry, or you find it in the car seat, you know. And so I turned the badge in when I left, you know, but there were several others that were just hanging around so that when I get up in the morning, I could grab one and get my butt to work. And so I still have the badge to this day. It has exhibit number such and such on it. And anyhow, after I told him the story about it falling out of the laundry, that was the end of my interview with the lawyers. But what they were trying to do is they wanted to prove that we had stolen the layout. Well, we didn't. I had my skill, and I had done one. The two tips are similar, and there was certainly a lot of advantage to being the second one going.
Right. So, yeah, you could bring your experience from the first one.
Yes, and it made a big difference. So anyhow, for me, that was the end of the lawsuit. I wasn't privy to what other problems and what other people's interviews were. They didn't talk to me about it, and whatever. And so anyhow, he started selling them at $25 a pop, and we got that full color, which is a big thing in 70, 75, 76, when we had our picture on the front page of Electronic Engineering News and Times. And so anyhow, things progressed, but the work environment wasn't. Mike was a very manipulative person, and Bill was very susceptible to manipulation, and so the political world for me wasn't doing too well, and so I had to get out of there. And an engineer I used to work with had transferred to DEC. DEC was a big company at the time. And he's looking through the mic. DEC is trying to do the same thing. They're trying to make a microprocessor chip. And so he's looking through the microscope to the chip, and he sees the initials down there. And he says, man, I know the dude. Make a long story short, I got a call from DEC. And I needed to get out of MOS technology. The job was done. And so I don't know, at the time, anybody that I knew that messed with computers played Pong. And I saw no future in Pong. And so I guess I would have been better off to have hitched my wagon to these geniuses that I had been working with. But anyhow, I didn't see it that way. So I moved to DEC. DEC was really messed up. I can remember one time that they couldn't get a chipset together to make their PC. I can remember the fab telling the engineering guys, I can't take any more chip designs. We're too busy trying to make the ones we have work with match-ins and corrections and all that sort of thing. Mm-hmm. And it looked like a futile effort to me. And it was just, Chuck deserves a lot of credit for putting together an engineering team that could do what it did as quickly as it did it, and then make it work first time. Mm-hmm. You know, making it work first time, everybody gets credit for that. Everybody that was on the team, because there's no DRC programs, there's no logic checking programs. Mm-hmm. It's all coloring plots and using coloring to guide your mind and eye for checking. And so at the time, I sent a letter to a manager I had worked for at Motorola, and I told him that I didn't. DEC didn't look like it was going to make it to me, and I wrote him, says, keep me in mind, because in 6 months or in a year or so, I'd like to come back. And I got a phone call a few days later after I mailed the letter that said, come back now. And so it was very embarrassing to me to quit DEC after eight months. But it just wasn't going to go. And of course, right after that, after I left, I don't know what all happened to DEC, but it folded into something, was sold or something. Anyhow, it went from the top of the line in computer design to nothing. So it was very fortunate for me to do that. But and some people ask, very surprised that I was the only one of the 8 to return to Motorola. And after the lawsuit, and the lawsuit based on the layout, how did that happen? Well, I knew that if this manager would hire me, it would be my only chance to come back to Motorola. And the half-life of a manager at Motorola was, measured months, really. I mean, they come and they go. And so if I had property, I had a place to live in Phoenix, and I was tired of freezing my butt off in Boston. And so as bad as I don't know, what do you call it, unethical or whatever, I was really embarrassed to quit after 8 months. But I did. And while that 8 months that I was there, I bought a little airplane. I bought a Cessna 150. And so the day after I got my license, I had bought the airplane without knowing how to fly. Will Mathis and Will had about 300 hours, and so the deal was that he and I would fly to Arkansas, and I would get him an airplane ticket to fly back, and then I would fly the plane on to Arizona. My parents at the time had retired and were living in Searcy. My father had a long tie-in with Harding College, which is now Harding University or whatever. But anyhow, so Will helped me fly it to. It's just kind of a tough trip. I just felt better if to take Will, who's more experienced with me. So I flew back to Phoenix, and I worked in a digital department there. The manager that hired me didn't care about politics. And within 6 months, he had got busted, and there was a long story behind that, but it's not relevant. And so, but through all the ups and downs of the semiconductor industry, I retained my employment all the way to age 65. I had no peers that survived in their job to 65. Almost everybody was cut. How do you call it? Early retirement. I mean, Motorola was on the downhill run. It's kind of a common thing for the electrical engineers to be furloughed early, whatever. But one of the questions that was asked was, how come they hired me back? And the basic reason is that I was very good at my job of layout. Now, layout's not a job anymore. Computers do it. But I was typically faster, more accurate, and my chips tended to have a good yield. It's kind of like an artist, you know. You can't put your finger on exactly why, but Michelangelo's pretty damn good. And so I was very good at my job, even though that job doesn't exist anymore. And that's why they hired me back. And I did good work for them for quite a few years. And when the layout function faded away, I got into the interface between the chip design and the mask shop sort of a thing. And I was good enough at it to stay employed. But looking back on it, it's almost a miracle. So, and I had no clue of the big picture. I mean, Chuck Peddle, but I didn't realize what was coming. I mean, you know, what cell phones came on in 95 or whatever, 90, 95. This was 75. I had, and what we did is, you know, everybody I know has a cell phone. You go into a restaurant and there's 4 people sitting there working on their phones, and then I'm talking through an iPad right now. I had no clue, and it would have been nice to have made some money out of it, but and there's one other thing that I called. I wrote Chuck a letter, probably about 15 years ago, and just told him thanks for the experience or whatever. Anyhow, it was a good thing for me.
Welcome back, everybody, to VCF East's 2020 virtual show. That was Harry Balcom. He was a layout designer of the 6502. And we have him on the Google Meet here to answer any questions that you want. So if you have any questions, you could go into the Q&A channel on Discord or ask the question at microphone@vcfed.org. So Chris, do you have any questions for Harry right now?
Yes, we do have an email question, and the question is, I'm going to copy and paste this over here real quick. So the person asks if you could help to understand why the 6502 generates the inverted carry after compare and subtract instructions. It was an absolute novelty for 1975. DEC, Intel, Motorola processors don't invert carry in such cases. Thank you.
And I'm the wrong person to ask that question to, so you'll have to take it to Bill or somebody.
Okay. Well, thanks anyway.
All right. So Harry, can you? So you had sort of told about in your story about when you were at Motorola, and then you went to MOS, and then you went to DEC, and then you went back to Motorola. Is that correct?
Yes, and that was unique. And after the lawsuit and all, it was very surprising that I made it back to Motorola. But the explanation for that is that Motorola is a large company, and people I had worked for before didn't much care about the politics in the microprocessor department, and they just ignored it. And those in the microprocessor department didn't know I was back till I was back. And I did get a kick out of that, walking into their office and saying hello. But the bottom line for why I made it back was that even it's a skill not marketable now, but at the time I was very good at my job. And the people that I had worked for before knew it. And that's why I made it back. And nobody in the company objected. At least I never heard a word about it. I don't know whether there was any undercurrent about it or not. But it was a major lawsuit, and Motorola kept progress on their bulletin boards in the hallways about that lawsuit. So the fact that I made it back is a surprise to all.
Yeah, I'd say that when I was in IT industry, it was actually fairly common for people to leave a company, go to another company, get more experience, then go back to that other company and say, hey, look, I have more experience now, pay me more, and then actually have them hire them because now they're more valuable assets.
That wasn't an objective at all, and it just happened to work out, and I did good work for the new department there. But doing layout in 1975, and nowadays that's like I put in a note. You could be a steam locomotive designer in 1960. There's no market for it. There's no market for the work I did now, then, because layout is mostly done by computer because the chips are so complex.
Yeah.
But at that time, I had a skill, and it was marketable.
We have a question. What were the main challenges of layout for a chip like the 6502? Did sections get retried many times to save space or reduce capacitance? Were mistakes hard to find? And how would you typically find them? And we could take those one at a time if you like.
Yeah, well, the key to it all is nowadays you have software we call DRCs, design rule checking software, and then we did not. nothing like that. And so the only way you could check the schematic or the spacings on your topology was to plot it out, and in large scale. You would tape all the pieces of paper together, and then you would take colored pencils and you would go through the schematic and color each line. And as the colored pencil guided your eye, you would check for spacings and correct circuitry. And the main way you did DRCs was that you colored the plots, and everybody on the project did that together. It didn't matter what your job was, whether you was the architect or the logic designer or the layout person. You grabbed the color pencil and went at it. And the typical thing was that if you went 3 days without finding an error, maybe you could quit. But if you found one, then you had to go again. And so it was very tedious.
That's incredible. The labor involved, the attention to detail that's required. And to something that's going to turn into a basically microscopic chip. Just amazing. I have a question.
You have to consider,
go ahead.
You have to consider that I think somebody counted the transistors in a 6502, and it was 3,510. That's a difference. You couldn't do it today.
Yeah, 3,000 versus over 1 million for some of the larger ones today.
Yes.
Yeah. Again, that's just astounding to me. And I'm not 100% sure what this question means, but the guy who writes, I'm curious, can we expand on someone's note above? I think it maybe was somebody in the chat. Is Harry saying that Bill Mensch is to be given no credit for the development of the 6502?
No, I didn't say that. We all were on the team together.
Okay. Very good.
So, and everybody colored it. Everybody did a lot of things. But as I see it today, Rod Orgel isn't given much credit, and he was the chief logic designer for the 6502. While we were putting
there's
together
a little bit of I'm sorry. There's some conversation going back and forth, just distinguishing layout between design. Maybe.
Well, you've got the architect, you've got the logic designer, and you've got the layout. And Rod Orgel was the one in charge of the logic design. And while the 6502 was going together, Bill was at the other side of the room putting together a chip called the PIA. But Orgel is deceased. And so you can't ask him what he did and what he didn't do. And there's another fellow in there, Ray Hurt, and nobody's ever mentioned him as to what he did. As I remember it, he helped Bill on the PIA circuit. But the whole thing went together as a team, and all the checking and things that were done, there was a teamwork to it. But I do feel that Bill is usurped more of the responsibility for the logic than he deserves. But we were all on the team. We all went together, and the chip did work. But I would like to see Rod Orgel given more credit.
We have another question. Someone would like to know, when was the end of the hand-done lithography?
By date-wise, I don't know. It had to be at the end of 75. I can't remember. The hand-done lithography took 6 months. And I can't remember exactly when the lawsuit date came in, but I think that was probably if that was the third quarter of 75. Let me see, I arrived in October of 74, I guess. And so maybe, anyhow, the lithography took 6 months, and the exact date I can't tell you.
Okay, I'm seeing if we have any more questions in here. I don't see anything else right now, Jeff. Let me check the email.
All right. So while we're having Chris check that, and the theme for our show was originally the 6502, because Chuck Peddle had died in December. So, can you share with us your memories of Chuck?
Of Chuck? I have good memories of Chuck, very pleasant memories of Chuck.
So I think Jeff just got disconnected accidentally. Now I think we lost Jeff. If you could reconnect, that'd be good. Yeah, tell us a little bit about your memories of Chuck.
Well, as we were doing the 6800, Chuck was the one that noticed that I had special skills, and I didn't make any more about it. But he used those skills to my skills to help finish the 6800. And when it came time for, and then Motorola was going to put together a chip like the 6502, only they brought another guy in to do it, and sent me to Switzerland to take his place. And they only got 2/3 of the way through it before Motorola canceled it. And so when I took maybe this summer of 74, I took a motorcycle trip to Alaska. When I came back, I had a call. Chuck was already in Pennsylvania, and he asked me to come over there, and I agreed. And so that's pretty much the end of it. I haven't had, and several years ago, I wrote Chuck a letter, and I thanked him for the experience of that job. I don't know. Must have been 15 years ago. I wrote Chuck. I chased down his address and wrote him a thank you note. So I have very pleasant memories of Chuck.
Sorry about that. I was on mute. Yeah, sorry, I was on mute. The question similar to the one about when the manual work was done. So when did the industry stop doing Rubylith and manual work? And when did it all go to automation, I guess, or computer design?
Oh, me, I can't. Somewhere around 1980 would be my guess.
Oh, wow. Okay.
Because they were still Rubylith in 75.
Okay, yeah, that's back there. So someone has a curiosity of what you thought the primary customers of the 6502 were going to be back when you were working on it.
Well, it kind of not very complimentary to me, but when computers came in, when the personal computers were, let me back that up. In 1975, anybody that played with a personal computer played Pong, and I saw no purpose in Pong.
Okay. that makes sense. I mean, if that's all they do, what's the point, right?
That's
I mean,
it.
There's a few small points, but some Pong fans would disagree with me. But yes, I definitely see your point. So, what did you think the customers would, what did you have expectations?
I had no clue. You remember, this is before cell phones or whatever. My career may have gone better if I had attached myself to these guys and gathered them on. But I'd rather go ride my motorcycle and fly my airplane. So. and true, in 75, if you wanted a computer, you had to build it. I had some friends that were very interested in building their computers, but when they got done, they played Pong, and it just didn't make any sense to me. You know, Atari came later.
Right.
So I didn't know what the market was.
Okay. So among the teams, so the question here now is, would the layout team collaborate during logic design? E.g., would designers ask, how fast or small would the circuit be versus that one? Or was there a one-way flow of architecture, then into logic?
It was probably one-way flow. Now Chuck was really into the size of the chip. They added function and threw out function, all related to the size of the chip. It was extremely important to him, but it wasn't in my world. Now, I did have a skill to be able to lay out a circuitry in a efficient and small way, we just did it as best we could. But Chuck, at his level, would add or throw away function to get die size, and I can't remember what die size he was trying for. But anyhow, die size was the most important thing, and I guess I didn't know it at the time, but I guess he was at that after that $25 a chip price, whereas Motorola was selling the 6800 for $300.
Okay. And the next question, the person apologizes if it was already mentioned during the video, but what chips did you work on at DEC?
At DEC, well, the guy called it, he called it the Fonz, was what he called it, but it was their personal computer. And was that the one that came after the PDP-11? Or was it the PDP-11? I can't remember.
Okay. The chip was called the Fonz.
The department manager called the microprocessor, the computer they were building with that microprocessor, he called it the Fonz, and it was out of the Happy Days TV show. That's what I remember. Now, you can tell me, was the PDP-11 before that, or was it the PDP-11? I don't know.
Yeah, I'm not sure.
Let's look it up. It says DEC Fonz 11.
Oh, maybe it was from the 11.
PDP-11, I think.
PDP-11, it could have been.
Jeff, yeah, interesting.
Yeah, it looks like 1124.
Oh, Jeff was just looking up. He said he thinks it's the 1124. So
okay.
So next question: did your work? I'm sorry, I have to see how this was written. Did your work aid designers to spot design errors that avoided manufacturing errors? In other words, did your work correct or improve the design?
Well, there were. I don't quite know how to say it. Layout is kind of like an art, and some people that did layout had good yields in their circuits, and others didn't. And it's an intangible thing. In some cases, because if the leads are shorter and the device is more compact, then you had less risk with manufacturing tolerances. So my chips typically yielded better than others. It's just a characteristic I had, and it's like an artist sort of a thing. You can't quantify it.
Wow. Okay. I don't see anything else right now, Jeff.
Okay. Well, we're going to probably wrap this up, Harry. I mean, we had got a lot of questions.
Okay, thank you.
There
Well,
may be one more coming in. So just
all right.
But and I maybe they've mentioned it before. Nobody's been able to come up with a copy of the lawsuit, but the lawsuit was based on the layout, at least the opening paragraphs of it.
Yeah, I've been trying to investigate, trying to get a copy of that lawsuit. I've been trying my contacts at Computer History Museum. Bill Mensch didn't have it, so maybe afterwards, after the show, I'm going to try to investigate further to try to get an actual copy of it, because I know you said that it had some of the actual technical stuff.
Well, it was filed in Philadelphia, and I would guess it would be the third quarter of '75.
Yeah. So I might try to investigate further, try to get people that are a little bit better about researching stuff like that to help me.
But the reason it was the lawsuit, at least the opening paragraph of it, was based on the layout, is that it took Motorola 7 man-years to lay out the 6800. It took us 1 man-year to lay out the 6502.
Yeah, so they're upset, obviously, because they got it done so quickly.
They were upset at being so quickly, and of course, Chuck was constantly poking them. With his advertisements, and so I think he just poked them once too often.
No more other questions, but definitely the people are very thankful that you're taking the time to do this and answering these questions for us. It's really great that you joined us today.
Thank you. It's not the core info on the project, but I was there.
Yeah, I mean, that was an important thing.
To us, being there means a lot. I mean, we have some other guys that we know that we get to share some time with, who have been a part of some point in computer history, and we think it's important, and we like to try to convey that importance, especially to younger kids who don't have a concept of where this stuff came from, the efforts that were involved in getting there, and stuff is taken for granted too much today, and and we want to.
I do appreciate the attention. I will say that. Thank you very much.
Oh, you're welcome. You're very welcome, and thank you.
Bye.
All right, thank you, Harry. Thank you very much. I always appreciate your time and making the video and answering the questions. And as I said, it was all part of honoring Chuck and his creation of 6502. And you provided some good stories from your point of view, because each person in that team has a different point of view and a different role in that team. So just one more question is, so Chuck Peddle, as a person, what kind of person would you describe him as? Because you knew him personally, so people would be like to know what kind of person was he? How did he work? That sort of his personality and work ethic.
He was very pleasant to me. He was driven. He knew what he wanted. And but I'm sure that if you look at it from the big picture, he paid a terrible price. I mean, a big price for what he wanted to do. Like the fellow that wrote the book said, other people look for computers, but Chuck started with sand. I think that was in one of the books, and he did. He knew what he wanted, and he put it together. I don't know his entire career, but I appreciated working with him and for him.
Yeah, so I think you're referring to the book by Brian Bagnell, Commodore on the Edge. Is that the one?
Yes.
Yes.
Yes, and I think it's even on the flyleaf that Chuck started with sand. Nobody else started with sand.
All right. We have another question. One last question before we go.
Yeah, this changed back to a technical question. So did the rapid changes in process back then from PMOS to NMOS and then to depletion mode cause difficulties in layout?
No, I don't think so. Some of the PMOS was more. CMOS was the more difficult. Some of them took more area than others, but in this story, MOS Technology had to bring up the process at the same time we were doing the design. And that's a remarkable accomplishment that when I was at DEC, the order came down. I can remember they said they weren't going to take any more new designs because they had trouble enough making the ones they had work. It was taking all their time, and they put a stop to all new mass sets coming into the process area. So DEC, with its almost unlimited finances, was having more difficulty bringing up a process than MOS Technology is. Somebody gets the credit for that.
Well, thanks again. I want to read a comment that sums it up. Just came through the feed here. Valuable memories for us, collecting and loving vintage technology. So thanks again.
Thank you. Bye.
All right. Thank you. Goodbye, Harry.
Bye.
All right. That was Harry Balcom, one of the layout designers for the 6502 microchip. Next up, we have Bill Mensch. Bill Mensch was a co-design engineer for the 6502. He's part of the Motorola 8 that went from Motorola to MOS Technology. So without further ado, we're going to have Bill Mensch's video. Make it so.
When you first kind of make this transition from Motorola, you've got a lot of motivations, a lot of reasons for wanting to leave Motorola. And when you first kind of make this transition from Motorola, you've got a lot of motivations, a lot of reasons for wanting to leave Motorola and kind of strike out into something new, right?
Right.
And Chuck has kind of, at this point, started to lay some groundwork. Now, I know that at one point you and Chuck talked with people in Motorola. Was that something that Chuck had been really kind of intending to do initially, or was he really kind of always thinking about breaking out to something else?
Well, that's a very interesting question, Brian, and actually something that hasn't really been touched on in other interviews and or articles and things. Chuck coming to Motorola in '73, this is at the end of the 6800 program. It's at basically the end of putting together the system on chips. So there's multiple chips. There's the ACIA, there's a modem chip, there's a PIA, which is the general purpose digital interface. You got the microprocessor itself. So when Chuck came there, he came there because they were looking for somebody to validate, you could say, these systems on chips, multiple chips. And Chuck was a systems engineer that worked on a point of sale terminal. He worked at General Electric Computer in Phoenix. And so he knew the system stuff. And that's why Motorola hired him. They wanted somebody to validate, are we doing the right thing with the 6800 program?
Mm-hmm.
So Chuck came along, and one of the key things is, how do you interface a microprocessing system to the real world? Well, the PIA is part of it. The ACIA is part of it. The modem is part of it. And then you have the microprocessor, the CPU, and you have RAM for data, and you have ROM for program. And so he knew this. He knew what to do here because he was already working with, let's say, small scale integrated circuits, logic elements, to build the control functions for his systems. Because Motorola was one of the first in the integrated circuit world. And so you see that at that point, Chuck is learning what's possible by being real close to semiconductor engineers. So we're celebrating Chuck, and this time about 45 years ago is when we introduced the 6502, 6501, 6502, 6530, two-chip system. All of this came about 45 years ago. But when Chuck shows up in '73, this is a whole new world for him because he wasn't close to semiconductor engineers, but now he saw how this fit together. So if he, knowing a few different instruction sets and could read manuals, he would see, hey, we can do whatever I want to do. And I got a hotshot little young engineer here called Bill, and his ego would say, we're going to be successful because that guy's not going to quit until it's working right. And that's how we fit together. I'm the semiconductor engineer. He's the systems engineer. So my technology enabled Chuck to do what he wanted to do with a small system, like what happened in about 76, 77 timeframe was the PET. But now go back to your question. Did Chuck think he was going to come in there and raid Motorola to build the processor he wanted? And I have a feeling if he didn't really think those thoughts, that it was there someplace. Because when I proposed in 1973 the home computer, Chuck was like, we're not doing that, which tells me that he was thinking of doing that.
Right.
It's like,
it's somewhere it had already gone through his head. Yeah.
Yeah, and so when this upshot young engineer is saying this, he's saying, I don't want you talking about that because that's a good idea, but we just don't know how we're going to do it yet. And so that's what my interpretation of his attempt at intimidating me in December of 1973. And see, the other part of it is that his story tells me that he was talking to others when he'd be on trips. He'd be on marketing trips. If you watch his videos, there's one I really like that I have on my website that is a link to his 21-minute talk at the in Boston, when he was introducing the Victor 9000. But anyhow, coming back to Motorola days, so did he come in thinking he was going to raid Motorola? Well, that's what he ended up doing a year later. But he came to me to put together the team. So when I said, well, we need Rod Orgel, we got to have Rod Orgel. Rod and I worked on the Olivetti chip. We worked on the 6800. He worked on Precisa calculator chip. He knows processors. He knows logic. He's one of the best logicians at Motorola that I've run into. Rod, we need Rod. And we need a couple of layout designers. And I only have one of them that I ever worked with on the PIA. So this green layout designer, I worked with him. But when it got tough in the corner, I did the layout in the corner to make that fit the die size we were looking for. And so I know how to do layout, but I'm not a layout designer, but I know how to work with layout designers. And if it gets tough, I know I can lay out that part of it, but I'm hoping I never have to do that because there's a lot of other things that a semiconductor engineer has to get involved with. So that's the story. So did he come there to raid Motorola? Maybe. He did that. So at the end of the day, he did raid Motorola.
Well, so whether it was on his mind at the beginning or not is not clear, but pretty quickly he realized that was a good idea.
Yeah, and see, Motorola, there was something else that was going on in the background that I didn't know about, but maybe Chuck knew about. As it turns out, the 68,000 team, just like at Intel, they'll have, to turn out a new microprocessor every 2 years, they have at least 2 teams, maybe 3 or 4 teams. And so if it takes 8 years, you might have 4 teams that every 2 years you can introduce a new product. That's what Motorola was doing behind the scenes. They had a 68,000 team built up while we were doing the 6800. Now, I didn't know about this at the time, but if Chuck knew about it, he knew they were going big, not small.
Right.
Now, when they moved to Austin, they went small. The 6805 is a one chip with a subset or whatever of the 6800 instruction. So you know that they were probably thinking of that, But how does Chuck's story fit with what actually happened? I'd say he wanted to strike out on his own. He wanted to raid Motorola. He did that. And I was his lead semiconductor engineer that just loved designing.
So is it likely then that he made the initial contacts with MOS technology on those trips that you were talking about?
I don't think so. When we were getting together with Paul Barossa at Paul Barossa's house on the north side of Camelback Mountain in Stone Canyon, I think is where his home was. When we get together with Paul, he was wanting Paul to be a partner with whatever we did. So Paul was a professor at UCLA before, I think. He had several different business cards. So Paul was the go-to guy, the way Chuck saw it. So he never really talked about MOS technology in any of those meetings, because at some point, Chuck just decides Paul's not going to be able to deliver the next opportunity for us. So we're going to have to figure it out on our own. That's when he started thinking, well, I know this guy, John Pavinen, that I worked with at GE, and somehow he connected up those dots. Wait a minute, John's got a place back in MOS in Pennsylvania, in Valley Forge Corporate Center. And I'm going, hey, I don't care. I don't care where we design. All I want to do is design a chip that we know is going to be better than what we just worked on.
Yeah, transistors are the same whether it's Arizona or Philadelphia, you know.
Exactly. And I'm going home, although that wasn't really that high on my list.
Right. Yeah, just, in fact, I had a similar experience myself where I ended up going back to the area where I grew up at one point, and it was not, that wasn't a motivating factor. It just turned out to be a convenience.
Yeah, just kind of fit together that way. But what's interesting is I don't believe, because I wasn't part of the decision on going to MOS. I was no part of that. And so what happens is, but when we get back there, it's like we just stepped into a pot of gold, or we just stepped into an awesome opportunity. And it was random. In my opinion, it was totally random. And as a calculator company that had a metal gate PMOS process, and we're going to a silicon gate depletion load process, I mean, they're like, okay, they're still an FET, field effect transistor process, but it's a whole new process.
Yeah, very different, yeah. And so when you guys got in there, now I gather that there was a certain sense of, okay, who are these guys coming in here into our turf that was going on there?
Yeah. There were a lot of people unhappy about the decision by John Pavinen, the president. He knew Chuck, and Chuck and he were friends. I remember this. He was a country club kind of a guy. The first time we got together for dinner was at his country club. So it just, the quality of and the camaraderie between Chuck and John Pavinen is that's what fused it. But basically everybody else thought this was a bad idea. Now I'd say that Mort Jaffe, the financial guy, he was just a good guy. I guess financial guys are just good guys. They just want to make money. And hey, if John thinks this is going to work, hey, I'm not going to complain. But if the engineering guy would say, well, what's the deal? I mean, we know how to design processors. I mean, don't you know that there's a processor in a calculator? I mean, Intel would claim 50 years ago that the first microprocessor was really a calculator processor. And you go, dude, Motorola was designing calculator chips before Intel was, working with the Europeans. Intel was working with the Japanese. I mean, all these things fit together in my mind that says John made a decision to go with these cowboys from Motorola, from the West, over his own guys. But that's because Chuck convinced him that because he worked on this point of sale terminal and some of these other small systems, that he knew the instruction set that would be a winner. And because he worked at Motorola, you use that experience to pick an instruction set that is going to be more effective than the previous one. And that's what engineers do.
So essentially, it sounds like what got you guys in there really was Chuck convincing John that you all could do a better product than the group he already had.
Right. And I think probably Chuck says you can't use that PMOS process. You need an NMOS process. So we know NMOS. I can see Chuck saying, we know NMOS, and we're going to go with depletion loads. The other guys aren't using depletion loads. Bill knows how to do that. Bill already had that all figured out at Motorola. Motorola didn't want to do it. We'll do it here. And, you know, we're passionate about making this happen. And, you know, that's Chuck.
You know, I can really see how that could have ruffled the feathers of the engineers who are already there.
Oh, they were all pissed.
Yeah, I can imagine they must have been.
I had 3 flat tires in my first week.
Oh, my.
But, you know, you don't know whether it was going out and looking for a new house that might have had some nails in the...
Yeah. Yeah, it's always hard to say for sure where that came from, but it is suspicious.
Well, it happens. But the other comment that said I may be on the right track is when one of the guys says, you don't want to mess with the Godfather. Is the Godfather here someplace?
Yeah.
He was talking about Don McLaughlin, I think.
Okay.
But it was never revealed who the Godfather was. But then you go, well, we're back here in Philadelphia and things happen in New Jersey and New York, and it's a different Wild West back here.
That's true. That is true. So then you all get there, and so Chuck has essentially at this point laid out a roadmap for where to go. You're diving in enthusiastically working on this, and a lot of it then is not targeted towards specific products, of course. You're thinking we want a chipset basically that other designers are going to pick up and realize that they would rather use this than the 6000 or the 8080.
Right. Right. And it's going to be simpler to work with. And Will Mathis wrote the hardware manual. Chuck wrote the software manual, which made it easy for people to pick up the technology. And simplicity, simple elegance, the 6502 known as simple elegance in a microprocessor. That's why it's popular with the hackers and the makers. And, you know, of course, nowadays you'd use Arduino, Raspberry Pi, but back in the day, the 6502 is what Wozniak was attracted to because he could make things happen.
So you all joined in, moved over to MOS technology in 74, right?
Right.
August
19th, 1974.
August 19th.
The same day we were off the payroll at Motorola, we're on the payroll at MOS. So our travel
that works out well?
Yeah, it worked out great.
Yeah. So then how long was it before you turned silicon on the 6502?
Well, we introduced it a year later, right? So that means we actually had silicon probably in working parts in about the June, July timeframe. And then we had to get the 6530 out too. So then I'm the design engineer of the 6530 chip. Because Chuck You know, the goal of the 6502 was not to be competing with the 8080 or the 6800. I don't know if you knew that.
No. So what was the goal then?
To compete with the 4040. So if you go back and look at the history at Intel, it was a 4-bit processor called the 4040. That's why we're selling it for $5 for the 6502. We're getting $5 more because the chip is the same chip. The 6501 was $20. So we're getting $5 more for the same chip, just have a different metal layer. That's all it was. Same size, everything was the same. Same number of transistors on both of them, except that about 12 of the transistors aren't hooked up on the 6501, but are on the 6502. So the 4040 was a 2-chip system selling for $29. So if you're going to compete with the 4040, you're going to be in the 20s. And that means that we have to figure out how to get this $20 CPU. And if you look at the chip size or the chip set for the Atari 2600 with the 6507 and the 6532, you're looking at something that I don't know what the pricing was for those 2 chips, but I have a feeling they were lower priced than the 4040 chipset. So when we introduce the 6502, we're introducing the chips that were used on the KIM 1, 6502 plus the 2 6530 chips, one for the keyboard or the keypad interface, and one for the teletype interface. So that program, 1 KB of program was needed for the interface, the monitor for the keypad, and separately 1K for the monitor for the teletype. So that's how that worked. So we're not competing with the 6800 because we want more volume. Lower cost, higher volume, more things. So to go to a pet computer that was a whole new market is what was Chuck thinking? Right?
Right. Well, I mean, yeah, you were already going after what amounted to the microcontroller market.
Right.
And, you know, as we know, there's always more controllers out there than there are personal computers.
Order of magnitude, orders of.
Yeah.
Yeah.
Fascinating. Yeah, I guess I never really thought in terms of the 6501 and the 6502 being really kind of directed at different markets. But it kind of makes sense.
Well, yeah, I never related to it just the way you did just now. But yeah, the 6501 was competing with the 6800. 6502 was competing with the 4040.
And you were able to basically take one design and go after 2 different markets with it.
Right.
That's impressive.
Well, back in the day, it was just, if you were there in the day and you saw what we saw it all. Rod and I saw it all. Chuck saw his thing and Will saw his. Will is an awesome applications engineer. That's why he wrote the hardware manual. Will, he was a logician. He knew how to apply chips. So he was a great member of the team. Now, I didn't recruit Will. Chuck recruited Will out of the applications department, that's where I got started at Motorola, out of University of Arizona. But Will was an awesome team member, just awesome. And so the combination of Chuck and Will and Rod, because Rod worked on calculator chips and 6800 and Olivetti chip. And so Rod knew basic microprocessor technology or processing technology, but Rod taught me, he was my mentor in logic design. And so that's how that all fits together. And Mike and Harry as mask designers, and then Sid Holt, she came along from back there. But Mike and Harry was a very good mask designer, and he was fast. And Mike was a very good mask designer, but he was more methodical. So if you wanted something done quickly, give it to Harry. you wanted some done with more accuracy, you give it to Mike. But then Mike was always going back and cleaning up somewhat. Now, if Harry was on this, and when Harry sees this, he's going to Harry and I don't know if there's any love there, but I think I would say love-hate, but it could be mostly hate. Anyhow, but I could go into stories, but Harry is an awesome guy. I love Harry. We got together after he came back west and worked at Motorola. We got together once. He built an airplane. He's got a wonderful story. Harry's got an awesome story to tell. And anyhow, there you go.
Yeah. That's it's interesting, you know, you come in, and so in less than a year, you've not only introduced a new architecture, you've got new processes, and you know, as we talked about, you've got these significant improvements in the way the process is implemented that really substantially improves your yields. And all this happens in less than a year.
Mm-hmm.
And then you hit the market with this. You go to the show and announce this thing. And I love the story that I heard you telling in another setting, where you had these like bowls of the chips.
Oh, they were actually they were big jars.
Okay.
They were like these mason jars, like you might find pickles in at a bar, you know, a big old jar. Those jars were filled, and, you know, at the time, I don't even know if they were all tested, but there was a bunch of chips in the jar. And they were probably tested, but right now Chuck likes telling the story. The ones on the bottom didn't work, but who would know that looking at the jar, right? But anyhow, there's
Did
one
you have like
jar.
a 6501 jar?
Yeah, and 6502 jars.
Okay, excellent. And so when people would come to the hotel and go, okay, I really want one of these right now, were they actually, you know, buying it out of the jar?
Yeah. Well, they thought they all worked, and they probably left. Yeah, my chips always had the higher yield than the next guy's chips, and if they weren't tested, they probably more than half of them worked. But but nowadays, my chips that we have manufactured now, 99% are good. After packaging, and we never probe them. 99% good.
I'm not a process engineer, but I'm impressed by that.
Yeah, I'm impressed because it's the manufacturer, TSMC manufactures them.
Yeah. Wow. That's, yeah, I guess it's a whole different world. So you all then, you know, this thing comes onto the market, and, you know, obviously you're blowing everybody away with this price point.
Well,
and
quite a stir.
Yeah. And now, when was the show? That was later in '75, right?
It was in September. It's like right now.
September. Okay.
Like actually, probably last week, 45 years ago.
All right. So 45 years ago, last week is the show.
Yeah.
You all have been there now just over a year.
Yeah.
And so at this point, I'm guessing, is Chuck thinking about what's going to become the pet at this point?
Well, okay. Of course, I don't know what Chuck is thinking, right?
Okay.
I mean, Chuck, I don't even know if Chuck knows what he was thinking, because Chuck is just, he's awesome. And we're celebrating Chuck. You know, he passed away last December 15th. But so we want to celebrate it. So, you know, anything I say about Chuck has got to be something good. And
of course,
I don't know that I have anything bad to say about him. Chuck is Chuck, and he's unique. He's one of a kind. It's like Steve Jobs was Steve Jobs. Yeah. Some people can say negative things about Steve Jobs, but these characters that got started with the 6502 were just awesome. They're characters, but they were breaking the mold of what came before. So Chuck was that. So when you asked, was he thinking pet when we were introducing the 6502 in 1975? Well, he bolted from MOS the next year when Commodore acquired MOS. And so he's not even on the East Coast in 76, he's on the West Coast. So to me, that's 3 years after we talked about a home computer. So my guess is that from that day forward, even though he's going, we're not going to do that, I think he was going to do that.
Right. And then once the chipset was now available,
yeah,
you could begin putting the pieces together.
Right.
You mentioned that the Commodore takeover then is in 76. So you've got another fairly quick sequence of events that ultimately led to that. So where did all that begin?
I'm missing. What do you mean?
Oh, well, so the involvement with Commodore. So at the very beginning, it's Commodore is coming to you asking about calculator chips, right?
Oh. Yes. And so what happened there is, so I leave MOS, going to start my own company, but didn't know what I was doing. And some people would still say today, Bill doesn't know what he's doing. And there's some accuracy in that. But anyhow, so I'm going to start the company, but Rod doesn't want to work with me anymore. So he wasn't necessarily happy with me and my attitude, and especially after I win the bet. So there could have been some friction there. Ray is there, and he actually fell in love with a woman that was a test engineer there, and he married her, and I was the best man in their wedding. But Ray then, at some point later, after he sends me the tester, Ray is how I got the tester. Ray's back there when he sends me the tester, and they replaced it with a Century 700. And anyhow, so this is part of that story. But what happened then is Terry Holt. Now, there's another part of the story here that isn't really told. And that is, what was the employment agreement that we had as a team? Wild West, I mean, the cowboys coming from the West. What kind of agreement did Chuck put together to get us all to think this was a good idea?
That's a good question.
Yeah. It was a percentage of the profits.
Uh-huh.
We each had our own percentage of the profit. Do you think there was ever any profit? No. There was never any profit. And when someone started relating to that, and I have a feeling Rod and Terry, I don't know about Mike, but maybe Mike, Harry, maybe. I never related to, hey, I like the idea, let's make a lot of money. We got everything's working towards a lot of profit, but then you don't realize that this is a new market, and Chuck was always being bugged by the leadership team at MOS saying, give me what you're going to actually make happen with all these controllers. So Will and Chuck were out there trying to find applications that would generate the volume to replace the calculator business, which is basically now not happening. So that's when it switched from calculators to computers. So what happened there was that Chuck couldn't make the controller business happen fast enough to keep MOS viable. And that's when Jack came along. We're going to build computers and we're going to build this and whatever they decided in the West Coast. But what the surprise was for Chuck is Al Charpentier and these other guys that were working on the VIC-20 and the Commodore 64, they knew how to build low cost, really, relatively speaking, high performance audio and video attached to what basically is the 6502. So when you look at that, Chuck is out on the West Coast without a semiconductor engineer, so to speak. So the East Coast has the VIC-20 and the Commodore 64. They're looking at the consumer market for computers, which is a combination of the Atari game and a keyboard. So the other ones are just joysticks, but now we have a keyboard. So that makes that different, and that makes it fun for somebody that wants to make something new happen. So what Apple, working with their investment bankers, etc., said, we need to come up with an answer for Commodore. And so they called that a consumer computer, and the Apple was a home computer. But then what happened was IBM then says, well, there's more people in a home, so that's a personal computer. So they said personal computers because there's 4 times as many computers. And so the home computer idea is a good idea, but a personal computer is a better idea. And a consumer computer says you're going to sell it at a cost. And so their price point was like, I was a distributor for Apple at one point where I was buying $3,000 Apple IIs as a workstation for my 65 CO2 development team. Anyhow, the 816, I was using Apples, and so I was a distributor of Apples, so I got them for like $2,000 and sold them for $3,000. I think I lost money on that. But anyhow, you see what happens here is Apple says a real computer sells for $2,000, $3,000, and Commodore is selling for $200 to $300, so they can't be in the same market. So they're a consumer computer, and we don't have any interest in that. So that's how they set up the market, and that's how Jobs then is saying, no, we're going to build bigger computers, and that's the Macintosh.
Right. So the time frame on this, when was it that you left MOS Technology?
About March 1977.
Okay. And so that would have been just a few months, I guess, after the acquisition?
Yeah, Commodore acquired MOS in 76, and I'm not sure, maybe the fall of 76.
Okay. So that, yeah, that all, was all happening really fast. You get there in August 75, September 76.
No.
You introduce
August
74.
74.
Right, 74. And then September 75 is the show where the 6502 and 6501 are introduced.
Right.
And sometime about a year later, fall of 76 is when Commodore purchases MOS Technology, and then you're out of there in the spring of 77.
Right.
And this is the point where you had already put together a plan for what would become Western Design Center, right?
Correct.
But where did you go immediately, though?
Okay, so I'm realizing Rod doesn't want to work with me anymore. Will doesn't want to work with me anymore. Chuck's out of there. Mike and Harry are out of there. And you go, well, we kind of disintegrated. And nobody wants to work with me. And I thought that was a good idea that they didn't work with me because I didn't know what I was doing. I was trying to put together, I had a little business plan. I have it down in Arizona. I'm here in Colorado now. But anyhow, I'd show you the business plan. But anyhow, the business plan was about designing integrated circuits and just getting paid for that. There was no starting a company that was going to license microprocessors. I got that idea from Glenn Madeline. And so I'm realizing I don't know what I'm doing. That's probably a good thing. So then I don't know how ICE came up on the radar screen, but integrated circuit engineering, I decide that's where I want to design integrated circuits because they were the first in that business. Integrated circuit engineering started by Glenn Madeline. I gave you a link to that one. By the way, that's the first time I saw that link at the Smithsonian. That is fascinating. You can spend a lot of time looking at that link. And I'm going to put that link on my website. But anyhow, Glenn Madeline is the one, and he's the one that said, well, Bill, we'd like you to put on a seminar called Microprocessors for Management or Industry. And I'm going, wait a minute, you want me to stand in front of a group of people and tell the story about microprocessors so these managers will get it? Okay, that's what you want me to do. Also, because he was a training company. If you drill into that link at the Smithsonian, you'll see it's fascinating information. So that's where I ended up at ICE. And then I said, well, I came here, I want to design integrated circuits. He said, well, actually, if you design an integrated circuit and it doesn't work, then I'm in trouble. I'm going, well, my chips work. Yeah, but that's a risk I don't need to take. But if you stand in front of someone and they pay me, I'm making money. It doesn't have to work. I go, okay. And he says, I actually sell my work product 3 ways. What? Well, someone gives me a contract to create this understanding of the technology. I get paid for that. Then I get paid for putting on these seminars. And then I sell it in book form. This is when we had books. Anyhow, I go, oh, that's interesting. So you sell the same thing 3 different ways. Okay. So then I'm thinking, if I sold a design 10 different ways, like a microprocessor, I could sell it to 10 different people. That would be even better than what Glenn's doing. That ended up being my business model. Well, I've sold the 6502 60 plus different ways. So that was better. And licensing with royalties and all that stuff. So it was a much better model than Glenn's model, but Glenn is who taught me that.
Yep.
All right, welcome back, everybody. Back to VCF East 2020, our virtual show. That was Bill Mensch, co-design engineer for 6502. I hope you guys enjoyed that. That was a 45-minute version, 41-minute version of our video. There's going to be 2 other versions I'm going to put out on YouTube, a 60-minute version, and the full 1 hour and 49-minute version has a lot more stuff on there. So now we're going to take a few questions from the Discord. Chris Fowler is going to bring up some questions. What do we got, Chris?
Yes. So someone would like you to help them understand why the 6502 generates the inverted carry after compare and subtract instructions. It was an absolute novelty in 75. DEC, Intel, Motorola processors didn't invert the carry in such cases.
Are you there? Oh.
I'm sorry. Did you hear me? I'll read it one more time.
You know what? I'm trying to listen to you. I had to shut off the YouTube thing that was going in the background.
That definitely not synchronized at all. Okay, so
Sorry
let's go.
about that.
No problem. So the person asking the question would like you to help him understand why the 6502 generates the inverted carry after compare and subtract instructions, and that he says that it was an absolute novelty in 75 because DEC, Intel, and Motorola processors did not invert the carry in such cases.
Yeah, so I'm not sure about the inverting the carry. Right now, I think what we do is if we get a carry out, we put a 1 in the carry bit. And if we don't get a carry out, then we get a 0 in the carry bit. So I'm not sure what that question's about, because I would think that like rotate right or rotate left, you rotate the top bit or the bottom bit, depending on which way you're going, into the carry bit. So I think it represents what's actually there, not the invert of it.
Okay, I don't know anything about the other processors, so I'm just wondering if maybe it was inverted in those. So okay, yeah, what you're saying makes sense to me. You know, being a 1 would be a carry and 0 wouldn't be a carry. Okay, so during the lifetime of the 65XX architecture, there have been several variations of it implemented in different computers where several external components have been integrated in the silicon to meet the needs of hardware designer. Actually, that's just a comment, not a question, but maybe you could talk about that.
Okay, so let's talk about the 6510, which is probably a favorite there with Commodore 64. Anyhow, that added an I/O port onto the processor, and that I/O port, you guys probably know more about how you would use it. I don't know if you manage memory with that or some of the I/O functions. So apparently, the design engineers at MOS and Commodore CBM thought that adding that port onto the 6502 was a good idea. Now, I don't know if they were doing that to actually make the Commodore 64 unique, which they could have, meaning that they wouldn't sell the 6510 to somebody that was trying to clone the Commodore 64. So I don't know what the thinking was behind the 6510, but I can tell you that right now I have added on these chips, this is the 816, no, this is a CO2 with a lot with memory. It's got a monitor built into it. You can buy these things. You can get them from Amazon or check my WDC65XX.com website and you can find where you can buy these things. But this added, so I added some peripherals onto this. I have 4 timers in this one. I have a serial UART in here. So what you do and what I did was I licensed my microprocessor so that others could do whatever they wanted to it. So I was the first to do that. And the reason why, I was following what Chuck and I knew was the revolution we were creating with the 6502 and the PIA and the ACIA, well, and the VIA and the 6530 chip and the 6532 chip. What we were doing there is actually fulfilling the idea of microcontrollers for embedding systems into things. So when Chuck went off and did the PET, it was like, really? Why are we doing that? So an earlier question someone asked was, well, what were we expecting to use the 6502 in? It was in a whole bunch of control systems. But Chuck went off in a different direction after Jack acquired MOS technology, which was more like a hostile takeover, in my opinion. But the point is the whole idea of the 6502 and then extended it for 16 megabyte address space is for controllers. So that you answered that, I'll show you my latest state of the art. This is where we're going. This is a Wi-Fi Bluetooth radio. This is a GPS. This is a little screen, 64 by 128. That tells me where this is, the longitude, latitude, the time of day, and the date. And then this is an environmental sensor. This is an environmental sensor, and I forget what this other one is. There are thousands of things you can plug into here and write code for. And that has all the peripherals. So that has I2C, SPI, it has 3 UARTs, it has 3 VIAs. Anyhow, it's got a lot of stuff built into it. And you can find this online. We have the data sheet. You can see it.
But
So
at the
you
core,
can-
is that basically the core would be a 6502 processor?
Correct. And
Okay.
it runs at 14 megahertz.
Amazing. I think the question I asked you might have been an extension of this. It was a different paragraph. And I'll just read what it says and we'll see what makes sense here. The writer says, it seems that the 6502 upgrades are more focused on increasing memory addressability, more instructions, and fixing bugs, but the 8-bit data bus is still a fixed feature, at least in the physical offerings. Is WDC interested in releasing by its own will 16-bit data bus versions of the 65XXX processors, or is it a feature already available for customers going with the FPGA way?
The answer to the question, if you've got the time, we got the technology. If you got the time and the money, we got the technology. So actually what I just showed you is a 6502, but actually the memory interface is 32-bit.
Oh.
And we actually have a 64-bit unique ID for encryption. So that actually has 64-bit stuff, 32-bit stuff, and 8-bit stuff. So we can make the bus. And if you know that right now, the ARM core is running at, let's just throw out a number, 2 gigahertz, right?
Mm-hmm.
We think we can go 4 times faster.
4 times, wait a minute, say that again because that's exceptional.
Exactly. Well, the highest speed Intel processors, I think, run now at about 4 to 5 gigahertz. We think we can go 4 times faster what Intel does or ARM does with what we have. Now, you think about what would you do even going at a gigahertz with the 6502, right? What would you do?
Yeah, I can't even imagine.
So
yeah,
I
a lot.
knew,
You can do a
Right.
flight simulator with the Commodore 64,
Yeah.
plug in the
So-
gigahertz, so you can do a real flight simulator.
Well, the other thing that's interesting is here's a book. Here's a book edited by John Hennessy. He was, I don't know if he's still the president of Stanford, okay? And David Patterson, who's at Berkeley. This is the architecture for the most advanced, this is the 5th edition of this architecture book. This has all the tricks of the trade known to mankind to improve the performance of things. So when I was designing the CMOS version of the 6502, Intel was building a 432 chip. And how I knew this is Telenet, packet switching, were using the 6502 for all their packet switching. And they were owned by GTE, one of my licensees. So that's who recommended I have memory lock. Memory lock on the CMOS version was recommended by Telenet, the packet switching company behind the internet to begin with. They were owned by GTE. So I met with them in Virginia, I think. So where I'm coming from is that they were looking at using the Intel 432, which was 4 chips to make a 32-bit processor. And they were thinking that that would outperform a 10 megahertz 6502. They said, we have to go to look ahead instructions. So that architecture book I just showed you is look ahead, parallel, everything's mixed around in there. And that's what was needed to beat a 10 megahertz 6502 for packet switching. Now, when you know this, then you know that fact, if I had the backing of Google, Apple, throw out a couple other companies, if I had their backing, which is unlimited, if I just threw out a number, if I had $1 billion, the 6502 could outperform everything in the market right now. But I'm kind of happy doing what I'm doing. I don't need to compete with ARM or Apple or Intel. I'm enjoying my life. I mean, I've been doing it for 42 plus years.
Well, if I was doing what you're doing, I'd love it too.
Well, I get to talk to you guys because you're curious about the history of it, but at some point, the state of the art is where we're going. So we're still in the business. We're still swinging for the fences.
Well, we're glad you're doing it. We're very happy to do it. As I've said earlier today, and I think everybody that I know in this hobby agrees, we're trying to instill an appreciation of what it took to get where we are today. And kids today that are just handed a piece of technology that have no concept of how it works, how it's made, or anything like that. We just think that's a sad state of affairs, and we're trying to work on that. So we're glad.
I'm totally with you, Chris. I'm aligned with your thinking completely.
Excellent.
And I want to put a plug in for Ben Eater. Ben Eater is doing something really special.
I agree. I've watched Ben's video series. They're outstanding. I mean, even if his content wasn't outstanding and amazing and fabulous, which it is, his presentation style is just engaging and so easy to follow. And he's doing amazing work. So hey, Ben, if you're out there, we appreciate you. Okay.
Exactly.
Back to the question.
Have you seen his interview by the founder of code.org or whatever it's called?
I'm not sure if I caught that one. I'll have to make sure.
There's
a
an
few
interview
on his
by
channel
the
that I have to
founder.
catch up on.
There's two brothers out of Iran that started. Is it code.org? I might be mixing it up, but it's where people. Oh, the Khan Academy. Sorry,
Yeah.
Khan Academy.
Yeah.
And so there's an interview of Ben by the founder of the Khan Academy, and that tells you he's the technology guy behind the Khan Academy. So he knows how to do this, and he created the technology to make it look like he's just magically putting this stuff together. But he fast forwards, right? And so you don't want to wait around for 2 hours until he plugs in all these wires. And so he figured out how to do all that. And and he's got just a gift of teaching.
Yeah, he really does. Yeah. And I'm sure he would be thrilled to know that you even know who he is. So, because I know I would feel the same way. So let's see, we got a few more questions here. Let's get back to that. So the 65XX designs have stood the test of time very well. Did you think at the time, back in the 70s, I guess, that you'd be designing future-proof technology?
Yes.
So you knew that. I mean, you planned, not so much that you planned it, because we can't predict the future, but you weren't doing just something to do it. You were doing it to do it right.
Yeah, that's what Rod and I just, Harry thinks I don't give Rod, or Rod doesn't get enough credit. He should have been there when they were celebrating 10 of the pioneers of the microprocessor world. Chuck and I were two of them, but Rod was invited, but Rod didn't want to go. I don't know why he didn't want to go. Maybe he was fishing or something, but Rod should have been there. Rod is magical, was magical. So now going back to what we knew. Now, how did we know? How did Rod and I know? Rod and I knew factually what we were doing and how we were going to revolutionize the world. How did we know that? The 6501, by the way, just so you know, the 6501 and the 6502 and every other version, the 65XX, all are the same core on the NMOS depletion load process at MOS Technology. They're the same design. So if somebody gives me credit for one of them, like the 6502, and Rod credit for the 6501, which actually was written into his obituary by his wife, Phyllis. He was the designer of the 6501. What? No, we were the design engineers of the 6501, 6502, and all the other variants from MOS Technology. Now, the reason why we knew we were changing the world, because Rod said to me, and I documented this, he thought we were going to go, quote unquote, to the happy hunting ground, which is his way of the indigenous saying heaven. If what we think is going to happen happens. He knew this was the best thing since sliced bread, literally. And how did we know that? We worked on the Olivetti chip. Olivetti was in this weekend. Olivetti was the leading computer company of Italy. I mean, they had great ideas, and Motorola had 2 sets of design engineers before Rod and me. I can still remember Rod coming into my office and saying, well, Bill, we've been assigned to fix the Olivetti chip. Now, you can either leave right now and do something else, or we get this thing to work. That was Rod saying, we need to figure this out. So Rod said, I'll focus on the logic. This is where Harry has it right. He was a great logician. He wanted me to focus on the semiconductor engineering part of it. That's getting the transistor sizing right and everything else that had to work right to make the theory of semiconductor engineering actually match up with the real world. That's my job. That's what I did on the 6502. And that's the part that Harry didn't mention. He didn't know that you go from the instruction set architecture to the flow chart, to the logic drawing, logic design, to the circuit design, which is the way you hook up the transistors, to the layout design. He was missing the circuit design part of it. He just, I don't know what he's thinking about the sizes of the transistors, but that logic drawing back there has every size of every transistor in it. And when I did the design manual for designing the chips at MOS Technology, that design manual had the conversion from an inverter to a 2-input NOR gate, 3-input NOR gate, whatever, 4-input NOR gate, and all these other things had to go into before you lay out the chip, before you do this and this. So all of that has to work. And that's why when I had an interview with Steve Diamond at the Computer History Museum, afterwards, he says, so Bill, when you put the clock generator on the 6502, did you have any problems with it? And I go, well, no. Why would I have problems with that? He says, well, we couldn't get it to work on, and he was a design manager at Synertech. And so anyhow, the point that I'm trying to make here is there's a lot of semiconductor engineering, and engineering is the practical application of the science, technology, and math. That's the E in STEM. So engineering, a semiconductor engineer has to understand the physics of the semiconducting properties of silicon. And so it's all those details that you don't have to teach somebody all those details. So when I taught my wife how to design these integrated circuits, I skipped a lot of definitions of words. Poly is green. Metal, first layer metal is red. And each of the colors for the diffusion is blue. So I just said, we're drawing blue when we, so I had all that. And so my daughter, who put that together, also, this is a hand-drawn layout. I taught some guy when we were cruising around the world how to design an inverter at Martini's, a bar in the middle of the ship. He wanted to know how you do this, so I just got a napkin out and showed him how you design an integrated circuit, but just an inverter.
That's amazing. Let's get another question in here. The person says that I believe you should take a lot of pride in inspiring the ARM processor and business model. And his question is, why did you decline to collaborate with Acorn when they came to visit you in '83?
Okay, well, that's a good question. I love that question. So, Herman Hauser, you can find a video on YouTube or something. Herman Hauser was the money guy behind the BBC and the Beeb. And so he sent Steve Ferber, who wrote this book right here, Steve Ferber wrote that book about system on chip architecture of the ARM. Okay, so Steve is one that visited me, and Sophie Wilson visited me. Now, so Sophie Wilson, I think, works for Broadcom. But anyhow, when they came to visit me, they were the only company ever to ask me about abort, the abort input of the 816. And I'm going, wow, that's interesting. You want to know how abort works or why I even bother putting it on the chip. I don't know if anybody has ever used it, but the original ARM processors had an abort feature. Why did I put abort on there? Because abort, I learned from the Prime 550, which is the system that I had for simulating all of our chips. Prime 550. I don't know if you have one in your museum there, but that was a virtual memory system. So I could build the biggest files known to mankind on a Prime 550 because of one reason. It had a virtual memory architecture. So the abort feature on the 816 is for virtual memory. Well, what do I mean by virtual memory? What I mean by it is that if the real memory isn't there, you stop the instruction without modifying any registers and then repairing the memory map so that you get real memory there. That's why I put abort in there. And that's why they asked me about that. So when they came and visited me, that was in November, December of 1983. That's when I was wrapping up the design of the 816, and they wanted to do a 32-bit chip to leapfrog Apple. But it wasn't compatible. And I've designed several data sheets on 32-bit versions of the O2 and the 816 and the compatibility. There's one online, I think you can find it. Somebody did a 32-bit version of the O2. But when I looked at that, I'm going, wait a minute, this is more than a microprocessor. This is a new company. Because if you're going to build something that can address 4 gigabytes linearly, you got a big software problem. And this is a lot of other things going on. I recognize this, and because they didn't want to use my 816, oh well. So I just said, good luck with that. But they were looking for a semiconductor engineer like Chuck was. So actually, Sophie Wilson is the Chuck of the ARM technology. Sophie Wilson is the Chuck. She defined the architecture of that instruction set, the first versions of the ARM. Steve Ferber, who wrote that book, did the microcoding of Sophie's instruction set. But they didn't know how to make the silicon. So they went to VLSI Technology, one of my licensees, Doug Fairborn, who I don't know if he still is the photographer at the Computer History Museum. He told me when I was visiting there for the interview with Steve Diamond, he said, I actually designed the first version of the ARM for ARM.
Wow. That's a great answer. Thank you very much for that. So next question. Another technical question, and then after that we have a more personal question. So technical question. Was there a debate about the 6502 omitting add and subtract instructions without carry? Was there really, in retrospect, nothing else to remove that would have cost less than 2 cycles and 1 byte? And I sort of know about 10% of what that means.
Okay, so we know this without question. It's in the book, in this book that Chuck contributed to. This book, Rod, Will, and Chuck were the ones picking the instruction set. Okay, so the answer to the question is Chuck wanted to minimize the number of different instructions. That's why microprocessor report was a you could subscribe to it. I have them in my office. They're like archive type of stuff. In there, they said the 6502 was the original RISC processor. And that was because we wanted to have a reduced set of instructions that would be useful for any problem solving, especially for control systems. So the answer to your question is, if we just have add and subtract with carry, then you have to initialize the carry bit before you do it, rather than having an add and subtract that didn't use carry. It was a choice that Rod and Will and Chuck made. And so why did they not use it? Well, Rod's not available. Will's available. Will might be able to help you with why they didn't put that in there. But I didn't, it wasn't part of my, that wasn't in my lane. So this, now the other question that goes with that one, which is I think an interesting thing, because some people think that the chip came out and didn't work and that there was a bug in the ROR instruction, right?
Yeah.
Some people say that, right? That's that's factually incorrect. The ROR was left off, so that was optimized out. So that's an example of saying, so why did we put it in? Well, I think Chuck was talking to some people, or Will was talking to some people that was saying, well, we want ROR. And so then we had to put ROR in. And that, and how you know that is the original programming card that you'd put in your pocket was missing the ROR.
Mm-hmm.
And then it was cut and paste back when you actually cut and paste.
Physically, yeah.
Yeah, and then you got the ROR instruction.
Okay. Commodore wanted Chuck Peddle and presumably others to stay after buying MOS. Why did you and he and others leave? What relationship did the MOS veterans have with the designers of the VIC 1 and 2 chips, SID, TOI, etc.?
Okay, so Al Charpentier, I don't know if he graduated from Penn, but Al was there and he and I talked about what he was doing with the sound interface device, the SID chip. Mm-hmm. And I don't know what he did with the video interface chip, which is called VIC, video interface chip. So those chips, they were defining to optimize or maximize the performance of memory for these small systems. Now, there was a question. So the answer to the question is, we didn't stay. I didn't stay along the lines of what Harry said in the previous Q&A. And what he said, he didn't see the value of Pong. Well, I saw the value of Pong. And in fact, MOS Technology, I think I helped get the Pong chip work on their process. There was something going on there between Atari and MOS that I got involved with in this game world. Well, the game world is application specific for games. If you look at anything I've ever designed, it's general purpose. That means I enable people to do what they want with my technology. This is an enabling board. It isn't the board. And so if you want to learn about it, you can buy some of my boards and learn about it and do what you want to do with it. But my whole idea for licensing my technology, that ARM followed that model, I'm answering the previous question as well, is because what I was doing is saying, there's no way I can design everything that would benefit from a 6502 and then the 816. So that means that, am I willing to give up the family jewels so someone else can do whatever they want to do with it? So I was the first company to give every bit of information to my licensees, all source, and then it was built on a piece of paper called a license agreement. I wrote those license agreement, and I had my license agreement checked by the best law firm in the world at the time, Brown and Bain. A lot of other things I can tell you about that. But basically, what happens is when I see Commodore coming in wanting to design calculators or game systems, and Al is working on trying to get the what shows up on the screen and what you hear, that Commodore VIC-20 and the Commodore 64 are magical. I worked, to say I worked with Al is probably a stretching of it. I talked with Al. He figured out how to do that stuff. They figured out, and Yanis or whoever else was participating on that, long before Bill Hurd shows up in 1983 or Dave Haney show up for the Commodore 128 or whatever. 5 to 6 years before that is when I'm talking to Al and realizing, wait a minute, Commodore acquiring this is not going to work for me because I want general purpose technology, and they were doing application specific for games. Now, yesterday there was a question that came about PCs. So the personal computer was defined by IBM. The home computer, using the definitions yesterday,
right,
was designed by Chuck, the home computer. The consumer computer was designed by Al, Yanis, and whoever else. That was the consumer. And what Apple did to the market is they're selling $3,000 computers, home computers. I was a distributor of Apple computers. I bought 25 of them to be a distributor because I was using them for my development system for people that wanted to develop with my technology. So I had to buy 25 of them for like $3,000 a piece. And Commodores were like $300 a piece if the Commodore 60. So you go, that's a different category of computer. That's what Apple did to the market. That's what Steve Jobs did. So he put Commodore in the consumer computer market.
Right.
They were the home computer market. And IBM said, wait a minute, there's 4 people in the home. I sell 4 times as many computers than somebody that has one home computer. I think the marketing people of IBM saw that. And so that's how that whole thing unfolded. But I, in this book that Brian wrote, I say in there clearly, I was going to start the Western Design Center in Pennsylvania on July 4th, 1976. Magical freedom of technology for humanity. That's what I ended up doing, but I had to wait 2 years.
Okay. Okay, so that's that one. So what application usage of the 6502 are you the most proud of? So of what people have done with that, I'm thinking in the time that it's existed, what would you be the most proud of? Oh, I lost your camera. Oh, there. Okay. I can't quite make out. What is that?
That's a pacemaker.
Oh my gosh. That's a hey, yeah, that makes a lot of sense. You know, it's funny. That just made me think about something from 30 years ago. I was working at a company, and I was in the shipping department, and a FedEx driver was dropping some stuff off. And FedEx is, they were back then in the 80s. It was like unheard of that you could deliver a package overnight. And so I asked them. I said, do you guys ever run red lights and speed excessively or things like that to get in on your deadline? And he gave the most profound answer. He said, when we have human organs, and that fits in with what you're saying. So the only priority was human life, and your pacemaker it's the same, it's a similar answer. That's interesting.
There are millions of people that talk about personal computers. Doesn't get any more personal than keeping a human alive 1 heartbeat at a time.
I agree 100%.
Now, there's another quite proud of, and the Commodore folks probably aren't going to want to hear this.
Uh-oh.
any company that goes from a little processor to the most valuable company on planet Earth, if that you can't be proud of, then I don't know what you could be proud of. So there's two ends of it.
Who are you
One is,
talking about, Bill?
oh, I didn't use the name, the Apple.
I know
But
you
the
meant.
Apple used my processors in the ones that I designed when I was a designer of, one of the team members of, just so we keep this politically correct. I was one of the design engineers of the original MOS 6502. Okay. That company that I'm talking about, Apple Computer, used that one. They used my CMOS, the one I have hanging up here. They used that in the Apple IIc and the Apple IIe. And they used my 16-bit that I've got on this board on in the Apple IIgs. Because it was used in the Apple IIgs, Nintendo used it in the Super Nintendo. So they went from the NMOS 6502 in the original NES to the Super Nintendo using my 816. So that's why Apple is my favorite computer company, except that because they killed the Apple II, I don't buy any Apple products.
Can't argue with you on the Apple thing. I am a Commodore fan, I'll admit, but I certainly am an Apple fan also because I appreciate what they've done. As I was a TRS-80 fan back in the day, I mean, they made a fabulous computer too. Not the same processor, but still, the three computers that came out in '77, they definitely changed the world. I do have another question. How did your Western Digital Center acquire the 6502 IP when MOS Technology was presumably the original IP holder?
Oh, good question. You know, they sued me. You know, they
No,
settled.
I didn't realize that. No.
I was sued coming and going from MOS Technology, just so you know. The IP and what happened, there was a question earlier about the lawsuit, Motorola and Harry. Harry didn't know all the details. But, and I'm not saying I know all the details either. But the whole thing was about patent. We were signing, as we were designing, the 6502, we were signing the applications of the patents that we were violating. I mean, come on, give me a break. I mean, we violated every patent that Will, Chuck, and I had on the 6800. I don't think Ray had any patents on the 6800. I think he and I might share a patent on the, well, I'm not sure. It could be we share a patent on the 653032, but I'm not sure about that. But anyhow, let me go back to something. I didn't use, and we didn't use any of the IP from the Motorola 6800 design or the PIA design. We used the patents. Only way we could do those chips is to violate our own patent. So that means that the IP is what you know as a semiconductor engineer, how to design chips. That's what Xerox hired me for when in December of 1980, 80. And so the magic is understanding everything from the sand to the systems. That's the tall, thin man that Carver Mead talked about. That's me. Now, there may be others, but this is what Chuck recruited me for to design his idea, which is the 6502, became the 6502. So when I left MOS Technology, I didn't take anything. And I didn't know that anybody took what Terry took. I couldn't have taken what Terry took. Well, I was going to be sued by MOS So I can't have any of their stuff. So when I got sued by Commodore, when Jack was thrown out of Commodore in 1984, that's when, I don't know if it's Charlie Winterbull or who it was that came from CES to settle the lawsuit that was going on for a couple of years. That's when they discovered everything I had. They didn't have a leg to stay on. That's why we settled, and they paid me. So I went through all of this discovery. They for 2 years or whatever it was. And when we settled, then Charlie, if it was Charlie, I don't know who it was. I was reporting to Bud Fry in California, but Charlie Winterbull may have been back there. When he came to visit me after we settled, it was a 5-minute settlement. And that's because he wanted to talk with his lawyers. He had a big law firm, but they were not nearly as competitive lawyer-wise as Brown and Bain. Brown and Bain was the pinnacle of lawyering worldwide. Jack Brown, I could go on and on. So what happens is when we settled, then I told him, here's what the deal is. And I don't know if I did this before in a video, but I go like this. Do you want to settle or not? And he's sitting across from me, and I have like 3 lawyers for GTE there. I have 1 lawyer. He's sitting here. Joseph Mott is his name. And he had a couple of lawyers, and Charlie or whoever was there from Commodore. And I'm doing this to, like, come on. Do you really want to settle this or not? And if you do, here's the deal. I hadn't reviewed any of this with my lawyer, Joseph. And I said, so here's what the deal is. I'll cut my normal license fees in half for the 02, the 22, 21, whatever you want in CMOS. You pay for your lawyer's fees. I pay for my lawyer's fees. But the one chip you can't get this way at 1/2 license fees is my 816. He says, oh, we're going to go with the 8086 or whatever, so we don't need your 816. Okay, all right, well, then it's the deal. He says, okay, could I have 5 minutes? It could have taken 10 minutes. So me telling this, then he leaves for 5 minutes to go talk with his lawyers about it. GTE lawyers say to Joseph, I've never seen anything like this. Are you crazy? Now GTE was they were suing them too. And so they had something, that's why they're in the meeting. And so Joseph says, no, no, this is all Bill. And Joseph's like, they're spellbound. Charlie comes back with his lawyers and says, hey, we'll take the deal. So I've never been to your office. I don't have my rental car. Would you take me to your office? And then I've never been to GTE's offices. Would you drop me off there? I said, absolutely, Charlie. We're good to go. That was the settlement. After 2 years of their trying to discover that I didn't use any of their stuff, even though I knew it. And that chip right there does not violate my own patent.
Wow. That's something. I definitely didn't know any of that story. Let's see. We have a few more things coming in. So kind of more licensing and patenting things. Did Nintendo procure a valid 6502 license? Their NES CPU was missing the patented BCD.
Okay. All right. So the original NES was actually, this is where the history of it, Commodore left. I don't think Commodore had their eye on the ball. Okay. Because.
Is this before or after Chuck left?
Yeah, probably. So what happens is Rockwell gave Ricoh the design of the core. So for many years, I was on the Christmas mailing list. I had my Christmas mailing list and this guy in Japan. He is the guy that actually designed the NES and the Super NES chip set for Nintendo. So he and I visited his office once, and he was in a new world that for Japan was a totally new world because he struck out on his own. I mean, how many companies, usually when you work for a Japanese company at that time, you never left the company. It didn't fit their culture. Right. So what happens is the NES that used the NMOS core was gotten from Rockwell. And I don't think it was legally gotten, unless I don't have their license agreement from MOS. But if I were MOS or Jack, I would have said, how can you be using the NMOS core? Because that was built out of the NMOS core. So then what they did to create the custom chip for the NES, this design engineer, I forget what his name is, he probably said, somebody said, we don't want to mess with the decimal mode. And guess what broke up the asteroid game at Atari when I wanted to sell them the CMOS version? I put one extra cycle when we're in decimal mode. That's how I could avoid my patent. But they couldn't use the chip because the asteroids would break up. Because how that worked is each raster scan on the retrace time, they were doing some updating of the scores. And if you use decimal mode and it took on the CO2, it used one extra cycle, it broke things up. So that's why it didn't work. So now let's go back to something. I licensed Ricoh exclusively to supply chips that used my 816 to Nintendo. Ricoh invested $500 million, which isn't much these days, $500 million on a fab for the Super Nintendo. And that's why they wanted an exclusive. So Ricoh and one other company has an exclusive on the use of my technology for specific markets. They only were protecting their market opportunity with Nintendo. And so I'm willing to do that because I'm saying generate a whole bunch, but I got a royalty off of every one of those suckers.
Okay, so let's see. Did NEC Hudson collaborate with WDC on the major changes made to the 65C02 to make the HU6280? And it also continues, it powered the TurboGrafx, aka PCE. Did Sony pay you for the SPC 700 or claim that it was a new design?
Until this show, I didn't know those even existed.
Oh, okay.
So in other words, there's something going on there. And remember, I just said that a piece of paper is all I did to protect the family jewels, right?
Right.
Now, you know how many people in this world, with everything that's going on in this world right now, how many people would do that? They usually keep pieces of it. It's just like when you were talking about software protection or encryption codes. Some would say that you can't run a business the way I was running it because I was trusting that the people I licensed would stick with the agreement. Well, is it possible that somebody gave my design to them as the starting point? You know, I don't know. I mean, right now I'm saying I believe there's only one. There were actually two companies that ever violated my agreement that I'm aware of. One of them was AMI in Pocatello, Idaho. Whoa, the second source of the Motorola 6800. And so that's a whole nother story. but that company wanted to hang on to my design after they weren't going to license it. They wouldn't send my technology back, even though they weren't going to license it, because I had even a free license to evaluate my technology because I knew how good it was. I knew how awesome it was. But after they received my technology, all of my source, after they received that, and they said, well, we're not going to license it. And I said, okay, well, let's just send everything back. No, we don't want to do that. We want to validate our design, but we're not going to use your design. Well, how can you validate your design without using my technology? And that's where, and we left it there. We never, usually those things end up, the lawyers make the money and everybody else pays them. And then at the end of the day, you kind of walk away. That's what Harry was saying. I didn't know the $400,000, the lawyer's fees. But if you see what's going on here, if NEC had it and Sony had it, that's news to me. And so there you go. I'll check it out. But I don't know. So when you have a design that's fully documented in a data sheet, I don't know how many clones there are. 6502.org has a whole bunch of clones. And I know that a company that sold probably at least 1 billion games, you know, these joystick games that you get, they've sold at least 1 billion of those.
Yeah.
Okay. Well, anyhow, that company is in Japan. And they acquired a company that had a, how about this? Not a clone, a non-WDC version. So there's lots of these. I think one of the people that were going to come to VCF East in April from Russia, they have one from either Russia or China or something like that. So there's lots of opportunities. The 6502 will be manufactured forever, even if I'm not around. And even if my company's not around, which I'm planning to keep around forever. So you'll be able to buy 6502s and 22s and 21s forever.
We're happy about that.
Well, I'm glad. I like your smiles.
Yes. And we just, not just because we're Commodore guys. I mean, we appreciate.
Well, you know, that's a two-way street. I'm smiling big too,
right? That's right. Good point. I think the questions are tapering off. I'm not sure we have anything else right now. Jeff, you have anything you'd like to share?
I think this is a good point to wrap things up. Bill, thanks so much for your video. It's been great that you did it for VCF West and now for VCF East. A lot of it was important because of the history, to preserve the history while you guys are still around, because you guys are dropping off one by one. We want to document as much as we can. And again, it was about the, honoring Chuck Peddle. I did try to put the video of Heat 6502. It didn't quite work out the way we wanted to. It wasn't easy to turn there, but people got the message. They watched the video and they showed us. But remembering Chuck Peddle, because it was a great processor and it was a great team that helped him to put it together. But thank you again. And again, I'm going to invite you back to VCF East and hopefully a live show in April 2021. And we'll do part 3. And I think part 3 will be more about what WDC and the chips that you're making there.
Okay, I would like to say something about Chuck, since
you
gave Harry a chance to talk about Chuck.
Yeah, go ahead.
Chuck was a magical soul, one of a kind. There are things about that story that would take a book to actually come across or get across. The interesting thing is, I have an office at 2166 Brown Road. You can Google that and find out where it is, maybe even get a street view of it. He is the only person that actually lived in that office in the last 40 years. He lived in that office for 6 months. in the middle of all of my IP, while we're designing a flash controller chip. So that speaks, I think, should speak volumes for our relationship. Now, what's interesting, he actually has family in Phoenix at the time. Yet he chose to live at my office. But we cut a deal on that he wasn't going to take showers in the office. So he joined an athletic club. So every day he would work out and get a shower. So he never took a shower ever, but we have a refrigerator, coffee maker, and all the other stuff. So he lived there. And so when David Gray, who works for me, David Gray is magical. David Gray is the guy that's making things happen for me. He's the one that fills the orders. He's the one that gets the wafers manufactured for me. He does all that detail. He's also my website designer. Okay, so Jack of all trades, actually it's a Dave of all trades. So what happens is when David would come into work, Chuck would be there. I don't know that he woke him up. I think Chuck went on a run or something. We still have his sandals or his little penny loafers, I guess. And he actually has some of his change in his penny loafers. I mean, just thrown in there. He also used, I just found this out. He used to carry, a dowel that goes into an 8-foot closet. They're about 1.25 inches or whatever. He cut that in half and he'd carry those when he ran because he was attacked by a dog one time someplace in Russia or something like that. And he didn't want to run. But can you imagine with 4-foot pieces of that dowel, one in each hand, is how he jogged around Mesa. I just found this out the other day talking to David. And he said, I said, wait a minute. He said he had really strong hands. So Chuck was a magical soul. And he actually created some of the confusion because he respected what I did, but he didn't know what I did. So that's why in the back of that book that Bagnall wrote, I'm a 6502 artist. I'm not a co-inventor. I'm a 6502 artist. And as you heard Harry say, he's an artist. So he's the one that actually did the drawings on the Mylar to create these. So how does Bill get to be a 6502 artist? That's the part of the story that's in there, but you have to almost decode it. And so he wants to be the architect of the chip. And I like to say he was the architect of the instruction set. I'm totally, but he's also a co-architect because I know Rod had parts to do with that because of our experience with the Olivetti and the 6800. Now, if you look at when Chuck showed up at Motorola in 1973, I was already there 2 years. I was already doing these things. I designed a process, an ECL process in 3 months. I know how to design processes. I designed the rule set that everybody that I license uses and is higher yielding than their own process. I could go on and on about how that's possible. But the point that I'm making here, that I want to make about Chuck is the one that led the team in his interesting style that just is somebody you want to be around. I just wanted to be around him. And even though, the truth be known, he was a master manipulator. But think about Steve Jobs. Talk to me about Bill Gates. Talk to me about some of these other people
to get
that
the job.
end up being, look at Zuckerberg. I mean, all these guys, right? All these guys.
Does Chuck fit into that category?
Yes, he's one of them. And what I'm getting, the only thing is, he was self-defeating. He never really got.
I'm sorry, I meant to say, does Jack fit into that category?
Jack fits into that category big time. But Jack did never have a relationship directly with Wall Street, from everything I know. Now, Irving Gould might have, but I'm saying Irving couldn't put it together. So what's magical about Steve Jobs and why it became the most valuable company on earth is because Steve Jobs is a magical soul. Incredibly, he was. And so Chuck fits into that category. The fact that this book here is written to promote Chuck as the father of the personal computer business, I think it's got some really valid points. I mean, did Bill Gates design a microprocessor or the instruction set up? No.
Nope.
Did Sophie Wilson? No. She never really got anything other than a 6502 out into the market, from what I know. But all of these kinds of things fit together. And so I really think that Chuck was the father of the personal computer industry. And I really think I'm the mother, because I gave birth to it with my friends, and that's who's on the team. And that's what Jennifer put together. And Jennifer discovering all that stuff in a filing cabinet that her father had, that's out of storybooks. You can't make this stuff up.
Yeah.
This is awesome. So I couldn't be more happy to celebrate the roots of the 6502 at MOS Technology with Harry, Mike, Sid, Rod, Ray, Terry, Will, and if I miss someone,
Chuck.
It's unintentional. Though that was an awesome opportunity. And Rod, my relationship with Rod goes way beyond anything written. That bet was something that was made because we had 2 weeks of conversation and talking about things and drinking beer and other things, waiting for the chips to come out. And that's why, hey, why don't we have a bet? You think the 6501 is going to outsell the 6502? I'm good with that. Yeah, it's not going to plug into the 6800 socket, but hey, you think that's going to win? I'm going to go with the 6502. And that's all that was to it. It wasn't that he designed the 6501 without the rest of the team. No. Or I designed the 6502 without, no. It was the same chip, just with a different metal layer. And there you have it.
Thank you.
Bill, it's been a real pleasure and honor to speak with you and get to know you. And I just want to say thank you, very heartfelt thank you for this time and for everything you've done. And I'm going to hand it off to Jeff.
Okay, well, thank you, Chris. You're welcome. And thank you.
One more thing about Chuck. Someone asked me a question about an invention that he had made, and I wasn't sure. They said, did he invent the USB 3? And if you just Google Chuck Peddle patents, he did patents all the way up to 2018 in some things that we use now. So I encourage people to look that up to see the stuff that he continued to make different patents through the rest of his life after the 6502. So it wasn't just that I mean, these are things that maybe they're not as sexy as 6502, but they're still important things that he continued to create that we use nowadays.
Well, actually, what he did, what we were working on. So somehow his coming back to VCF 2007.
Yeah.
He must have come to WDC after that meeting. And somehow I think he got a new respect for the 6502 that you would have thought he always had.
Oh, interesting.
He has page mode patent. And if you check out page mode patent, what you'll find is that he could repair a flash memory, or he did this on DRAMs. So he would buy DRAMs and repair them with a thing called page mode. He got the page mode patent. So when he came to WDC in 2007, it's around May of 2007 is when he visited me. We went golfing. And what happened was, we're at the country club, the Superstition Mountain Golf and Country Club, where I'm a member. And what happens is we golf, and then he comes back, hey, Bill, I want to talk to you about something. And that's when he talked to me about his USB flash modules that he was going to build in Sri Lanka. That's where he was building his dynamic RAM modules that he was repairing.
Yeah,
So
he
he
was
got
about that. He was in Sri Lanka at VCF East in 2007. Yep.
Yeah. So what happens was he is talking to me about the FIFO that he actually had a design. Actually, he bought microcontrollers that had an 8051 in as the core of the flash microcontroller that had a FIFO in it. So what happens is he's talking to me about this 8051 controller he has that he wants to remove the 8051 and put in a 6502. I said, oh, that's a good idea. And he says, I will, what I'm going to be selling these. I'm going to get them from Micron and Toshiba. And I don't know if there was Hynix or whatever, whoever was in the business of flash memories, he was getting failed die, and then he was going to repair them because a sector is 100 times bigger than a page. There's like 100 pages in a sector, I think. And so what he was doing was repairing them. That says their spec said that if they had so many sectors fail, that they had to fail them. Well, he was going to repair all those failed chips by page mode. So that's why he came to me. And so then I said, well, why don't we just do a DMA from the flash memory and we put that in a buffer. And then if you're bidirectional or duplex, we could have double buffering so that you could be transmitting one to the PC from one buffer while you're filling it up from the flash. And then if the other direction, if you're receiving a buffer full from the PC, then you could fill that buffer. And then once that's filled, then you can store it in the flash memory. So you're just managing 4 buffers, 2 in direction. He goes, nobody's doing that. I go, why? I mean, isn't that the right way of doing it? He goes, yeah. And I go, well, why don't we do that? You can get IP, just go online and find the IP for the DMA for the 82, I think it's 55 DMA controller from Intel. People made a copy of that. So we started with that. And we go, oh, that DMA just doesn't work. So that's what we did. So we created the DMA for page mode, which is a special DMA. That's what we did for Chuck. But then Chuck went off, and now we had documents signed and everything. He was going to pay me 10 cents per flash module. I'm thinking, that works. I was only getting a penny or so from the game systems, and I get 10 cents. That works for me. How many are you going to build? He says, oh, we'll probably build 2 to 3 million a month. I go, 2 to 3 million a month. That works. That works for me. I can do that. So I never got 1 penny from him for all of that work. We worked for years. And David Gray was a co-inventor of this. Another guy that works for Microchip, worked for Marvell. He knew all about USB. His name's Corey Walton. And so Corey, Dave, and I, along with Chuck, were the co-inventors of that patent that you're looking at. So when we found out that Chuck filed for the patent with a lawyer in Salt Lake City, he already sent in to the Patent and Trademark Office the provisional patent, and they were about ready to get the real patent when I caught wind of this, because Dave Kramer, who was working for me, Googled and said, hey, look at this. Chuck's got a patent on that work that we did. And he used the information from our copyrighted data sheet on that. So if you look at that data, if you look at that patent that Chuck filed, so then I'm going, and then I get an email from the patent attorney from Salt Lake City saying that this is the way that the patent office works. If it's filed without proper identification of the inventors, you can't refile it. I'm going, oh, wait a minute. Oh, so in other words, I sent him all the signed agreements that David Gray, Corey, myself, and Chuck were the co-inventors of what he filed a patent for. So then I go, oh man, so if I file some document with the patent office, then nobody gets a patent. And I say, well, wait a minute, Chuck's got the page mode patent, which I'm not on, But in order to implement the page mode for flash memory, we need this new patented concepts that David, Corey, me, and Chuck did. So then I'm thinking for it. It took me a while, and then I go, oh, I know what. I'll get. We agreed on 10%. I would get 10% of any license fee. This is an agreement. So, but the patent attorney in Salt Lake City did one thing extra. He said, you have to get a notary to sign that they witnessed each of us signing this agreement. So I have a patent royalty agreement. The patent is Chuck's, assigned to Chuck, now his estate. But what's interesting about that is that in that patent royalty agreement, I would get a royalty if his estate ever gets anything for that patent. And so I know somebody that invested in that, and so we're communicating. But right now, the dust is still trying to settle on his estate. So there's all kinds of stuff, and that's the story about his patents. And so actually, on that last patent, I have a patent royalty agreement on.
Nice.
I just want to say a few of us are going to be checking our mail for our 5 gigahertz 6502.
Oh, yeah, there you go.
All right, Bill, we got to wrap it up. It's getting late here for everybody, but I really appreciate that. And I look forward to inviting you to VCF East 2021 and doing another talk. See you in person. We'll talk about that later.
Right.
But I appreciate everything, and I'm sure we've been having a lot of visitors. And right now, we still have about 100 people streaming and still watching you. So it was like about that pretty consistently all day, between 100 and 160 people. So thank you for everything.
You're very welcome, Jeff. It's been a pleasure communicating with you and doing this, and thank you for the invitation for next spring. Looking forward to that. Good excuse to come back, see family, and hang out and see what that museum sounds awesome.
Yeah,
And,
come see our museum. There's lots of. I'll give you a tour.
Yeah, that'd be awesome. I know my wife Diane and I will enjoy the tour. So stay safe, and thanks again for inviting me to do this. It's been a total pleasure.
All right, thank you.
Very good.
All right, have a good day.
All right, thanks. Bye-bye.
All right, everybody, we're approaching the end of VCF East 2020. I want to thank all the exhibitors, instructors, the presenters. We wouldn't have this show if you didn't have those videos and these guys, all of you doing this. You're the meat of this show. I'm just the guy that pushes buttons and points. Thank you, Chris Fowler, for the questions. And Andy Diller for running the OBS streaming to YouTube. That was very helpful. This is a team effort. Corey Cohen for running the camera work with the exhibitors and all the exhibitors that are coming here in person. That was nice to have like about 6 exhibitors here. Adam Michelin to doing the social media promotion. He's been doing a great job with that. Bill and Doreen, always here, the last guy here to help me out with everything. Marcus Merritt for coming in Friday, helping to clean up this place, get it ready. Jason Perkins for working on the Xerox Star. That was a great demo. And CDL, Computer Deconstruction Lab, for giving us this space. This was fantastic. It would have been a lot more difficult to do it without the resources that they have here.
Yep.
And InfoAge Science and History Museums for giving us like all the rooms, the campuses, the building, everything. This is great. Gives us the ability to be able to do this. So we did our VCF East 2020 virtually. I didn't want to cancel. Someone said you should cancel it. Just kidding, it's going to be a problem. I said no. I'm going to still go forward. We're going to have a great show. And just remind you, you're a nonprofit 501c3. So anything we get in is, tax deductible, and so we're put that money to our museum, put that money to our warehouse. We're working on climate control for a warehouse. We're still selling our T-shirts. While they're available, get them while they're still available. Not all of them are available, right? And he's showing off polo. We're gonna have those for sale soon. Those are hand embroidery. There's someone in Brooklyn, in Oregon, who does our embroidery. So this is the hat. We had the hat. I don't know which one, guys, you like. That was the original design, and that was another prototype. And then the one I'm wearing now, I think that's the one
Sharp looking.
That's
Yep.
really sharp looking. We have some local events coming up. We always do repair workshops and our swap meet. We're working on that. And last thing, VCF East 2021. We plan on doing it April 9th, 10th, and 11th. Cross your fingers. Hopefully things are better in 5 or 6 months or so. And the theme this year, drum roll please. Things, one for hardware, 4004 chip / 8080 chip. Those are the first two that Intel made, the first and second chip. And the second one is text adventures. We're hoping to get Scott Adams because that was a fun thing to do. So those two themes, you don't have to do those, but a lot of people will do, because it's the anniversary of IBM PC, the 5150. The people want to do that as a theme, that's fine. But we want to drive those as a theme, try to get some different things going with that. So that's it. April 9th, 10th, and 11th. VCF East 2021. So I'll see you guys then. Any last word, guys?
Good.
Great to be here.
Yeah.
Thanks for everything. Good words, Jeff. Lots of thanks in the chat. Thanks, you guys. It's been great to do this for you. Andy? All right. Thanks,
Goodbye,
Jeff.
everybody. This has been fantastic.
And thanks to Jeff. I don't know if you're saying all the thanks. Thanks to Jeff helping us keep it all together.
Yeah. All right.
All right.
Good night. Good night.
Enemy is an option. We all listen, now we go down and start.